morning, everyone. Now the time has come to start it officially. So we are ready now, right? So let me invite the director of SNBNCBS Center, Professor Tulusri Shah, who is one of the alumni of the center, to formally inaugurate this alumni meet Impact 2022 and deliver the inaugural address. Professor Shah, please.
Very good morning and a warm welcome to this Alumni Meet Impact 2022. And I could actually see that many known faces and all very excited, online, offline, and with a lot of chatting. I'm equally excited because, as has been mentioned, I have a dual role here. So I am an alumni as well as, the director of this institute. So I have a dual role. But I'm as excited as you. And this idea of having alumni meet, it started a few years back, and it started in a small scale. And after that, the pandemic hit us, and there was not much activity. So we thought this time we should again restart this activity. And it's actually very, very pleasing to see that in spite of the fact that this center is only 36 years old, there are so many alumni who are well placed, well established in various different institutes, universities, IITs, ISERs. This is really very gratifying. And we have tried to reach out to as many as possible. Of course, this was done in a rather short notice. So if we have not been able to reach out to any one of you, our apologies, and next time it will be rectified because we will have more time for preparation. And as you could see in the poster, the whole idea is to showcase our achievements because our alumni are our achievements in order to encourage the young students who are currently in this institute so that they can be confident that they can also reach out to those heights. So that's the main idea. So in your talk, whatever short talk you have, more than the science, you try to address your journey to encourage all the youngsters who are there listening to you. And we have a panel discussion where there are few panelists, but the panelists will just start the discussion. It is the audience to take the discussion. So I personally look forward to suggestions from all of you how to make this alumni cell more proactive, more useful. So with that, I will don't want to spend more time. It's your day. So please enjoy the day. And once again, a very warm welcome. And I do hope that next year, all of us will be here in this campus, enjoy, chat face to face. We could already hear some of the interesting conversation. If you are face to face, of course, it becomes much more interesting. So thank you so much for all of you participating in this short notice. And once again, a warm welcome.
Thank you, Professor Shah, for your exciting and welcome note. Let us begin. My solemn duty here is to provide a welcome note. I myself is a guest here. You are the host because you are the assets of SNBNCBS Center, and SNBNCBS Center is your alma mater. So, what I could do, probably profusely thank you for your spontaneous participation and your exciting participation and exciting talks that already initiated. And I'm just guessing, if you could come here in person, how it would have been. Maybe next year, many of you, if not all, would come and grace the occasion in person. It will be very exciting, very moving. The students here, juniors, will be inspired by no limits, and you can also tell them what are the difficulties and what are the opportunities that are lying ahead in their future path. So I would make another request. It's a extension to the list or to the wish that our director has already expressed to you. My request would be to all of you that we might have missed several of the alumni of SNBNCBS Center because we do not know their current address. So if you really extend this our network by sending those people whom you think that we have not been able to reach out this email, and if you ask them with a request that could you please send a mail to this address informing what is your current position so that we can tabulate their names and update our list of alumni. So with this, I again warmly welcome you on your own dais, on your day, and in your alma mater. So let us start the technical session with this. Maybe we need 2 minutes or something like that to start the first technical session. Okay, so give me 2 minutes, please. And the first speaker would be Aftab, followed by Arnav, then Sukhadip, Malloy, and Vishwajit. So please, give me 2 minutes. So, Aftab, you are ready?
Yes.
Okay. So, if you want to share something, some slides or something like that, you can do that now and start your.
Okay. Sure.
Okay.
Yeah. Is my screen visible?
Yes.
Okay. Hello, everyone. Good morning. And let me first thank all the faculty and student members who have taken all the efforts to organize and facilitate such a nice platform for a comeback and reinvigorate the bonding between the present and past researchers of SNB. I strongly feel, as Tanushree said, that the actual fun of such an event lies in the physical attendance and meeting all of you in person. However, due to some academic commitments, including teaching first-year courses, I could not make it this time. Also, I have to travel to SNBNCBS next week for another kickoff meeting. Nevertheless, let me quickly start and try to squeeze my 15 years of journey after SNBNCBS in 15 minutes, because that's the time given. Myself, Aftab, currently in the Department of Physics, IIT Bombay. I had been at SNBNCBS between the year 2001 and 2006 doing my PhD. These were those glorious days when we used to have a small group of research scholars. In fact, when I joined SNBNCBS in 2001, there were only a handful of, I guess, 30 to 35 research scholars, which makes it a close-knit family and facilitate a strong synergy amongst the seniors and the juniors. And I can't forget the instrumental, teaching from several faculty members. Some of them I can recall: Professor Mani, Professor Mukherjee, Amitav Lahiri, Tanushree Sahadas Gupta, and so on. Okay, let's look at my journey at a quick glance. So after completing my PhD in 2006, I went for a postdoc to University of Illinois at Urbana-Champaign, USA, and was there from 2007 to 12. After that, I moved to Ames Lab, where I worked as a senior postdoc and research staff for some time. 2013 was come back to the country, and I joined as assistant professor in Department of Physics, IIT Bombay. Got a joining offer from few other places also, such as IIT Kharagpur, IIP. In 2017, got promoted to associate professor, followed by a full professor early this year. So this is an old picture involving several of us, and I think during some event at the institute, and I can spot few of the friends from my batch. Ankush is there, Somen, Kuldeep, and myself. Devashish and Prasad is missing, I think, here, who are also another batchmates of mine. In the top row, you can spot some other people like Abhishek, Saurav, Ayan, Arnab, Arjo, Maloy. We also have Sunandan down there, then Mukul, Joey, Korabi, Tapati, Abhishek, and so on. So I did my PhD under the supervision of Professor Mukherjee. My dissertation title was Phonones in Disordered Alloys. It was a great opportunity to work under his esteemed supervision. He has been a phenomenal in guiding not only physics but different aspects of life. His lectures at Presidency College, where I did my master's, were truly instrumental. His constant support and encouragement has always been very, very helpful. Unfortunately, he is no more with us today. Let us all pray, may his soul rest in peace. In fact, it was his phenomenal training and teaching which motivated me to write a detailed article on phonon transport, which was published last year, and it's just a small token of appreciation and dedication to him. Some of the other activities at SN Bose, I couldn't track any pictures of that duration, but some of these I still remember: freshers welcome, farewell parties, blood donation camp, toys. Once in collaboration with Saha Institute, and once solely by us. Barbecue party, being a part of Students Forum, and Star Party, which we used to organize every year. So after completing my PhD, I moved to UIUC for a postdoc. And some of the topics which I worked over there are electronic structure and phase stability of alloys, spherical to full potential methods, which involve several levels of code development, materials under extreme conditions, and I worked with Dwayne Johnson there. UIUC is one of the finest places to work on material science and physics of novel materials. And, I actually got an opportunity to interact with several renowned researchers over there. UIUC is actually known to host one of the largest number of Nobel laureate faculty members, I think 13 as of now, involving Burdine, Cooper, and Schrieffer for BCS theory, Anthony Leggett for superconductors, Josephson for Josephson effects. Later, I moved to Ames Lab for another senior postdoc, and later I had been serving as research staff. The appointment was a combination of Duane and Bruce. Duane actually moved there as well during those times. And some of the research topics that I worked on during that time involves quantum phase transition, iron-based superconductors, rare earth magnets, etc. Ames Lab actually has some of the pioneering experimental groups involving Schneidner, Paul Canfield, Adam Kaminsky on RPACE, and so on. So I got an opportunity to work with all some of them there. UIC is known to host one of the largest. This is already done. I mentored 2 PhD students there. Then I moved to IIT Bombay in 2013. These are some of the things over the academic journey. Some of the areas which I started working after moving to Bombay involves spintronics, photovoltaic, and thermoelectrics. From 17 to 20, I got a promotion to associate professors, and there are several committees and the awards which were awarded. Some of the other areas which I worked on during these periods involved topological materials, high entropy alloys, photocatalysis, and water splitting. In last month, 2022, I got promoted to full professors, and some of the group details are here. So there are 3 postdocs who have already completed, 4 are still working on. There's a DST women scientist in the group. 4 PhD students has graduated. Some more are about to graduate, and some are working. So, in a nutshell, the research of my group, revolves around some of these topics, as you can say: thermoelectric, topological materials, photovoltaic, magnetism. There are some efforts on the code development side also. So the group really works on fundamental understanding of these topics. There are strong experimental collaborators across various engineering and science departments. There are efforts to develop new methods and codes to better understand few key phenomena. For example, carrier relaxation time, phonons and substitutional alloys, and so on. We actually recently signed an MOU between IIT Bombay and SN Bose with the kind help of Professor Saha Dasgupta and Anjan Bauman. So this was signed in March, and there are several activities which are in pipeline, such as exchange of students between the 2 institutes, combined PhD program, organizing combined conferences, and so on, writing research proposals between the expertise in these 2 institutions. And last but not the least, these are some of the funding agencies. IIT Bombay, NCPRE is a very concentrated center for working on photovoltaic research. SERB, BRNS, who had been generous enough to support financially over the last few years. Thank you.
Thank you, Papa.
Thank you.
Any question here? I don't think there will be any question, but you can always ask him anything if you want related to the career development. 1 or 2, anyone from on-site or offline? Papa would be happy to interact. Anyone? Raise your hand, please. Looks like no. So let us move to the next speaker, who is Arnav, Dr. Arnav Saha, Assistant Professor. Arnav, please.
So after seeing the talk from After, so organized, a bit tense now. But anyway, I thought that it was kind of important. But anyway, thanks a lot for the students, faculty, support for this program. And, so we are the integrated PhD third batch here. And we were full, like 10 students were there. And if I'm not wrong, this batch everyone remembers. Maybe people will say. Anyway, so we started doing MSc here, and we got wonderful team faculties. And I must, so it is kind of crime if I not say so. People not mention people like Vidya. Rai, Abhijit Mukherjee, teacher, then Surajit Shanguta, very sadly, very sad. And then teachers from, so it was a program, I don't know how the program runs now, but it was a program where the faculties from other institutes, renowned faculties from other institutes also joined to teach us. Some of them are very, very privileged to have their classes. For example, Rajkumar Mitro from SIMP, then Room Chakraborty again from SIMP, then Janta Bhattacharya from ISS, and eventually he was my PhD supervisor. Then later, actually, so we did MSc from 2003 to 5, and then after 5, I took the joint PhD position with Professor Janta Bhattacharya and Professor Project Sengupta. Then I did PhD and I submitted in 2010 July or something like that. And then it was a nice rule that time that if you submit within 5 years, you will get a 1-year extended SRF position here, where which you can utilize to have a further positions like postdoctoral positions, find something like that. And that I utilized and I get first postdoctoral position in Max Planck Institute, Physics for Complex Systems in Dresden. So there I spent from 2011 to 2014 February there, and from 2014 to 16 I was in Düsseldorf University. So in this 5-6 years, I did soft condensed matter physics. So basically, I started doing non-equilibrium statistical mechanics related problems with Professor Janta Bhattacharya. Then, so it was like 1997, 8 onwards, there was a kind of discovery, fluctuation theorems, stochastic thermodynamics. So it was very new, and it was sort of so I was just getting some article going through archives and all, and it was kind of independent search apart from my supervisor. So then I took some papers and went to supervisor and see I saw these papers, whether we will be interested to guide me in these problems. So it was quite amazing to me to see that he was doing something different. I don't know that maybe post condensation or something else. But he immediately says that okay, you go ahead, I will help you. It's no problem. So then he encouraged me a lot to do this kind of problems. Because then it was very, very new. And today also people, not much people in India does that. Many people got experiments, etc. They are doing. But at that time also, this time also, that topic is quite new. Because then it was very new. And I worked on that with the encouragement of my supervisor, Professor Janta Bhattacharya. And then it was very easy for me to collaborate with other people. For example, another person from IOP, Professor Helmholtz, who also passed last few months back. So the thing was like I was very, very privileged to work with many people being in this institute. First, Professor Janta Bhattacharya, then Project Sengupta with molecular dynamics and ground dynamics simulation. Then again, Professor Alumni with again stochastic thermodynamics problems and all. So this was very easy for me to approach them. So these are very learned person, highly proficient scientist, but at the same time they were very approachable, I would say. So I talked to them, I interacted with them, I learned a lot from them, and then I moved to Germany, Dresden, Physics for Complex Systems, and there I started again a different topic, not different, but kind of application of non-equilibrium thermodynamics, which is biological systems. So there I found that how experimentalists can intensely collaborate with theorists and vice versa. So there actually I had a joint position like physics for complex system president, and there was another max plan called cell biology and kinetics. So apparently when I was here, to me it was like physics, a different subject from biology. Okay? But there I find that in the same table, same lab, how a physicist can interact with biologists, how a biologist can interact equally easily with physicists. So this is very, very important to move science forward. So these days are interdisciplinary days. So these are the, of course, these statements are not for the proficient scientists, it's for students. That these are the like days for interdisciplinary sciences. So don't be like focused on a single topic, or of course you will learn, you will be master at some particular topic, but try to learn other topics as well so that you can collaborate with people. Okay. So these are the days for interdisciplinary science, and I learned it from there. That typically the attitude. So I have this. We do physics. We know maths, how it works. Okay. So why to talk to biologists? They don't know math. So this is completely wrong. Okay. They know what they. So they are very good at their field. So if you want to solve or want to approach some forefront problem, okay, then you have to talk to the people from other disciplines. Okay? Yeah, and you will learn from them by interacting with them. Then you know the problems from other fields, and then you can. Okay, so after this, after 2014, I again moved to Düsseldorf University, again a soft matter group, a theory and an experiment. So they're currently collaborating. So that time the experiment. So in Max Planck, the systems are biological systems. So these days we call, from this point of view, it's an active systems. And again, in 2014 to 16, so again the active systems, but in active colloids or active. So those kind of systems I have dealt with theoretically as well as talking with experiments. So now after 2016, I came back to India. I got a position in university. There I started to teach. So another section of my life. So I started to teach students. I try to motivate them in the same way that you learn first of all your topic, and then talk to other people from other disciplines, students from other disciplines, so that you can learn more. Okay, and there and so I was there from 2016 to 2020 beginning, and there I started a small research group. So I had one PhD student there. So he is going to submit thesis now. And then after 2020, I moved to Calcutta University as an assistant professor. So here I'm going to be now I have two PhD students, very new there, so I will try to guide them in the same fashion that I learned, talking to the many people. First we learn and then talk to other people, and their issues and problems, etc. So now my research is related to substance matter physics, active system, biological systems. So particularly, I'm interested in physics of living. So now there are many experiments. In India, NCBS is one of the forefront research institutes regarding this biological research. Also, there are other groups in India and abroad, particularly Europe, USA. There are many groups doing the physics of living matter. So the main theme of this particular topic is to see the biological phenomena in light of physics, in light of the rules or equations, theories of physics. So, for example, if I go a little bit, I want to be a little bit particular. So, say for example, cell division. Okay. So everyone knows on the basic textbook that what cell division is. So typically, the cell division is a biological process, a very complex process. But little by little, I would say, we can explain them in terms of fluid dynamics, active fluid dynamics. So it is not yet fully, so it is a far-fetched comment maybe that we have explained everything regarding cell division. No, it's not that. But there are many things can be done, can be understood in terms of physics, and see, there is a great advantage if something is learned in terms of physical rules or by physics, because immediately it becomes universal. So one example everyone knows, I guess, is an observation of long back, like 400, 500, or maybe more back, like all the astrophysical observations from Tycho Brahe or many other people. So they all come into a nutshell from like Kepler's law, and then you know that Kepler's Newton's gravity. Right? So immediately, if so this is the kind of holy grail, that if something can be understood in terms of physics, immediately it becomes universal. So if we know the Newtonian gravity, we don't need to like the orbits of Jupiter, the orbits of Earth are not very much different. They are different, but the physics is same. Okay? So that is the advantage of explaining something in terms of. So this is maybe a far-fetched now, but we want to dream. So without dream, no research can happen. So I would say that it's a complex biological process, orthogenesis, cell division, developmental stages, etc. Then starting from this to talking birds, swimming fish, their motion, their pattern formations, everything should be explainable from physics point of view. I've started already doing that, doing experiments on that, theory on that in various institutes, and I will be happy to talk to students. And so I'm not very far, I'm close by Calcutta University, so anyone interested will hear this particular topic discussed. This is my
Thank you, Arnav. As usual, maybe you can contact Arnav as he has invited all of you. We now move to IIT Guwahati, and we again thank Arnav for putting the stress on research in the overlapping areas of various branches of natural sciences, physics, chemistry, biology, and also highlighting the importance of theory and experiments going hand in hand. The next,
excuse me, may I just
you are, please.
Am I audible?
Yes, yes.
Okay. Thank you, Professor Biswas. Thanks to the organizers for arranging this meeting. And it was a pleasant surprise when I got the invitation. I had no idea that such a thing has been planned. And as Aftab told, that it would have been wonderful if I could be there in person. But in such a short notice, and with the courses still going on in IITs, it was difficult to make it. But surely I would love to be there on such an occasion in future. So I'm going to sort of make a small presentation, but maybe unlike Aftab or Arnav, what I'm going to stress upon is basically my journey, which was not a personal journey, by the way. It was a collective journey. The SNBNCBS Center is what sort of shaped me up. in some sense to where I am. It has helped me seeing perspectives, getting perspectives, and understand a lot of things which are academic and extra academic as well. And by the way, I have this distinction of being the first Institute Fellow of SN Bose Center way back in 1996. Aftab was talking about 30 students, right, during his time. In my time when I joined, there were probably less than 10, 7, 8, I can remember all of them. And all of them were CSI or UGC fellows. So I was the first one as Institute Fellow. So let me share my screen and let me keep on talking. So what I thought that I will be sort of telling stories about the journey of SN Bose Center, because with me, the center also grew up. And a lot of people do not know about the small stories, the development. So I will be more or less stressing upon that, and that I believe would be more interesting than my personal development or my positions and my research. Of course, I will touch upon that a little bit, but more on this. So it was, and things have happened to me in an amazing way. First of all, I never thought that I will end up in a place like this, because I had no idea that such a place existed in the first place. Okay, so it was 1995. I had just finished my PhD, MSc, and was looking for a place to go. I hope you can see my screen.
Yes, you can see.
So in this screen on top, you can see the picture of the center. It's taken from the internet, from the web page itself. And down bottom is my present place of employment, that is IIT Guwahati. Both places are kind of picturesque, but this is in SN Bose in 1996. When I joined, people were actually just shifting. So in 1995, when I thought I would be doing cosmology, and I was fixated on a particular professor in Jadavpur University. Unfortunately, he didn't have a project by then. I had a GATE fellowship. I didn't have a CSIR one, so I had to wait until I get he gets a project. Meanwhile, I was trying this place, that place. It wasn't really working. And then one of my peers, who was a student in Saha Institute, by that time he was doing a postdoc, he said, why don't you work with Professor Abhijit Mukherjee in SN Bose Center? And the first thing that came to my mind is, oh, it's Rajabajar Bose Institute. But he told, no, it's a different place. It's Bose Center. It's in Salt Lake. You should go visit there. Okay, fine. I got the address. I probably got it from Professor Vikas Chakraborty in Saha Institute. And one day I ended up in the bus stop called Vidyasagar. There was DB15 or BD15. I don't exactly remember. That was a couple of flats. SN Bose Center was situated there. It was a busy office, computer rooms and all that. I was totally lost there. I was looking for Professor Abhijit Mukherjee. He's a condensed matter physicist. Then the then PA to the director, Mr. Shunis Dev, he said, oh, you have to go to JD block. The center is relocating there, and Professor Mukherjee is right there. Now, how to go to JD block? Salt Lake has always been a bhul-bhulaiya to me. I got a bus, probably it was S19, if I remember correctly, and Shunis told me that you tell the conductor that you want to get down at Stadium Point. Well, later on I realized that it was Purvachal bus stoppage, and I asked somebody, I want to get down at Stadium Point. Now that person looked at me with curiosity and said, there are several stadium points. Now you look right, you can see the stadium. When the bus, makes a circle around one of the islands, you can see the stadium. So there are several stadium points. Where do you want to go? I said, JD block. Okay, so this gentleman was kind enough, told the conductor he wants to go to JD block. Then the conductor called me, here's your stop. I got down, I said, is it JD? He said, it's GD. I said, I want to go to JD. He said, there is no JD, it's GD. Okay, so it was a mid-September afternoon, a blazing sun. I started walking. There was not a single soul on the road. Then finally, I ended up very close to the center. There was a police patrol, I asked them. So that guy was trying to sort of make it out in a very reasonable way, scientific way. He said, it's IA, IB, then there must be JA, JB, then JC, JD, something must be somewhere around. So you look around. Then finally, after a little bit of attempts, I ended up at the gate of the center, and I was asking the guy, the security, that I want to go to JD block. And he said, this is JD block. I said, oh, so the entire block, one entire block is the institute, fine. All right, so I got in, I spoke to Professor Mukherjee, and he said that, okay, we can arrange an interview if you have a gate fellowship. So finally that interview happened sometimes in January 1996, and then I got this offer letter. I finally could dug it out. So you can see it's dated 8th February 1996. I immediately joined on the next day. And I found that Professor Mukherjee has a group. So these were the group members. So at the center, you can see Professor Mukherjee. And then there were these 4 research fellows, Taposh Mitro, who is now a college teacher, Biplav Sanyal in Uppsala University, Parthopratim Bishwas, he is in University of South Mississippi, if I am not mistaken. And this is Nityananda Das, he is also teaching in a college. Now these photographs actually reflect the moods they were always in. So for example, Nityananda Das was always bindas and cool, Parthopratim Bishwas was always very serious, Biplav Sanyal, often he used to grin, but more or less this was his face. And Taposda also very serious, always absorbed in physics and all that. So that was my journey. And then what happened was I was death scared to using computers. But then Professor Mukherjee on the first day, he said that, well, you have to open a file. Open a file with VI. And I was wondering, what is VI? Then these guys, Biplab Parthoda, they came into rescue. And they actually sat with me and with a rookie who was very scared that he's not going to actually sustain this kind of pressure, computational physics. The guy who used to run away seeing a computer would have to write codes, run codes, do computational stuff, but they actually taught me literally how to do the things. And in fact, I dug out also this thing. If you can see the screen, you can see the date to the arrow. It's April 10, 1996. One of the first programs I wrote. It was about generating a nearest neighbor map and doing a calculation, which is called a recursion method, which was kind of the backbone of our work that time. And this program, once again, if you can see, it's dated 25/4/1996. It was written by me and Biplav. So such was the life. They made the entire contingent over there, welcomed a rookie, a new guy with open arms, gave time, and made him feel comfortable. So when I say that it was not just a personal journey, but it was a journey along with the center, I'm not exaggerating, actually. Well, so things were going on fine with fewer students. Then in 1997, 2 things happened in the center. First was the internet came. And this man was instrumental in bringing it. Professor Sandip Chakraborty, around late 1996, he joined. And the first thing he tried was to bring internet into it. Well, up to that time, it was emails were fine, but internet we haven't really had access to. We haven't really heard of. We haven't really thought that we'll be ever using it. At the same time, there was another guy who joined and introduced Linux to us. That is Professor Amitabh Bhai. So these were the 2 very exciting new things in the center. Okay, and Amitabh Bhai, I mean, I don't know he knows it. We used to call him the Linux man. So any troubleshooting Linux, Amitabh Bhai was. All right. At the same time, one guy joined as a PhD student, and it was the beginning of a new friendship with Indranil Chattopadhyay, who will be a speaker here. He is an astrophysicist. He used to work in astrophysics, but we sort of made a extremely good bonding, which is still continuing. And it was so that I had to, from the bottom of my heart, I had acknowledged him in my thesis. So this is the acknowledgement page of my thesis. Apart from my group members and others, I had acknowledged him, and I still acknowledge him. His sort of, I would say, friendship, mentorship, you want to call whatever it is, actually helped me sort of pass through difficult periods during that time. And we are great friends till now. All right, in 1999, SNB went international. So these were the first international students, Ainul Huda, Aka Mukul, and Kamal Krishna Shaha. They had joined both from Bangladesh, and they are very well placed. Mukul is now faculty and was former head of the department in Jagannath University, Dhaka, and Kamal is placed in US. And on your right, you can see Durga Paudiyal. He was from Nepal, and he is also in US, being extremely successful and a big shot among the Nepalese community and scientific community in general. So in 1999, things were happening. The first post-MSc batch joined. So you can see there are several people, Anuj Nandi, Abhishek Choudhury, then Shantobrata Das. This is Indranil back then. Monirul Ali, and then Sharnali. I think this, if I'm not wrong, this is Shubhankar, who is a participant here and a speaker, and this is Rumani. So life changed. In 1999, not only the students, but lots of faculty, including Professor Tanushree Saha Dasgupta joined. So the entire center was beaming with sort of energy, and lots of activities started. I learned few life skills back then. I was leading part in organization of one conference and one ACRC school. So I saw how to manage things from the front line, and that lesson actually helped me later on in IIT to organize big conferences. And then during that time, I visited ICTP twice. This is no big deal, but the big deal was full funding for travel from the institute. Nowadays, I can see the difference at IIT when people really have to struggle to get funds to go to conferences abroad. And this man was instrumental in it, Professor Chanchal Majumdar, the first director of the institute. He didn't ask a question. When a student wants to go, he completely understood the merit of it. So that was a very important lesson I learned. Another important lesson I learned was in 1999. So this was so funny. That was the first kind of progress seminar everybody had to do. And I was there, damn confident. But then Professor Mukherjee himself ripped me apart totally. And later on, I heard that he did it purposefully to give me a taste of what could happen if there is a hostile crowd. So we should not take anything for granted and be ready for any consequences. So Professor Feynman said that never say that you will give a talk unless you know clearly what you are going to talk about and more or less what you are going to say. And my experience over there was that never take any presentation lightly, no matter who the audiences are and how friendly you perceive them to be. I made a mistake that it's just a in-house presentation. So you can go semi-prepared, half-prepared, and just give a talk. But I remembered that lesson, and I decided never to repeat that kind of mistake. So in 2000, I finally had submitted the thesis. The association with the well-knit family came to an end. But before I finish, there were some important cogs in the wheel who were also very friendly, and occasionally, apart from the students and faculty, we had wonderful discussions. One was Jaideep Kaur. I had to somehow sort of dig this bad photo out. This is about him. Indranil said, the man who cared about Tendulkar's performance more than Tendulkar himself. He was always talking cricket, and he was always cared about India's performance. Then there was Santosh Singh, cool, suave, organized. Sunish Da, now retired, gentleman with a smile. And Prashanjit Talukdar, he was the handsome hunk of 90s that time. Okay? There were others too, but I just could dig out the photos of them. A.K. Sarkar, for example, was another person. All right, so my association with SN Bose formally came to an end through this farewell party. You can see back in 2000, that time the faculty quarters were converted to hostels, and this was one of the parties. But the association actually didn't end. When I was applying for jobs, Professor Mukherjee first said apply to IITGs. It's a new place. Again, like SN Bose, I had no idea about IITG. But he actually sort of inspired me to apply there, and now I am here. And then when I got the job and came back and went to meet the people in SN Bose, Robinda told this, it's a wonderful place, picturesque, faculty housing on the hills. So he was effusive in the praise and was basically advertising, pushing me to go to that place. He said that, your hometown is a click away. You can start in the morning and have lunch with your favorite Hilsa fish at home. So do not make a mistake of not taking the job. And my association with SNBNCBS client continued till then. Of course, some, these academic ways, joint projects we had with Professor Mukherjee, with Biplab Sanyal, joint publications with Mukherjee Group, Aftab, Biplab Da, and then several conferences as organizer and participants, both ways. There have been people coming to IIT Guwahati, and I also had participated in many of the conferences. So the association is still there. And I would really like to have a formal association now to join these two institutes through a hyphen, sort of a memorandum of understanding with Professor Shahadat Dasgupta at the helm of affairs. I really hope that this will happen. Now, just the last bit of things for the students, because the students also need to, because one of the goals of this meeting is that the students should be aware of future development and self-scrutinize. So what I learned during my journey, first thing that I learned is collaborations in research are very important. The second thing I learned that social life, understanding of fellow colleagues are crucial for sustenance in this field. Third thing I learned is disseminating knowledge to young aspirants and laymen are very crucial. In fact, this breaks the research free from exclusivity and narcissistic tendencies. Society looks at researchers in that way, but I think it's time that we break free. It's good for everyone. And the fourth thing is that teaching a class broadens your horizon and ultimately aids to research. So for the students out there, for the future researchers, this is the little words of wisdom for me. I know that life is difficult, that life of a PhD student is very difficult, but if you sail through it, with certain philosophies in life, then the difficult roads will lead to beautiful destinations. Thank you for your patience. Thank you all.
Thank you. Great. Exciting talk, and it was really walk down the memory lane, and then again back to the present time. So, Dr. Ghosh has stressed upon several important points, and he would be available to interact further. Let us move to Bhubaneswar. Malloy, are you ready?
Ranjit, Ranjit,
I think some questions are there.
Yeah, I think Aptav has a question to Subhrata.
After I have a question, well,
Please.
hi Subhrata.
yes.
I am really curious what happened during that semi-prepared talk. If you
You want to humiliate me? Come on, Aftab. Well, what happened was, I tell you what happened. Professor Mukherjee dragged me deep into the mathematics of augmented space and various other things and everything. And then he wanted me to relate things to experiment, which at that time, I really never thought that I should do that. But yes, he never told me why he did that, but later on I told others that he will be going to do postdoc. There can be a hostile crowd. So he better be prepared to face such a situation. So that was it. And he probably understood that I was casual. So it was a situation that, you are inside a boxing ring and your opponent is, you are getting jabbed, hooked right and left, and you drop your guard at some point of time.
Mukherjee is never like that, as far as I have seen.
No, he was never like that. I don't think he ever repeated that. But that day, those who were there, Hindu was there, Shanto was there, they can vouch.
Okay, thank you.
Okay, so now, Malloy?
Yeah, okay. Can you hear me?
Yeah.
Okay. Okay, so very good morning to everyone. And I would like to thank Professor Biswas and the organizer for arranging such a nice platform and giving us the opportunity to meet some of my friends as well as some of my seniors, and also I will be able to know the juniors also. I would have been happy if I would have been there in person, but as already Subhrata and Apta mentioned that in IIT we are already, like BTech is already going on, first year BTech is going on, and so we cannot leave right now. but most probably next year we can join in person. That would have been very good for, like, I would like to interact with the juniors and want to know that how much development have been occurred in that part of my golden era, which I spent in SNBNCBS. First of all, I want to say that I joined in 2002, and as Aptab mentioned that although Aptab and we are friends from the MSc, and Aptab joined just 1 year back to me. One is previous, so he joined in previous year, so I joined in 2002, and in 2002, so when I joined, there was a mishap happened, like that is funny, so I want to share that. So when I went there in SNBNCBS Center to in the joining date, so in the offer letter I had been mentioned some joining date, so I went that day with my father, and there that time Professor Mukherjee was like acting director, although like Professor Dattagupta was somehow, he was in outstation. So he told me that sorry Malay, Professor Mukherjee said that so your place was replaced by some other person like Subarna. So I said no, I somehow he did not get my confirmation later that I will join. So but he got the information that I joined in IIT Kharagpur. So then he said, okay, you stayed for some time. So within 2 days, Professor Dattagupta will be back, so you can talk with him. And so then I stayed there for like 2 days, and so after that this has been sorted out. But apart from that mishap, the whole 5 years I said that that was my golden time of my life. Why? Because, so let me just summarize that some of the strength of this institute, what I found that time. Like first thing is like we are very much fortunate to have like some of the great teachers that time, like Professor H.S. Mani, Professor Vinayak Dattaray, Professor Dattagupta, Professor J.K. Bhattacharjee, Professor Abhijit Mukherjee, and I must say about Surajit Da, who is no more. So all these person, they have actually inspired us a lot. So like to blossom a bird, you need some kind of caring. So that kind of caring we got from those great personalities. I will say that you can always ask anything and you can learn many things from these persons. So that was like, I will say also that was the like Professor Dattagupta can be thanked. So we can say that this is his credit that he was able to collect all these like great teachers in a place. So I will say that that was the most strength of that time. I feel that was the more like best thing about that place. The second thing is that there was great freedom was given. Like it was not like constant that you have to do this thing or you have to be like. So when I joined with, so first I joined with Surajit Sengupta, and then also the thing which I should mention that I interacted with the experimentalist that time, Subhankar Da, and he introduced me some new things happening in the experimental nanomagnetism. So some funny things were happening in some temperature protocol or field protocol that was called memory effect, and it was not been explained. So we are trying to explain it, and with some simple model we could able to do all these things. But that was a nice collaboration between the experimentalist and the theoretical people. So I will say that, so this is a great lesson to the youngster also, that you should not be constant I am doing theoretical physics, so I don't require to interact with the experimentalist. So you should be always open up, in your throughout your journey, you should be always open up, because ultimately what I feel that until and unless your theoretical results are verified, it is not useful, or it is not people can care about it. So you need to be talk with the experimentalist, you need to interact with them, and you can get some new idea or great ideas from there. Okay, so throughout my journey, I actually tried to interact with the experimentalist, and I try to orient my theoretical skills to analyze the experimental results, or to give something which can be verified by experimentalists. So try to always interact with the experimentalist. So that was my first lesson that you can get. So as a theoretical, because I was from some remote area, I did not have any exposure to research. What is research? So after getting into SNBNCBS Center, I got some opportunity to interact with some great teachers. So they have motivated us, and then I got to interact with the experimentalists. So there are very few experimentalist research scholar were there that time, and one of them was Shubhankarda, and he was very dear friend, and he was very caring. So that time, so this thing which Subrata already mentioned, that that kind of bonding is required, that until and unless you are happy, you cannot create a good thing. So that environment was there. So I think until and unless you are a happiest person, you cannot create anything beautiful. So you are a creator. So if you want to create something, you need to be happy inside. So that kind of free environment and also interactive environment was there that time. What I find, so these two things are the best thing which I can remember for the SNBNCBS Center. That time we got very good teachers. There are free environment. You can interact with any other people of that, and you can discuss anything about your research or apart from research. So that kind of environment was there, and we were like a family kind of things. Although it is not possible for a larger group, but that time we were a very few persons, almost 40 to 45% research scholars are there, and we had a very good bonding with the seniors and also juniors. So we are fortunate enough for such a good environment. And during that journey, so I did also some theoretical modeling, but that modeling is in the quantum domain. So latter part of my PhD work, although apart from this nanomagnetic work, which is experimentally proved, and I had a good contact with the good collaboration with that experimental group. But apart from that latter part, I worked with Professor Dattagupta on some dissipative diamagnetic system, And that part actually gave me some more insight on the quantum domain. So with that knowledge, I submitted my thesis around 2007, and then I moved to TIFR. So during the TIFR era, like 2007 to like 2009, so during that part, 2 years part, I was also fortunate enough to like interact with some of the great physicists like Professor Mustansir Barma, Professor Deepak Dhar, and so these two persons actually very much interactive that time. And I also discussed with some physics with Vikram Tripathi. So during that time, Professor Deepak Dhar actually was very interactive. Like every time he was like curious about what is going on and what you are facing, like in personal life, also in your research area, and also he was like he was telling telling us to broaden your views, like not only concentrate only your focus area, you like learn from the various parts of the like there are like so what was lacking in SNBO Center like that time, like we are not fortunate enough to like foreign visitors or like some of the well-known physicists from around the world, but that was like I was fortunate in the TIFR era that I was able to interact with some of the great physicists that time also. So that also helped me to blossom as a scientist. So after that, I joined in University of Toronto, where I actually able to like learn some new techniques or new simulation techniques to tackle some of the challenging problems in heat transport. So that was development. Like I was learning non-equilibrium classical mechanical techniques as well as the quantum mechanical, how to tackle the quantum transport problems. So during my training in PhD, I was like learning the non-equilibrium statistical mechanics tools, and then during the TIFR also, I also able to learn some of the non-equilibrium statistical mechanics technique. But side by side, I was learning the quantum mechanical tools to tackle this open quantum systems. That means the systems which are like in reality you can face, like in your textbook, what you see that all the quantum mechanical systems are at either at temperature 0 and they are isolated. So when you are solving for like quantum oscillator, harmonic oscillator problem or 1D potential problem, which are famous, you are basically thinking that there is nothing in the universe, only that particular system is there. But that is not the reality. So reality is that it can interact with in its environment and it is at finite temperature. So how that things actually affect the system, that is I was trying to learning during that era in University of Toronto. Then I joined in 2012 in IIT Bhubaneswar, and here actually I explored both this area, like classical mechanical area, classical statistical mechanics area, and also as well as the quantum mechanical domain. So actually I explored much more in the quantum mechanical domain, mainly in quantum transport problems. So in recently I have a group of 4 members, like 4 research scholars and 2 project scholars. So they are mainly working on the quantum domain as well as classical domain. So what the problems they are dealing, like they are dealing with some problems which are like thermoelectric heat engine in quantum with a system of quantum dots. They are working on thermal transistor and also some of the problems related to heat transport. Like we always think about that heat energy is waste, but whether we can able to, like just like electronics, whether we can make phononics. So whether we can channelize these phonons in certain direction or not, that is a great challenge, because from the experimental perspective, these phonons are like in the terahertz limit. So they have a broad spectrum. So at that limit, you cannot control them easily. The other thing is, like electron, it does not have mass or charge. So that is a great challenge to like channelize these phonons. So we are working on that particular domain. So why I am talking all these things, because this is a development. Like I started with some kind of nanomagnetic system, working on some nanomagnetic system, and that was started from Dulalda's piece of, which I can remember, like one discussion with Suvankar one day in the Dulalda's piece of, he mentioned this typical phenomena under certain temperature and field protocol, and that was like haunted me how to explain that one. So from there, now I am working in some other domain. So why I am telling this, because you should be open, like you should not be like, I am working in this particular, I started in this area, so I should be focused only this one. I will not care about other things. That is not, should be, that should not be like your view. You should be open in your mind so that you can get new ideas from other persons. You should interact with the experimentalist so that you can get some new ideas, and you can be able to know the new phenomena which you may not be able to like see without like interacting with the experimentalist. And the third thing is like which already Subhrata mentioned, that that what I also feel like, you can learn much more when you are teaching. Like, so if you don't teach, you will not be able to learn. So teaching is the best learning process. You can say that you can be like that time you can face new fresh minds, what they are thinking, and you are like giving some new messages to the fresh minds, so how their reactions are. So that kind of interaction will give you also some new challenge. So and also caring about those new minds, fresh minds also, and also you are giving them like or you can say that you are giving them the new knowledge to them. So that is a big challenge to you yourself. So when you face that problem, you can learn a lot. So teaching is the best part of the learning, you can say. So with that, I can say that as I am like, I also say that 2 persons are not here, like Surajit Da and Professor Binayak Dattarai. So I am thankful to them, because they are very helpful in my past during first 2 years or 3 years of my SNBOS time. With that, I want to conclude this talk.
Any points? Any raised hands? Okay, thank you, Malloy, for your nice presentation and introduction. We move to now Northeast, NIT, Agartala, Dr. Vishwajit Pal. Vishwajit?
Yes. Hello, am I audible?
Yeah.
So, good morning to everyone. Uh, Landed in this because as I can see, all of there are my seniors. So, with all a lot of expertise. So when I
Biswajit,
first
your
saw the,
voice is breaking.
am I not audible correctly?
It is breaking in between.
Okay, just a minute, please. Connection. Is it okay now?
Yes, yes, please.
Okay. So as I was saying that I can see today here in this group all of my seniors. So in that aspect, I mean at the beginning I have prepared a talk based on the abstract and all these things, but now I have changed the mind and I think I will discuss only whatever is I have learned from um, SN Center. Okay, so the thing is that I have joined SN Center in March 2010, and before that I went from Agartala. So when I joined SN Center as a JRF student, so I joined in theory division, and I learned one thing that how to do the board work. I mean, I I know how to do the calculations in the pages, but to do in the board and when your guide is present, I mean it's really a challenging thing. So on the first day I can remember Professor Robin Banerjee was there, and so he asked me to write a Lagrangian. So I just put the Lagrangian. So you have to since I am working in higher derivative fields, so I have to put a lot of dots over the fields. I mean it's like x dot and x double dot like those. So somehow I missed a dot. I mean toward the line, and sir told me that you are missing a dot there. I told, oh, one dot. And then he told me that no, it's actually a very serious business. I mean you can't miss a dot like that. So on the board to work and also to do the calculations seriously. That's all I learned, and other than the research part, I also was very much involved with my seniors and my batchmate. So I got from the group Divakar, then Devrajda, and here we have Shurabda and Shunanda. So I am thankful to all that I had a very pleasant and very a memory memory that I can keep throughout my life, and still I cherish. So I wish that I could have joined personally in the institute and be there for at least 1 or 2 days. But here, since in our institute the BTech exam is going on, so I could not got the leave. So, and other than this, I still miss the football ground especially. So at night, each and every night after 8 p.m. So we all used to go to the football ground, and I barely missed any session there. So at that time there was no goal post, so there was no this. I mean, these goal bars were not there. So we used to take a rod sometimes from the construction site and used to put there, and those used to be our goal post. And what I can remember is that the mess especially. So still when I tell choice in menu, and next day it will appear for sure. And whole thing is managed by the student. I was the mass committee for one there, and also so I tell everybody that if you want to see how to manage the mass with very low cost, and I mean the very nice food, then you should see the SNBNCBS Center. And most of my part, I used to sit in the students' bed. Now it has another name, I think. And other than this, at the beginning, I used to sit in the library. So I have a very nice attachment with the library. And after that, I have visited many libraries in many institutes. But the collections that is available in the SNBNCBS Center is phenomenal, I must say. So rather, I have a short journey. After I have submitted the thesis on 2014, and then I went for postdoc in IISER Bhopal, and then just in a hurry, I must say, I came to Agartala and also joined in NIT Agartala. So just with one of the reason to stay in the hometown. Then now the thing is that here we have to take a lot of classes, lot of students are there, and also manage the research part. Now I am involved in PT symmetric quantum theories. I mean, it is very interesting theory I later discovered. And I found out that Carl Bender, okay, he has grown this whole thing almost by himself, and so now a student under me is going to submit his thesis on this same subject, the PT symmetric quantum theories. Now this connection came actually, so when during my PhD thesis, I actually worked in higher derivative theories. So in all the talks, whether it was for postdoctoral talks or for some conference talks, everyone used to come, and then at the end of the talk they used to ask one question. You see, these PT symmetry theories have ghost fields and instabilities, how you can solve them? Then I used to say, no, I am not trying to solve them, I am just looking in some different aspect. And after getting the same question from many persons, I thought that let's try to explore this field, what is the issue. So later, after my PhD, I concentrated on the same question, and I got some really good publication on that line, and also I have solved a bit of that, I must say, using PT symmetries and also using other techniques of constant dynamics. Now the thing is that I really got annoyed at the beginning with the same question everybody asking me, which I do not have any answer, and also actually it's still a open problem for in quantum field theory. Uh, so during my time, we got courses from Dr. Bishwajit Chakraborty, then Professor Amitabh Lahiri, and so I am indebted to Dr. Bishwajit Chakraborty especially. He also have told me how to be serious in calculations. I am thankful to all, and other than this, the environment inside SN Bose Center, it is so calm. I still miss it because when you are in with the students I mean with BTech. In such a hurry that you miss the calmness.
Thank you, Vishnu. Internet connection from Northeast is still probably not very smooth. So we had sometimes still programs of you without noise. Okay, so this brings to the end of this first technical session of this exciting alumni meet, Impact 2022. We will now have 15 minutes tea break, and then after 15 minutes, we will join. So the time is now 10:23, so we'll probably join in 10:35, in 12 minutes. Okay, so please be there. Don't disperse. 11:35, sorry, in 12 minutes. 11:35. And the next session will be handled by another well-known alumni of the center, Professor Sunandam Mahopadhyay. We'll come back in 12 minutes.
Hello, Aptab. Aptab, do you hear me?
Yes.
Hello, I am Biplab.
Viplav, how are you?
I am fine. How do you do?
I'm good. I'm good. Long time.
Yeah, yeah, it's almost 15 years.
I know. কেমন আছিস?
ভালো আছি.
হ্যাঁ, হ্যাঁ।
Molay is there also. Mukunda,
মলয়
Molay.
সব শুনছি।
ভালো আছি.
বিপ্লব এখন কোথায় আছিস?
আমি কলকাতাতেই আছি.
আচ্ছা
আমি একটা কলেজে পড়াই ফিজিক্স.
হ্যাঁ।
Okay, Aptab, Molay.
হ্যাঁ,
I
হ্যাঁ,
will
হ্যাঁ।
talk to you later, okay?
হ্যাঁ, বিপ্লব বম্বে চলে আয়
হ্যাঁ, যাবো.
সময় বের করে।
Okay, okay.
চল।
ভিডিওতে স্যার এদিকটা দেখাচ্ছে সুরেন্দা ওইটা আছে
ইন্দ্রদা বলছি তো সবাই পালিয়েছে, এখন আমরা কথা বলতেই পারি।
হ্যাঁ, সবাই চলে গেছে।
সবাই চলে গেছে। তারপরে বলো কেমন আছো?
আমি ঠিকই আছি। এখন আসলে এসএন বসে এত ছেলে মেয়ে এসে গেছে না, স্টুডেন্ট, ফলে
এখন প্রচুর।
হ্যাঁ,
আমি আমার স্টুডেন্টদেরকে বলি, মানে তখন সেই সময় তুমি ভাবো আমাদের সময় প্লাস তোমার 3-4 বছর ডাউন দ্য লাইন,
হ্যাঁ,
তুমি যদি ফ্যাকাল্টিশিপের স্ট্রাইক রেট দেখো,
হ্যাঁ,
it's much better than any institute in India, including TIF or IISc.
না আসলে বড় ইনস্টিটিউট হলে তার অন্যরকম চ্যালেঞ্জেস থাকে। ছোট ইনস্টিটিউটের কতগুলো যেমন ইয়ে থাকে, তার কতগুলো আবার অ্যাডভান্টেজও থাকে। একটা মেজর রিজন হচ্ছে তোর ছোট ইনস্টিটিউট হলে বলে তোর ওই পার্সোনাল ইন্টারাকশনটা তো বেশি হয়। ইট ইজ ইজিয়ার টু ট্র্যাক। আইসার ফাইসারে যেমন যেগুলো মানে তোদের ওখানেও যেরকম মানে এত স্টুডেন্ট তুই কজনের সাথে আর পার্সোনাল রিলেশন বানাবি? পার্সোনাল রিলেশন মানে এমনি ইভেন মানে গাইড স্টুডেন্ট রিলেশনশিপটাও খুব ইয়ে হয়। একটা ছেলে সুইসাইড করলো না ইয়েতে আইসার কলকাতায়,
হ্যাঁ,
ইটস বেসিক্যালি কমিউনিকেশন ব্রেকডাউন। তো যাই হোক, সুব্রবোধ ব্রেক নিচ্ছে নাকি?
সুব্রত নেই, সুব্রত তোমার ওই খিচুড়ি দেখে ও খিচুড়ি বানাতে গেছে বলে আমার মনে হয়।
It's time for the next session now.
ও নদীতে যাবে মাছ ধরতে, তারপরে একটু পরে খিচুড়ি আর মাছ ভাজা খাবে।
So it's time for the next session. Professor Indranil Chakraborty from Aries Hospital will be the next talk, and looking forward to hear this talk.
Should I start or should I wait? Oh, I can start. Okay, fine.
Yeah, you can start.
So I'll share my screen. Okay. All right. Can you hear me and can you see my screen?
Yes, please.
Yeah.
I can hear you. The screen is also visible.
Okay, so I don't know what title I gave to this talk. I think this is something similar to this. And so this is Aries. If you can see my just a minute. Yeah. If you can see my cursor, so this is Aries. This is over a hill called Manora Peak. And so this is the main building. And I sit in the ground floor here. And this is our one of the most, old workhorse. This is a 1 meter class telescope here, and it produced many PhDs and so on. So I joined SNBNCBS in August 1997 in the astrophysics group. There were no departments at that time. And I spent a wonderful time in SNBNCBS. In 2002, I submitted my thesis in September, and October I joined in Kelvin, Belgium for my first postdoc. From there in 2000, after spending 2 years there, I joined CN University, Daejeon, South Korea for my second postdoc. And then I joined Aries as a faculty, and I'm there since then. So Aries is first some introduction to my institute. So Aries is a picturesque place. Clouds and sun can be very beautiful. Their interplay can be very beautiful. You can see it here. It's a drone picture, by the way. We have extremely good, fantastic sunset points. Evenings, clear sky evenings can be fantastic, or it might simply snow. Okay, so this is this year's snow in February, and it's almost 7 to 8 inches of snow there this February. But sometimes nature is beautiful, but sometimes it can be very, very destructive as well. This is from the last year's October floods, okay, which sort of engulfed the entire hilly region of Uttarakhand. It is also a powerhouse in optical astronomy. There are many telescopes. So there's 1 meter telescope, the dome which I showed in my first slide. This is 1.3 meter telescope, and this is a 3.6 meter class telescope. They are in our second campus in Devastal, which is around 60 kilometers from here. We also have an atmospheric division, and there we have an radar. It's basically to study atmosphere. Okay, so one section studies stars, galaxies, and whatnot, which is outside this, Earth system. And there are others who actually study Earth atmosphere. So they actually send radio waves or pulsed laser, and the reflect, and then they analyze the backscattered waves through which they then can sort of understand the nitty-gritties of our atmosphere. Okay, how the density is changing, what are the aerosols, etc., etc. So sort of they build up theories based on that, on those data. My research area is a theoretical relativistic astrophysics, which basically amounts to fluid mechanics in static or time-dependent space-time. And it basically, I am involved in developing new simulation codes. Major thrust area of my research is to study matter behavior around compact objects, be it accretion or jets. And we proposed an equation of state sometime back, and we are using, so this is the equation of state in fluid mechanics is basically relating all the thermodynamical variables with each other, the relation, and that can be computed from the first principles. And so this is something we did, and we are implementing this in various codes, simulation codes and all. So this is a simulation study of a shock tube test. Shock tube tests are typical tests to check your codes that you are developing. This is essentially what we have done in our thermodynamics courses, right? So statistical thermodynamics courses. So it's like you have two gases, two fluids, and you separated initially by a separating surface, and then you pull it open. What happens? How it develops? So it's something. So you can take a cut of this, and you can plot the densities. Here it is the density contours that has been plotted, and this is the x direction. And if you make a cut, and you can plot these densities, and there's a shock wave developing, the rarefaction wave developing. This is the original contact discontinuity, that is or separation of initial separating surface that is evolving in time. This is Kelvin Helmholtz instability, which we have developed it with our code. It's Kelvin Helmholtz instability is essentially happens when two fluids have relative velocity with each other. So if you go to a water body, you will sometimes see in windy day the water is very choppy. That's a Kelvin Helmholtz instability. So water is not really moving, but on the top of the water surface, air is moving very fast, and you develop this wavy patterns. You develop is the choppy waters, they call it in English. Those are basically Kelvin Helmholtz instability. We see it in clouds as well. We see in astrophysical phenomena. In jets, we see that. And there are something called astrophysical jets, where very fast relativistic matter moving through the intergalactic or interstellar medium, and we on the surface we see these phenomena developing. So this is a toy model for a dying star. This is the blast wave. So if a star, in supernova, if they die, so they throw a blast wave. It's essentially the same physics that goes on for atomic bombs, okay, or any bomb for that matter. Any bomb being their temperatures, their power, the energy they pack is much lower, that therefore they cannot generate this expanding supersonic shells. In supernovae or bursting stars, they happen, and these are called relativistic instabilities. These finger-like projections. Okay, so it happens when a heavier fluid strides over a lighter fluid. We know that in gravity, the heavier fluid should be at a lower altitude, and the lighter fluid should be on the higher altitude. But if you can do the other way around, so if you somehow produce higher density matter over a lower density matter, then the higher density matter through finger-like projections enter inside the lower density matter, and you have these. And it's seen in supernova. If you look at Crab Nebula radio image, you'll see that. Okay, this is an accretion solution with around a black hole. So with viscous solutions, as we increase viscosity, the shock settles at some. There's a shock wave here. There's a the velocity versus radius, and there is a jump here. There's a shock wave, and if you start, so this is inviscid, and you increase the viscosity, it sort of goes and settles somewhere else. All right, so this is also some jet problem. So where if it interacts with the radiation, then it can sort of also produce shocks, multiple shocks for that matter. So this is an electron-proton jet. And I mean, the gas is composed of electrons and protons, and you can see that many shock waves are developing. These are important because in jets, you need to form these shocks to explain a lot of observations. Okay, I'm not going into the details of it, I'm just giving glimpses of my work. Again, this is a outflow where two-dimensional, and you can see that matter is going out. It's a density contour with this arrows as the velocity vectors. This is a supersonic jet simulation. I'm not showing the movie here. This is one thing we did for the last couple of years. It's going deep inside the astrophysical plasma. It's what we can say that astrophysical plasmas are bare charges, and bare charges, being hydrogen being the most abundant element, it should be electrons and protons. And if you have that, then the equations of motions are degenerate. So how to solve them? So for given boundary conditions, this is a one temperature solution. You always have the same solution, but two temperature means that the electron gas and the proton gas are settling into two different temperature distributions. And if you do that, you increase the number of variables more than the number of equations. So, and then you end up with, so you can see the same boundary conditions, the two temperatures have different solutions. You can see this is a Mach number. Mach number is the ratio of velocity with the local sound speed. And you can see that the solutions changes. And we proposed a way to get out of this conundrum by calculating their entropy, and the maximum entropy should be the solution by the rule of second law of thermodynamics should be the solution chosen by nature. So that's we proposed. But we still, there are 3 papers we have published, but still it takes a lot of fighting with the community to get this proposal through. We also are calculating, doing all sorts of high energy physics stuff there. So this is like pair production in astrophysical scenario. This is an accretion, but we're also doing it for jets. And I'm not showing it anyway, no more here, pion productions and so on. So this is my group. I'm the only theoretician there. Recently, one person have joined, but he has just joined, so he doesn't have a student as of now. So these are the 6 students. So these 3 have already graduated. She will defend her thesis on this coming 2nd June. And Raj is now developing into a major numerical simulation expert. He's writing codes left and right and center. And Shonjit has started, and he's also a very intelligent fellow. Okay. I actually did not talk much about this, but it's about my association with SN Bose. So I was searching last night a lot of pictures. I was not getting them. So I joined in 1997, and the best thing I took with me are the students, the student community of SN Bose. They were absolutely fantastic, and they occupy my memory the most about SN Bose. So this is I could not find the persons who find a picture of the four of us joined the astrophysics group. This was my supervisor Sandeep Chakraborty, and this was Taposh Da. Then this is myself, Arnob, and this is Bani. So we four were the students. We joined roughly at the same time. Taposh a little earlier, but we three joined together with Sandeep Chakraborty, and this was one of the first conferences we faced. I mean, we had after joining, within a few months of joining, and so we were given lots of responsibilities to organize, including taking all these foreigners across Calcutta with a very bad bus, and so managing those things took some time. This picture actually Shubhro showed. So this is like Anuj, Shubhankar, Rumani, Devashish, Swarnali, Shanto, myself, Atish, Muni. I don't see Mukul here. So I think that is BDR at the back. I cannot recognize who's this person. This is inside the canteen. Okay. So this is again once Soumitra Chatterjee came to give a popular level talk in SN Bose, and we students grabbed him and took a picture. The picture is of course not very good. So yeah, there is Mukul here. This is we used to call him Ramu Chapcha. He's not around here. This is again this is a TT tournament, and where as Mukul and I was partner, and Mukul always alleged that it was because of me we lost the final, and these two guys won the final. Okay, this is Shubhankar, HS Mani, Professor Vijit Mukherjee, Moni, myself, Ainul Huda, Mukul Bhai, and this is also Mukul. We had, because we're two Mukuls, we had two names. I'll not divulge it here. And probably the first freshers welcome in SN Bose was organized, and it was triggered by Shubhro. And we took that opportunity probably to sort of torture people with our rather modest singing skills, but we did it all the same. And I visited SN Bose many times after I left. So I had some connection with some of the students even after I left. And but now Aries and SN Bose have a formal connection. We signed a new MOU with SN Bose from Aries, and that's what I have to say. Thank you.
Thank you, Indra, for a very nice talk, for sharing your memories. And so, if there are any questions from the offline people as well as the online people during that. So, if there are no more questions, so let's go to the next speaker. The next speaker is Dr. Hemant Kumar Kashyap, and he's an associate professor in IIT Delhi. So, Hemant, please, you can share your presentation.
Am I audible, Sunanda?
Yes, you are audible. Yeah. And you are visible also. You can share your slide.
Yeah, I'm sharing my slide. I'm sorry, it is taking a little bit more time because I'm using my data. I'm not IIT Delhi campus. Can you see my slides now?
Your slides are visible.
Okay. So, yeah, so good afternoon, everyone, and it's very nice to see you all from over there in the campus and some online. So myself, Dr. Hemant K. Kashyap, I am an associate professor in the Department of Chemistry at Delhi. Before I begin my talk, I would like to thank Sunandanda, Viswas sir, and Tanushree ma'am for organizing this beautiful, meeting and inviting all of us. So basically, I did my PhD from July 2004 to October 2009. Let me take this. Under supervision of Dr. Ranjit Vishwas, and then I moved to University of Iowa in November 2009, and I was there till September 2012. And then I had about a year stay in my compliance group at Temple University, and then I joined IIT Delhi as assistant professor in December 2013, and where I was promoted in 2018 August. And since then, I am there as an associate professor. So, before I start my experience in SNBNCBS Center, I would like to say that many people ask me why Kolkata, because I qualified JEST exams, which most of you also probably qualified. So only 2 students from my Allahabad University qualified JEST exam, and they got interview letters from 15 institutions. So I was one of them, and another one is a scientist in BARC, Dr. Tushar Roy. But unfortunately, I didn't have a ticket to appear for the interview, and at that time there was no online facility. But somehow Tushar decided to go to PRL Ahmedabad to give the interview, and he had the ticket for Kolkata. So what he did is he shared his tickets with me, and I took his ticket and boarded the train to give my interview. Now, when I reached there, it was too late. Unfortunately, the interview was over. The interview panel, went for lunch, and when I reached at the reception, I was almost crying because the interview was over. So I talked to the reception people, and they said that the interview is over. But we sit there, and they gave me water to drink, and they calmed me down. And after 30 minutes or so, Mr. Santosh Singh, he came out and he told that the panel has decided to interview you. So I was like, delighted to hear, because normally this doesn't happen. So then the interview went for about 45 minutes or 1 hour, where Professor Mukherjee and Tanushree ma'am and other members were present. And it went well, though I didn't have any idea whether I would be selected or not. Finally, I got the interview or this admission call letter. Now, when I got this, then there were many questions: why Kolkata, why SNBNCBS Center? So for that, there were, because I belong to UP. Most of you are, I am the only one non-Bengali speaking here. So I belong to UP. So many people had this, confusion: why this guy is going to Kolkata? So there were 3 reasons. First, my childhood heroes, like Raja Rammohan Rai, Rabindranath Tagore, P.C. Ray, C.V. Raman, Annie Besant, J.C. Bose, S.N. Bose, Meghnad Saha, all of them. You name them, they were somehow belonging to West Bengal. And second was, like, my family was having long association with Kolkata, so they also told me to go there. And third was the food. I knew that these people eat very good food, including fish and other things. Finally, even though none of my friends and others were encouraging, I decided to join SNBNCBS Center. So this is how I started. But first 6 months were really boring for me because I was not able to appreciate things over there. So what I did is, first thing I did is in first 6 months I learned Bengali, and I really, acknowledge my batchmate, Dr. Tuhin Pradhan, who taught me how to read, write, and speak Bengali. And ultimately, in 6 months, I could read, write, and even read Vartman and Anand Bazaar newspapers every day. This is how I started, and I shared the same thing with one of the faculty members over there, and said that, see, I'm not able to enjoy. So he told me that go for movie, go for watch, go to Eden, watch cricket, something like this. That's where I realized the gap between students and teacher in West Bengal. In UP, at that place, the gap between students and teacher was huge, probably because of fear or probably because of respect. But I found there the gap between teacher and student is really, really uh, narrow, or almost there's no gap, and that gives you more comfort to share your thoughts with your teachers. So this is how I started. So after 6 months, when I learned language, I started enjoying everything over there, and I finished my coursework, and I did reasonably good. Then again, I was confused whom to choose, what to who would be my guide. So ultimately, I took the courses of Professor Ranjit Vishwas, Tanushree ma'am, and all of them, Dr. Surjit Sengupta, Abhijit sir, all of them impressed me a lot. So I was really confused whom to join, but ultimately, because of the clarity of the subject and understanding, I decided to join Vishwas sir. And in his group, I learned several things which are still helping me to do good research and do better work. So I worked on mode coupling theory and classical density functional theories under his supervision, and then I used them to understand limiting ionic conductivity, summation dynamics, and role of vibrational modes. I knew nothing about these things before I joined there. These are two questions which are very close to my heart, because I was always around them, working around these two equations. And later on, we also solved a very difficult problem related to integral equation theory, that is called mean spherical approximation for binary dipole missions having different dipole moments and different sizes. Same size problem was solved, but for different size it was not solved. So we did solve that. And then one of the most interesting problem that I worked with him was explanation of a bimodal solvent response function in ionic liquid. So I still remember that day I came to UP for holy holidays, and after I returned, he gave me one manuscript and told, "See, Hemant, there is an experiment here. Can we do something?" That's all he told me, and then I took the paper and worked on this. And within 15 days, I had the calculation done, and we wrote the manuscript, everything. And in next 15 days, the paper was accepted. So that was fastest paper I have ever published so far. So that gave me also some encouragement to go deeper into other aspects of ionic liquids. Then after I finished my PhD in 2000, not finished, I actually submitted my thesis in October 2009. During that time, actually, there was great depreciation in US and other places. So not many people were getting postdocs. So I was, one of the 3 people who actually got postdoc positions. And I was very happy to join Claudio's group. So I joined Claudio's group at University of Iowa in 2009. There I really learned, all the term classical MD simulations, and then use them to understand X-ray scattering structure of ionic liquids, and also the transport properties of ionic liquids. So basically, I was involved in understanding the origin of nanoscale heterogeneity in ionic liquids, and then there was another experiment which was saying that if you do the conductivity measurement, using impedance and NMR techniques, there is a disparity. So why is that disparity? So we worked on that also, and explained people why we have such disparity. And then there were other things that we did over there. So after about 3 years of stay in Iowa, I decided to learn more things, because I thought whatever Claudio Group was doing, I have already learned, so I should move to some other place to learn new things. So I joined Mike's group at Temple in October 2012, and there I learned coarse-grained simulations, where I learned about how to model self-assembly of lipids, and also I was given task of understanding membrane fusion, which I could not do because it was really a difficult problem. So I was trying to have a membrane fusion without fusion proteins and other stimuli. So that was a kind of disappointing for me, but I still learned a lot from that. So when I moved to Mike's group, there his group was very big, and almost all postdocs were very serious about their work, and they're almost like professors. The level of knowledge was very very good. Anyways, when I moved to Mike's group, after 6 months, I realized that I think I should start applying to India at different places. So at every weekend or holidays, I used to fill the application form, and on Monday morning, I used to dispatch them from Philadelphia station. So it was going on for next 6 months like that. So whole weekend, also several nights were dedicated for applications, and wherever I applied, I almost got interview, or at least they called me for presentation. And then there were some hiccups because I was having chemistry background in physics, so but I was applying to both physics and chemistry departments. But nonetheless, I was fortunate enough to get an offer from IIT Delhi Chemistry Department, and I joined there in December 2013. So this is the main building of IIT Delhi, very historical building. It was one of the tallest buildings in 1980s. People used to come and see this building in Delhi. So my office is on the 5th floor, and on the same floor I have my lab nearby, and this is my group. So I have graduated 7 PhD students. 3 of them were joint students, and 4 of them were completely on their own. So Shobha is actually, she is one of the senior students of my group. She is now in Los Alamos National Laboratory. So Preet is in University of Wisconsin Madison. Pratibai is in North Texas University. Harinder is joining Rutgers. He will join in July, and other members are still looking for some are completing their PhD, some of them are applying for postdoc positions. So if you look at my research work in IIT Delhi, basically you can categorize it in 3 broad categories. So 50% of my work was dedicated to ionic liquids until recently, and then 25% to deep eutectic solvents, and then remaining on membrane, understanding the structure and dynamics of membrane and bilayers and vesicles, and so on, other things. So in the past, we have worked on pressure-induced phase transition in ionic liquids. And then we were the first one to calculate X-ray scattering structure function of deep eutectic solvents, and tell people that there is a spatial heterogeneity in these systems. So Dr. Biswas group had predicted this kind of heterogeneity long back, almost 5 years ago. Before then, before when we showed people, and then We also studied how hydration affects deputated solvents, and we also studied bulk and interfacial structure of biocompatible ionic liquids, a slightly newer version of ionic liquids. And then there were other problems which we worked on, and they are mostly related to physics. Right now, we are interested in understanding the composition mechanism of formation of solid electrolyte interface, basically, in short, it is SCI, which is a kind of a layer which protects, the electrode materials as well as electrolyte for further degradation. It also helps, it gives stability to, the batteries for from explosions. And we are also working on intercalation, de-intercalation of electrolytes in and out of nanoscale confinement. Again, this is related to batteries where you have rough electrodes. And we are also working on understanding the solvation structure of greenhouse gases like carbon dioxide, SO2, methane, ammonia, and so on in deputated solvents. We do some development also. We develop refined atomistic and post-grain models. And we also try to understand the impact of small molecules like simple ethanol or alcohol, even say acetone, DMSO, or polymers like that. So we just published this work where we have tried to understand the stability of super concentrated salt solution in acetonitrile, uh, and we found that here the degradation of acetonitrile is quite stable here, and the SCI formation mainly occurs because the anions dissociate, the TFSI anions dissociate, and then we could tell the composition of SCI. These are AIMD simulations, so this run took almost 9 months to complete. So we ran about 250 picoseconds. Recently, we worked on the effect of ether on solvents. It has been found that when we fluorinate the solvent molecules in concentrated solution, then the SCI that is formed near the electrode is more sturdy, and it is more compact, and it is well structured. So which is a desirable property. So we showed the effect of fluorination in the solvent molecule on the SCI structure, and we told that the contribution of the solvent actually with respect to chlorine atom. So you can see that if the SCI is more inorganic in nature, it is more compact and homogeneous, and therefore it is good. So we showed that yes, solvent molecules also contribute to the SCI formation in fluorinated solvent system. So there are many other things that we do, but since the time is short, I will share here. But I would be happy to visit. I want to visit a center, but somehow things are not materializing. But I hope that in future I will visit and share my work with all of you. So with this, I again would like to thank the organizers and the group member, collaborators, PhD and postdoc members, and the funding agencies. Thank you very much.
Thank you, Roman. So, time for a couple of quick questions for the online audience as well as the offline people. So, if there are no more questions, so thank you very much. And the next speaker is Dr. Rakadash Gupta. He is an assistant professor in Calcutta University Department of Physics. Apart from being a professor of physics in Calcutta University, she is also an accomplished poet, as all of you know. So, Raka, it's all yours now.
সকালে হয়েছিল
Exactly. Okay, so a very warm greetings to you all, and it is wonderful to be back here. In fact, all that feels like home would be an understatement. It actually was our home and it's been here, and I'm very happy to be here. And the moment I stepped in, I saw so many familiar faces right away from our teachers. So Sriman is here, Ranjit Mishra sir is here, Amitabh Lagri sir, ICT Dr. Gurdu sir, and also many of my friends and seniors and juniors. I could get to see them in person. Also, there are so many people I could just see them in the online mode. So I also think that it's a wonderful idea to hold this meeting in this blended mode so that I mean all our friends who are scattered all over the globe can join and can have something like a I'd rather call it a family get together. So really feels wonderful. Thank you, dear organizers. And when I was asked to submit a title and abstract for this meeting, I was at a loss. I could not find a proper way to describe what I'm going to talk about. So I chose this title, and this is actually from a phrase, one of my favorite phrases from Alice in Wonderland, that when Alice made this cat, said that, "Could you tell me please which way I ought to go from here?" The cat said that depends on who did or how you went to get it. Alice said that as long as I get somewhere, it doesn't matter to her. And she only wants to get somewhere. And the cat said that, "Oh, you're sure to do that. You only walk long enough." I always think that this actually summarizes not only my journey, but also many of the academic journeys of our friends and contemporaries, that we just dare to walk long enough. And well, maybe we arrive somewhere, maybe we are still walking that path, but at least the journey is worth the wait. So I was told to describe my academic journey, so this is what I have taken for. So I did my PhD and MSc from W University. Then I spent more than 5 wonderful years here at SNBNCBS. Then I moved Asia Pacific Center for Theoretical Physics, South Korea as a postdoctoral fellow. And then I first joined University of Calcutta as PhD inspired faculty, and later I joined the same institute, same department as an assistant professor. So this is my academic journey in a nutshell. And let me go back to, I should mention that I have not prepared any technical slides, so I will not be talking about much of my academic, only anecdotes that I can share with my friends and seniors and juniors. So when I first joined SNBNCBS back in 2006, the first thing that struck me was there is a unique warmth about this place. So the first day my father came to drop me here, I was a bit anxious, started to feel a bit homesick. But then the chief of the security guards in the main gate, he just walked up to us and told my father that, "Do not worry, she's our daughter as well. We shall take care of her." And now today, when I was again walking past that gate, I saw that 2 of the security people, they smiled and asked me, "How are you? You are here after such a long time. When did you come back from abroad?" So it just feels like home. It's just a home, and I'm just visiting it maybe after a holiday or a vacation. And we really had a wonderful time here. Of course, we had our ups and downs in our academic journeys, but we always had the back of our friends, our teachers, who always motivated us to doing better. And I was fortunate to have Professor J.P. Bhattacharya as my PhD supervisor. I mean,
probably the best supervisor one had ever had. So there was always some gentle hand-holding in his approach, but there was enough academic freedom. So he never imposed anything on us at all. So we were free to choose our problems. We were free to choose our approaches. He was just like, okay, you can try this way. Okay, it was a moment of despair. Oh, sir, it's not working. It was. Positivity was something that drove us ahead. And since there was an enormous freedom associated with working with him, so at that point, I think there were 4 or 5 PhD students working here with him. But each of us took a different path, each of us worked on completely different fields, but at the end of the day, he was there to lift our spirit up. That was a wonderful experience. And not only sir, but also all the teachers here, Larissa, they were all there to motivate us. I don't know, Vishal sir, I think you were at the charge of the student advisory committee when we were here, and all of you helped us in getting to a very healthy environment, let's say. And here's like a fun. We had our midnight birthday parties. There was a birthday. We from the girls could stay in the guest house, and we used to travel in the boys' hostel and cut cakes, eat rasgullas, and lots of fun. In fact, I remember that day Ayla hit this place, posted in this. When things in the evening, when things become calmer, then people just call, oh, why don't you come over to the hostel, boys' hostel, and we had a kind of a small picnic over there, fried pakoras and finger chips and like that. And things were not always rosy. I would like to talk about my first rejection, so first paper rejection. So I also remember the exact date because it was the eve of my dear friend Shastika's birthday. So I was back here. I went home. I came here on 15th April so that I can wish her birthday exactly at midnight. And then just 10 or 20 minutes before that time, I went to Students' Day. I was checking my mail and I saw that, okay, my first paper got a rejection. And I was heartbroken. This was my first paper. So at that point, I really had, did not have much idea about how this peer review process works. So I thought, okay, this is my masterpiece. I have put in so much efforts on this work, and this is supposed to be flawless. And then the referee said, oh no, this is just meaningless. The model is wrong here, equations are wrong. There's nothing to do it. I was heartbroken, so I had to, but I could not share it with any of the friends because this is Swastika's birthday, and if I tell her this, she would be sad and I would spoil her birthday mood. So I had to keep mum for an entire day. And the next day I said, oh, I see, everyone see, I have got a rejection date. None of the day, but I was so upset. Oh, I remember one of our seniors shouted that he just saw, oh, these are very gentle birds. You should be very happy about it. You get the action from we celebrate. So actually, what happened was those referees' comments were very constructive. So then I worked upon those comments and I learned that now my paper got much better and the final version was much better than the previous one. So this is how not only the people at the center but the academics outside also they shaped us. And it is really the place, SNBNCBS is really the place at my PhD years and really the years that shaped us into what we are today. Not only in terms of academics but in terms of the persons we now are. And after submitting my PhD thesis, I moved. It was not really my first choice when I was looking for a postdoc. It just happened that this place just sent me the first acceptance letter, and they had a strict deadline that okay, you have to accept this position within the 15 days. And I thought that why take a risk? Maybe I should say yes, and then I went over to that. Before that, I really did not have much of an idea about how this place South Korea was. because during my stay in SNBNCBS, I had the scope to visit several institutes and universities in Europe, in Germany, in Italy, but I did not have much of an idea about how science is in South Korea. But then what happened that I was an independent institutional postdoc there, but I started collaborating with Professor Gentaro Watanabe there. My PhD was on ultra-cold atomic theory, and Professor Watanabe also worked in the related field, so we started collaborating. But what happened was, apart from, in addition to the academics, South Korea offered me a newer business and different visions of life, and I started exploring the new place, its culture. So it was something completely new to me, and it was wonderful in terms of my experiences. So I not only stayed back in the institute, I roamed the entire country. I explored ancient Buddhist monasteries up in mountains. Along with my institute mates, we went for a conference in a completely snow-clad country. And overall, it was a wonderful experience, not in terms of the academics, but also about exploring life beyond academics. And it is during my stint in South Korea, I got the chance to enhance my academic skills also, because my institute sent me to this Colorado summer school in Economics Matter, because it's maybe one of the best places to be in your Economics Matter. And also, I visited Niels Bohr Institute and worked closely with Professor Christopher Petty, who is a pioneer in my field. And overall, it was a very, very engaging journey. I forgot to say that when I was talking about my journey in SNBNCBS, when I was here, Professor Wilson Peterly, who received his Nobel Prize for first making condensate back in 1995, he visited this center. And again, I remember our sirs telling us that initially the institute offered to put him to some nice hotel in Kolkata, but he flatly refused. He said that I'll be staying in the institute guest house, I want to interact with the students. So again, that was something to learn about. And I remember he was really interacting with the students all day, having lunch with us, having dinner with us. And since I was working in a related theoretical aspects of critical field, my mentors here again suggested me. I remember as well as Dave was our academic coordinator at that point. Why don't you go and talk to him? And I was very nervous. I was very nervous in nature, nervous and anxious. I didn't really have the guts to meet a Nobel laureate and have a one-to-one chat, but that is what happened. That is the miracle SNBNCBS arranged for me. So we really talked for like one hour. From the discussion, I could get some newer ideas about setting up newer theoretical models, and that was a wonderful experience. And later, when I was visiting Colorado, I got the chance to visit the lab of Eric Cornell, who was another person who got the Nobel Prize for the same achievement. So again, I am a theorist, but seeing how this experiment works in the actual lab, that always gives me an extra impetus. So it was, of course, a very, very enriching experience. And when I learned how much time, so I just wanted to show this picture about this proverbial zeros paradox. And I found that in my academic journey, it is always like this, that the Achilles is chasing this tortoise. Initially, the tortoise is the lead, and this is how Zeno originally proposed this paradox. That doesn't matter how fast Achilles can move, the tortoise is always somewhat ahead. So Achilles moves by some amount, but the tortoise always moves ahead. So it's like that. When you are a master student, you feel that your PhD is just a bit ahead. You have to walk up to that. Then you reach that point, there are papers to be published. When you reach up to that, you have to find a good postdoc position, then you have to find a job. So it's like what your goal is always eluding you. But again, if I go back to this concept of working long enough, as you say, we can really be somewhere. For example, since 2016, I am now working in Kelvin University in the department as an assistant professor. And I really, really do like my teaching skill. In fact, I believe that it is the best thing that ever happened to me, especially in the last few years, that I got the chance to interact with a bunch of very, very talented youngsters. I learn from them every day, and I'm very proud and happy today that I get to see some of them here. So some of my students, some of the students I taught in the last few years, and now here in SNBNCBS as PhD students. I think Shomik is here, or Dhendu is here, and also I think Kaushik and Shogab, I taught them, and they are now here in this institute. In fact, many students from our present batch, I think, is now doing summer internship here in this. So this is the moment of pride for me, and I feel that now life has come a full circle for me. So I'm very happy and proud, and I have enjoyed my journey, and I of course always believe that SNBNCBS has the biggest part to play in this case. And just like in the Zeno's paradox case, back then people did not have the idea of convergence of infinite series. But now that we know it, of course the series converges. One can calculate exactly when Achilles can overcome the tortoise. I think so do we. We have a destination to reach, and that can be reached. And this is a quote I'd like to end my talk with. That what this is, I am here to be, however, we don't look backwards for very long. We keep moving forward, opening up new doors and doing new things. It's be a curious sign. Curiosity keeps bringing us down new paths. This is a favorite quote of mine, and I started my PhD thesis with this one. I'd like to end my talk with this one. Thank you, everyone.
So Lata is here. We can ask questions now.
I guess people can interact during the
Yeah,
lunch
people
hours.
can interact with Raka during the lunch hours. Thank you, Raka, once again. The next speaker is Dr. Shubhankar Chakraborty. He is an associate professor in IIST Mohali. Shubhankar,
Yeah, I'm here. Can you hear me clearly?
yes.
Okay. So I would like to share the screen. Is that okay?
Yes, please.
Yeah. Is my screen visible to you?
Yes, it is coming.
It is coming. So can you see my presentation?
Yes, it is visible now.
Right. I don't think it's in a very odd shape, right? Display setting and duplicate set. Okay. Right. So thank you very much for this great opportunity. I'm from 2000 batch. I think this is the second post-MSc batch of this institution. And thank you very much, Sunandan. So whenever I think about Sunandan, the two things come to in my mind. One is singing and other is mathematics. He was actually excellent in both of them. And I'd like to thank Tanushree for arranging this fantastic platform where we can recall and share our journey from SNBNCBS till date. Indeed, it would have been fantastic to be present in this conference in a three-dimensional mode, but due to some commitment, I could not make it. I'm sorry for that. So when I received this invitation, so I was pleasantly surprised because I was completely confused. What should I talk about? Because I realized that there are so many things to talk about, but I'm not trained for such talk. Why? Because the basis of this talk is more qualitative than quantitative, number one. Number two is it is more based on emotion than facts. Then I thought, let's start preparing the talk in an usual manner as we do for a regular talk. What we do when we prepare a talk, we first try to get some figures that can tell the whole story, or at least partially can convey the message we want to convey. So I start searching for good pictures basically. And I landed up with these two pictures. So the top one basically is from some table tennis tournament.
We could not see your picture.
Shubhankar, the pictures are not visible. Shubhankar, your screen is not moving.
Really?
Yeah. Maybe you can answer and reshare.
Can you see this now?
Yeah, but just try moving. Try moving your slides.
Yeah. How about this one?
Yeah. Now it is visible. Yeah.
Okay. Okay, so the top one is with from some table tennis tournament. It's myself, then Mukul is there, Professor Abhijit Mukherjee, then Professor Mani, Mukul Bhai, Munirul, and Indroda. And the bottom one, I'm not sure this is what is all about. This is Muni, myself, Mukul Bhai, and Abhishek. So when I look into these pictures now, this picture says many things. Number one, the first picture preliminary suggests that at least I was busy mainly with sports there. The second picture primarily suggests that we had fun there. This might sound funny, but if you think very carefully, it also suggests that the institution provided us with an environment where, beside doing research, you can also enjoy your life. This is number one. Number two is that these two pictures also suggest the cordial relationship we had, not only among our group mates, but also with seniors and juniors, in addition to the eminent scientists like Professor Mukherjee, Professor Mani, BDR, and so on. So when you talk about SN Bose, we cannot miss talking about Dulalda shop. I'm not sure if it is still there or not. This is the place where all the PhD students from all disciplines used to interact among each other.
Shankar, we could not see the photo.
I'm sorry, at that time there was no picture, there was no digital camera, and I don't have thought about that. I want to tell you the story which can resemble something which we are now going through. What is that story? So at that time, Dulalda's daughter got married. And we asked Dulalda, what does your son-in-law do? He said that he is thinking and planning. So we asked what he is thinking and planning. He said that the family members of his son-in-law are at good government job. So his son-in-law is thinking and planning when he will receive all the property of his family, then what to do with that. So I now realize that we are doing a similar thing, thinking and planning for the future. So let me now tell you how, at least personally, I was motivated to come to SN Bose. During our college time, Professor Abhijit Mukherjee came to teach us statistical mechanics. I think Mukul is there. Mukul can easily connect that. We were actually mesmerized with his charismatic teaching and attitude. And we decided to join SN Bose. And really, this was the reason we came to join SN Bose. Why I'm saying we? Because it happened jointly with me and Mukul, I believe. In SN Bose, we got probably, in my opinion, the best teachers, for which namely BDR, Professor H.S. Mani, Professor Sushant Dattagupta, and so on. In addition to that, we got opportunity to have classes and interact with fascinating scientists like Tanushree, Amitabh Da, Surajit Da, to name a few. So I joined, then I started doing my post-MSc work with Professor Kalyan Mandal. I was his first student. So what I had learned with him, he actually gave me the exposure of this fascinating field of nanomaterials and nanomagnet. And another very important thing I learned from him is that you should continue working even if there is no or very less equipment and very less support, because at that time there was almost no equipment was there at SN Bose. Probably, if I'm not wrong, then I am the first experimental PhD student of SN Bose Center. Then finally, I finished my PhD with Sushant Dattagupta, with whom I learned a lot about dynamics of nanomagnetic material, its relaxation dynamics, and so on and so forth. Now, if you remember, what is the beauty of that at that time in SNBOS was that we had an opportunity to interact with each other. And I am showing you then a real example of that. Look at this paper. This paper was actually published by me and Molloy without any supervisor at 2007, when at that time both of us was the student. So this is what kind of we learned, that if you interact with among yourself as a student, then also you can learn many things and you can do whatever you want. In my life, basically, I never planned for anything. So when I finished my PhD, Professor Dattagupta asked me, where do you want to go? I don't know why, but I said, I want to go to D.D. Sharma. So he talked to D.D. Sharma, and D.D. was kind enough to give me a position. Apart from learning science from D.D. Sharma, which you definitely learn if you are with D.D. Sharma, I learned something very interesting. He always said that, he told me once that science is a business where everybody can gain. You can gain, and at the same time, other person can also gain. After DD, I went to Japan. In Japan, initially I was a postdoc, JSPS postdoc fellow with Masashi Kawasaki. He is one of the leading experimentalists in oxide thin film interfaces and so on. After doing, and it was at Tohoku University. After that, I joined as a scientist with a group of Professor Yoshinori Tokura and Harold Wong at RIKEN. As a scientist, which is equivalent to assistant professor. Then 2015, I returned India and joined Institute of Nanoscience and Technology. It is located at Chandigarh, northern part of this country, and is a very beautiful. We have now, this is new campus, it's a very beautiful campus, and I invite all of you to please come and visit us sometime. I belong to a, now presently I belong to a unit which is called Quantum Material and Device Unit. This is a small unit of 12 faculty members and around 60 students we have, 60 to 70 students we have. And this consists of theoretician and experimentalists who are doing theory of the materials. Then we are performing measurement and trying to prepare different type of devices. Okay, so now let me come to the point that what am I doing right now? So this slide basically represents what we are doing now. We are working on low dimensional material where the electrons are moving in low dimension in presence of some electric field. And these electrons are relativistic electron. So if you think of your BSc classes, then if the electrons are moving relativistic velocity, then at the rest frame of this electron, this electric field is now converted into a magnetic field because of the Lorentz transformation. And now the spin of the electron and the direction of this magnetic field is basically depends which direction electron is going because of the Lorentz transformation. And depending on the direction of the motion of this electron, your spin is now locked. So it's a system where spin and momentum are locked. These are the system which is basically known as Rashba system. So we are working on this kind of materials. In general, we are focusing on oxide materials, especially the interface of two oxides. So this is a real TEM image of our sample, and you can see that we can really prepare almost the best possible quality of the sample in the world. And you can see that these are the two material with a very sharp interfaces, and we're looking into the physics at interface. So basically, if you think, what is the direction of physics right now? So if you think that there are two pillars of their physics among many, one is the special theory of relativity and another is quantum mechanics. Now, if these two merge together, this gives rise to what is known as Dirac equation. So this Dirac equation and related physics were mainly exclusive for high energy physics so far, but recently people have observed this kind of physics in Dirac, Weil or Majorana fermion quasi-particle excitation and related phenomena. So we basically trying to understand or asking the question, can you realize this kind of physics in oxides or not? To just give you an idea so that in future, if anybody is interested, we can interact and work. These are our very recent few publication in last 2-3 years. So if anybody is interested or want sample or want to see the data or whatever anybody wants, can just let us know and we can collaborate. We'll be very happy to collaborate or write a project together. But this didn't come very easily. You might know that our institution is a very new institution. So when we started, we had a very old deserted school building there. So this is the picture of the school building we had, but we worked very hard to transform this into a laboratory. And with a very generous grant of DST Nanomission, I could able to establish thin film facility at INST Mohali, where we have a very fantastic thin film deposition system, which is a combinatorial pulse laser deposition system. And we have a physical property measurement system where you can go up to 14 Tesla magnetic field and going down to 1.8 Kelvin. So now, so far, 4 PhD student has been graduated from me. One is Neha, she's presently working at Cornell University. Second is Ruchi, she's at CNRS. Then Nand Kumar has just few months back and joined IIT Delhi, and Sabina has just finished 15 days back. So with this, I would like to thank once again, and I want to share one thing. As I said, that we are working on what is known as Rashba physics. When we uploaded the paper in archive, exactly the second, and I would like to mention this, Rashba is now 92 years old. So when we uploaded our paper in archive, next day I received this email from him that he actually, Professor Rashba, read our paper and he was kind of very excited with our data. So this was really a good kind of achievement for us, I believe. And this is my website and this is my email ID. So anybody interested, please feel free to contact whenever you want. Thank you very much. Thank you.
Thank you very much for a very nice talk. Do you have any questions? You can ask this point. Or else you can interact later. So the next speaker is Dr. Mukul Kovi, who is also an associate professor in IIT Pune. So Mukul,
Yeah, Shurandar, am I audible?
yes, you are audible.
Okay, so I'd try to share a window. Select a window or screen. Can you see my screen? Is it visible, Shunandan?
No, it has not come yet.
Is it there? No?
No. Have you shared it?
I am sharing, but it's saying that.
Hello, this is a button with an upward pointing arrow. Just click on that.
Sorry?
There's a button with an upward pointing arrow at the bottom side.
Yeah.
Just click on that and then click share.
So it's saying that you are not allowed to share your screen.
Okay.
Mukul, I think you are using Mac, right?
Yes.
So you have to give permission to your security option.
Okay.
So you have to
allow. So share screen is allowed temporarily. That is what I see.
Or alternatively, you can send your PDF file to someone there and they can present for you.
Yeah, that can be done.
You can just send the slides, the presentation.
Yeah. I'm just sending you the slide in the same email that you have sent me an invitation. And if you share that, then I'm very sorry. I should have
sharing through Mac. Can you open the security and privacy option in your Mac?
Privacy option.
Security and privacy.
One second. System preference.
Security and privacy.
Oh my God. Yes, done.
Okay, in security and privacy on the left hand side, there will be an option for screen recording. Just select that. Screen recording.
Screen recording, yes.
Hey, Mukul, if you want, you can send it to one of us. We can share on behalf of you.
The right hand side, there will be option for what browser are you using? Google Chrome or Opera? I mean, sorry, Safari. Which browser?
Yeah, so it says quit and reopen. So shall I do that? Quit and reopen.
We can reopen. Have you enabled the option for Google Chrome or Safari, whatever you have?
তোমারটা ইয়ে করো, ইয়ে আছে তোমার, আনমিউট করো, মিউট করা আছে তোমার।
So now you can see my screen, right?
It's fine.
Yeah. Okay, fair enough. So I thank the organizers first for this opportunity, because to me this is a great opportunity for re-acknowledge many of my friends who I have acknowledged in the past, and many of my friends I have never got an opportunity to acknowledge. Okay, so this is an opportunity to do so. Okay, so for that reason I thank the organizers and asking me to share my journey. So what I would do, I would share my scientific journey, and I will not stop at any stoppage other than SN Bose. I would briefly talk about my other journeys, but I will mostly concentrate it at my time at SN Bose. So before, so if I have to talk about SN Bose, I should actually at least start 2 years back before I joined SN Bose. Okay. I mean, if I don't tell you that story, then probably like you will not understand of what SN Bose Center means to me even today. Okay. So this is what I was before joined the SN Bose Center. I was doing my master's at the Presidency College at that time. But to be precise, I was doing MSc at the canteen of Pramodha. Okay. So I was probably not very interested in attending classes and all these things. Rather than that, I was probably educating myself in the canteen. Okay. So it's being a very informal talk. I'm taking liberty to talk and show something which I would probably not show in a formal gathering. But yeah. So my life then actually had two very distinctive phases. Okay. So I would rather smoke a India Kings at the canteen. Shivankar might remember. Okay, so because he was my partner all along those days.
I think we are going to lose our job, Mukul.
Not a problem, not an issue. So and then so why I say that my life had two phases and one was more real than the other. And I would go back to my my hostel and I will go from red to blue because that is what I can afford. Okay. So this is who I was. Okay. And I had no specific purpose in life or in career. And then I and many of my friends at that time was awestruck by this charming man. Okay. And so he was a guest lecturer for a couple of months teaching symmetries in quantum mechanics. It was a very early morning class. I never attended most of the classes, but I never failed to attend his class. Okay. And later on, like, he described himself. He himself described him as Chile Dhara. If you know Bengali, then you understand what it means. He was basically was going there to teach, to motivate people and bring people to SN Bose Center as a PhD student. Okay. So that year, me and Suvankar came to SN Bose. Many of other friends, many of my juniors actually followed this train, like Malay, Aftab, Shudipto, all came from Presidency College to SN Bose. So I am hugely in date with Professor Mukherjee, not because later on I became his student, but because, like, when I had no purpose in life, I just saw him and thought maybe I can do science. Okay. And then I came to SN Bose Center. Initially, I was a non-PhD project student with PKM. If any of you remember, for a year or so, I was not a PhD student. Shubhankar joined as a PhD student that year. Okay. I joined next year as a PhD student with Professor Mukherjee, initially, which was funded by Warwick University and then by DST. So basically, I was about to work on assembly of few atoms, which is scientifically termed as clusters. So I picked this problem because at that time I thought that I would require a little more freedom, and nobody previously worked on clusters in that group. So I picked up that topic. Okay. So then when I started my PhD, I was doing anything but doing research. Okay. I think many of you can resonate with that, but like, you know, so my inertia from Presidency College didn't actually stop. I was not doing anything. Okay. And okay, fine. I was doing everything else, but probably not that well in research. And at that time, I remember that I used to stay in room number 311 or 317, I guess, 317 in the guest house. And that room was known as SN Bose Bar. Okay. And if you remember that we had a senior called Manikam, who used to work with Professor Sandeep Chakravarti, he gave that name. Okay. His room is SN Bose Bar. For what reason? Let us not discuss that. But I'd say that, like, you know, this and when I started my research very actively, this was my best time of my life. Okay, I mean, best ever. Okay, and I will soon probably I'll convince you guys that why so. Okay. So then soon, in a year time or so, I had no other option but to put more time to research. So and then there come the first paper, which was a huge heartbreak for me because it was outright rejected from Journal of Chemical Physics. Okay. And then Professor Mukherjee said that, okay, fine, now you can submit it to International Journal of Modern Physics B, which he was an editor also at that time. So I said, no, I think that we can actually do better and submit it to physical review journals. And I think that I am right and referees are wrong. So why don't we submit in physical review? And he, being a nice man and never said a no to anyone, he said, okay, go ahead. Yes, do that. So we submitted that to physical review physical review A, and it was single shot accepted. So my first heartbreak at SN Bose was also a success. Okay. Then there was a lot of interest in looking into magnetism in few atoms, and that time there was a lot of experiment going on at Argonne National Lab, and I was closely following those experiments. Okay, so I got into looking into manganese and few atom manganese, and I think, like, you know, a lot of my paper from PhD involved manganese. So so my friends used to call me at that time Cluster Mukul, and I thought I was in love with manganese also. Okay. And then many people actually, like, you know, a journey is well traveled when you get a lot of friends with you. Okay. And when it comes to science, I got many people who came along. So I would take this opportunity to mention few of them. So it was Professor Kanere, who I also worked with during my PhD. Okay, so I came to work in his lab in Pune, and I literally lived in his lab and slept in his lab for 3 months. Okay. And then Tanushree was always a mentor. And then I worked with Shaumendu and Srimoyi. Whatever I learned during my PhD, I was transferring those knowledge to these two brilliant people at the time. And then I also worked with one of my good friend from then, Shuditto. We worked together on some DNA based pairings. Okay, Shubhankar, we never wrote a scientific paper, but a day didn't went by without we two discussing physics since our masters at presidency. Okay, so we discussed physics in a burning heart. We discussed physics in Maniktala cemetery. Okay, we discussed physics while riding a bike. Okay, and then it was Sriram who also infused like how to learn computers. Okay, I was amazed by his experience in computers, and he taught me how to learn things when it comes to computer. More than teaching me, he taught me how to learn. Okay, so a lot of credit goes to him. Then Biplabda was at Uppsala at that time, and I mean I was probably the first student who went to Uppsala as an exchange student. Okay, and that trip actually gave me a lot of confidence that yes, I can probably do things. Okay, and Shushanta Dattagupta was also very helpful. Okay, in many things, and I also have seen how SN Bose has grown under him, because I was one of the earlier students who joined SN Bose at the time. Okay, but every good thing had to end. Okay, so and I had to move on in my life, and okay, but before moving on, I should also tell few more things. Okay, so there were a lot of friends that we had, as previous speakers were also mentioning, and we always felt like a family there, because it was less number of students, and everybody is doing everything together. So a lot of seniors, a lot of crazy juniors. Okay, everybody was helping everybody in that. And then I remember at that time we had a coffee center which we used to run. Okay, and many things happened over coffee. Okay, and a thought of it. And I still remember that if any one of us is going to give a talk in a conference, okay, after dinner, everybody will sit in a conference room, and that person will give a talk n number of times. Okay, and my seniors, my juniors didn't ever say no. Okay, maybe I also had to tell, okay, fine, I will make coffee for you for next 3 days, but please come to my talk. I will give a mock talk, and they will listen, and give their feedback. Somebody will keep the watches. Okay, and I also think that my SN Post journey is incomplete if I do not acknowledge Dulal Das' contribution to many of us. Okay, and this is what I wrote in my thesis, that in the acknowledgement part. Okay, I literally acknowledged Dulalda, because he tolerated, rather than anything, he tolerated us for 5 years. Okay, I mean, he's sleeping, we are knocking that we were hungry, I need food, nothing. He was always there for us. Okay, and we used to call him a random number generator. Okay, so we 5 or 6 people will go, we'll order n number of things, and then when we ask Dulalda kitna hua, like, you know, and then he will say, like, he will randomly tell us some number. Okay. Okay. So it was absolute fun at SN Bose, and also sometime would be guiding us like a family member. So I remember that many times I didn't sleep through the night, and in the morning I will go to Dulalda's dokan and say, like, you know, give me breakfast. So in few days time he understood that I didn't sleep through the night, and he once scolded me saying that, like, you know, if you are coming tomorrow, I'm not giving you anything, so go and sleep at night. Okay. So yeah, and then yeah, as I said, that every good thing has to end, and I had to move on. So I joined, I finished my PhD in 2006 and joined MIT and stayed there for 5 years until I was kicked out and my visa was got over. Okay. So yeah, so there I worked with two brilliant minds. One, if you may know, is Sidney Yip, is a very famous person in studying defects in materials, and another experimentalist. She's also very famous now, is Kristen. So these two people I worked with. Sidney was a theoretician and Kristen was an experimentalist. And there, what I actually was looking at is how to cook steel, okay, which I had no idea, because my PhD was in a completely different field. And then I was hired to do something which I have never experienced with. Okay. So I was like working on steel. Okay. So once I was traveling from airport to MIT in a cab, and then cabby asked me that, what do you do? And I said, like, you know, I work on steel. And then I remember he said, so you don't know how much carbon you need to mix. I was very surprised that, like, you know, he knew the exact problem in steel. Okay. So I used to tell people that, like, you know, I work on material failures. I worked on material failures, and these materials are like humans, and they fail due to their defects. Okay, but it was a very complicated problem, at least to me, to tackle with. Okay, so then after 2 years, since this was not what I was trained in my PhD, so I worked on this field for at least 3 years, and then the next 2 years at MIT, I chose my own problem to work on, and I went back to electronic structure theory again. Okay. So, and then I came back to India in 2012, okay, and joined ICER. And since then, I lead a group where we study quantum materials. And what we do is like, you know, we couple various degrees of freedoms, like spin, charge, orbital, lattice, and topology in recent times, to understand various exotic and emergent phenomena in quantum materials. So at present, I have six PhD students. Two of them has graduated already. So I would also like to, I mean, many of you already know that, like, you know, I have been a part of I Have Quantum Technology Foundation, which ICER has been funded with 170 crore funding for next 5 years. I am one of the PI, and many of you present in today's meeting are collaborator in that hub. If you are not, you can also contact us, and we can figure out how both of us can contribute in that. Okay. Okay, so this is what in a sense. So I'll take one more minute and finish it. So I have seen many success, but what is actually my journey is not complete. If I tell you my journey all about my success, it is not probably complete, and that also doesn't tell me who I am. Okay, so I will tell you something which is probably what made me and where SN Bose transformed my life. Okay, so I'll share with you guys my failed CV. Okay, and it started with I failed to crack joint entrance test. Okay, both in engineering and medical. Okay, then my father wanted at least to study homeopathy. Okay, so I failed that test too. Okay, I was among the last few students who admitted to MSc. I failed the first ever SSC exam. When I didn't know what to do with my life, I sat for an IB exam and never knew if I probably I have failed, but I don't know if the result were out. Okay, and then I also failed the PhD admission test in 2000. So I am a 2001 batch. My first research paper was rejected. Okay, and that failure continued. Okay, so now you can understand that how SN Bose transformed my journey, and I would like to take this opportunity again to thank all of my seniors and juniors and faculties who helped me in shaping who I am today. Yeah, so I'll end it here.
Thank you very much for the wonderful talk, presenting a wonderful experience in the center. So, are there any questions from the audience? And from the online people, online mode?
I have a comment, Sunando.
Yes.
Sunandan, I have a comment.
Yes, yes.
Okay.
Mukul, your first
Yes.
heartbreak is a rejection of paper. How unfortunate you are.
No, fast heartbreak at SN Bose, I mean.
Okay, Mukunda, I have just a small query. In the beginning of the slides, you showed that college BDG. So, is that brand still available now at the SNBNCBS college?
What?
That college BD that you showed displayed.
I don't know. I don't know that it is still available or not.
No, I think Mukul is kind of lying. We didn't have college BD. We used to have Dum Dum BD.
Okay.
It's being recorded. That's fine. Thank you, Mukul, for the wonderful talk. The next speaker is Dr. Shora Bhattacharya, who is an associate professor in the Department of Physics, Dartford University. Shora, please. Good afternoon, and first I'll thank the organizers for So, good afternoon, and first I like to thank the organizers for asking me to be a presentation in this nice. So, the title of my talk is "Experiencing the Dark Energy." Dark energy is a kind of my theme of my research. Okay, so yeah, so here is a brief academic history of mine. Uh, I undergraduated from Presidency College. Then it was a college, not university. Then I completed my master's from Calcutta University, Rajabhajan Science College, and I joined SNBNCBS Center as a PhD student in 2005. My supervisor was Professor Amita Lahiri, and you can see it's almost half a century back, right? 2005. So, yeah. So, after that, after submitting my thesis in 2011, first 2005 to 6, I did my post-MSc coursework, probably now also you do. And I submitted my thesis in 2011, and then I went for my postdoc. My first postdoc was at HRI, Allahabad. Then I was at Crete Center for Theoretical Physics, the University of Crete. And postdoc 3 was at IUCAA, Pune. And then in 2017, I joined IIT Bhopal, Department of Physics. And currently, I'm lean means lean is a kind of lean, and I have joined the physics department of Jadavpur University as an associate professor only last Monday. And there is a it's physics department, but there is a center where I'm affiliated to also. It's Relativity and Cosmology Research Center, and its legacy is associated with the great A.K. Rai Choudhury. Those who do relativity have heard the name of Aman Kumar Rai Choudhury, the famous Rai Choudhury equation. And there is a office there, and Rai Choudhury used to come there and do calculations. And there is a very old almirah there also. And every senior member of the department says that Rai Choudhury's calculations are kept there. Okay, but I have not been yet able to locate the key. I want to find out the key, and I want to make those papers visible to the public. Because Rai Choudhury was a great person, but unlike many other Indian physicists like Bose or Saha, he did not get the due recognition, right? And his works, his calculations should be visible to the public. That's what I feel. But let me find the key first. Okay. Sorry? So yeah. So starting the PhD. So as I said, I did my PG masters in Rajabhajan Science College, Calcutta University. And during that time, I didn't have any exposure to research, to tell you the truth. Okay, because in those days, internet was not a very common thing, and I don't know whether you believe me or not. I never touched a computer until my MSc. I did not have any. Obviously, I didn't have any email ID. The first email ID I opened when I was being called for PhD interviews after my MSc. But in those days, somehow I had a vague idea that I want to do nonlinear dynamics. And nonlinear dynamics is thought that I should do specialization on something which will help me to pursue this research. Plasma physics was this subject taught as a special subject in Calcutta University in those days. And hence I specialized in plasma physics. I learned a lot of magnetohydrodynamics, KDB equation, Laskov equation, and many. But after that, when I started to go for interviews, started talking to people regarding and started to build some idea about what research is, I thought that no, I don't want to do nonlinear dynamics, and hence I abandoned the idea.
So when I joined the pre-PhD coursework of SNB at SNB in 2005, I really did not have any idea that what I'm going to do. I thought that I should keep my mind open, and I just keep in my mind that I want to do theory. I should keep my mind open, and then give myself some time, and then I will decide after the first semester course. As far as I remember, there were 5 courses running in those times. All of those courses were very excellent. But there was one course, quantum field theory course. The instructors were Professor Robin Banerjee and Professor Amita Lagri. Actually, that course was a very decisive thing in my career. So, to tell you the truth, I had no idea whatsoever on general relativity or quantum field theory. I never read those things. And all those courses were compulsory. And to tell you the truth, I didn't like quantum field theory much, because every time I thought, every now and then people are exchanging dummy indices and doing this and that and big letters, new lambda rho. I got frustrated. Okay, the first one. And I'll also give you this information. We all were really scared about Professor Robin Banerjee. He was the first half instructor, and he will ask us that, tell me whether you have understood or not. So we'll say obviously that we have understood, even though everybody does this thing. Then he will come here. He will give us a chalk and say, show me what you have understood. The next day, the same question, now we have learned. You will say, no, we have not understood. Come, show me what you have not understood. I mean, we were very scared actually. But then, I knew that I had to do this thing, otherwise I will fail this course. But then I started calculating this, in detail, what this thing is. In a couple of weeks' time, I thought I have found what I want to do. By that time, I also was learning a little bit of GR. There were seminars going on, theory of relativity, and I knew that this is my thing. I should do GFT and GR. And I must tell, both Professor Banerjee and Professor Lahiri's teaching was fabulous in this course. So after finishing the coursework, so I also did a project under the supervision of Dr. Vishwajit Chakraborty on conformal field theory. So I joined Professor Lahiri as a PhD, and he suggested working on black hole space-times endowed with a positive cosmological function. So you must have seen this diagram published by NASA, actually maybe infinite number of times. So, but just I wanted to tell you this, that this positive cosmological constant is something called dark energy. Okay. Dark energy, our universe, by the way, is not a static universe. Okay. It's time dependent, it is expanding. You take 2 stars, any 2 stars in our universe, their separation is increasing with time. And the increasing rate is also increasing with time. It's the recent data. You can see this slope, it's slightly increasing. And imagine this is surface of the universe, and it shows that it is ever increasing. Its age is almost 14 billion years as of the data. What data says. And we are living here, and we have this accelerated expansion. This discovery, this observation, was made by 2 groups of astronomers in 1998 and 1999, Rice and Perlmutter, and they got the Nobel Prize in 2011. So I'm talking about a time in 2006. So not many people were convinced that this lambda, positive cosmological constant lambda, needs to be taken seriously. Okay, but there were later on many overwhelming evidences which proved beyond doubt that really this universe must be endowed with lambda at the current phase. That is, this phase, there was much faster accelerated expansion that is called primordial inflation, that is related to my current research interest. I'll come to that. Okay. Here is a little bit technicality, but it's not really technical. So such accelerated expansion requires some exotic matter with positive energy density but negative pressure. And it is dictated by the Einstein equation. These are called dark energy. It satisfies well some inequality, and when this low energy density is a constant, It is the simplest model of the dark energy. It is the cosmological, called the cosmological constant lambda. And this lambda CDM stands for cold dark matter. It's also kind of mysterious matter, which does not interact with electromagnetism, so you cannot see them actually. But their existence has been proven by most overwhelming astronomical, astrophysical observational evidences. So nothing are here, I mean, what I'm saying are fancy stories. These are based on facts, on observation. So when this lambda or the simplest T plus Tm, dark matter, actually contributes around the 95% of the mass energy project of the universe. That means the matter we are made of, the standard model matter, the solar system is made of, only contributes 5% mass energy to the universe, total mass energy of the universe. Whereas 95% is these dark things, dark energy and cold dark matter. And although we can see, we can measure their effects, gravitational effects, but quantum field theoretically or microscopically, what they are actually remains open question, outstanding open question. And my research interest is the single theme of my research, which is dark matter. So I must tell you that there has been 3 breakthrough recent discoveries in the field of gravitation, cosmology, high energy physics, quantum field theory. Nowadays, we should not distinguish between these disciplines. Number 1 is the one I mentioned, the recent accelerated expansion of the universe. Number 2 is the discovery of the Higgs in 2012, I think. And number 3 is the gravity wave, discovery of gravity wave 2015. So the first has opened up arena for understanding the dark energy and dark matter. Okay, and in modern cosmology, there is no modern cosmology without a lambda. Okay, without a cold dark. So during my PhD, I chiefly investigated the uniqueness properties of stationary black hole spacetime. A positive lambda repels matter. Well, it creates some kind of horizon, and my key focus was to see the local effects created by this large scale boundary. In fact, in our first paper, we proved that there is significantly local physics can be changed by this large boundary, and it was published in PRL, but it took some time, and Professor Lai always encouraged me that no, we should not give it up. It took arguments, we should fight with the referee. Yeah. And then during postdocs, I was at HRI. I continued some works on black uniqueness theorems, and also works on aspects of equation astrophysics. For example, in this work, we use the idea of fermion Lie derivative. To the best of my knowledge, is the first time we have applied this concept in some physics problem. Fermion Lie derivative is Skinner's Lie derivative is a mathematical problem. I did Center for Theoretical Physics. I work chiefly on alternative gravity theories. Alternative gravity theories means there are reasons to model this lambda with some kind of dynamical matter field, usually a scalar field, and to see their consequences. We calculated, made theoretical calculations. We wanted to check them with the observed data, and those data were chiefly related to stability of something very large scale structures, very large scale superclusters. And then my mentor there was Professor Theodore Tomaras. And at IUCAA, I continued working on alternative gravity theories and also started working on some aspects on quantum field theory in cloud space. My mentor at IUCAA was Professor Helmholtz. And I must mention here that I lost during this pandemic period both my mentors, senior mentors, Professor Tomaras and Professor Padmanabhan. And this is a terrible professional loss to me, and as well as I find these losses are very personal. Okay, recent direction is related to the primordial cosmic inflation. Let us move to this diagram figure. So
you see that this is somewhere at the beginning of the universe. Something happened. It's called Big Bang. What is it? We do not know really. Okay, maybe some non-conservative quantum gravity effects was going on there. We do not know. But after around 10 to the power minus 32 seconds of this inflection, the universe needed to expand very rapidly, at a very rapid rate. That is called the primordial cosmic inflation. And this is necessary because of the large-scale homogeneity and isotrope of our universe, what we observe. Okay. And although inflation might seem a logical possibility only, but there are many other observational evidences as well of inflation. So my research interest, present research interest, is focused on this period. It started at 10 to the power, at the age of 10 to the power minus 32 seconds of the universe, and it lasted no later than 10 to the power minus 12 seconds. So, but some very interesting things happened in this time period, and that's what my present research focus is. Yeah. I must mention some open questions related to inflation. And these are outstanding open questions and related to understanding the very basic nature of our physics. We should always remember the energy scale of the inflation can be close to the God's energy scale, which is 16 GeV kind of stuff. So no man-made accelerator can actually reach that kind of energy scale. So things that going on there during inflation may have a may actually lead into so open questions are, for example, starting from the early inflationary universe endowed with dark energy, how did we reach the current before where its density is so much tinier? What it means that at the early universe, the accelerated expansion was very fast. That means the dark energy density was very huge in those times. But here, the accelerated expansion is low. It's extremely low compared to early times. So what happened then? That the inflation ended, and the lambda value we observe today is so small. It's so small. What is the mechanism? This is a very important question. This is because if the lambda value was 10% higher, only 10% higher than what we observe today, our universe would not have formed the way we see. Collapses could not have happened, or could not have been existing. And if the lambda value was 10% higher, the universe would have been very old, look very old. This is a kind of fine-tuning problem, and physics we don't like fine-tuning. Okay, we want always to give some kind of mechanism, and which explains this, which fits into the picture. We just do not want to give this idea of accept this notion that well, it is as it is. It has been given like. So this is also known as the cosmological constant problem. So probably you have heard this. And how did this inflation ended and we started a thermalized era? How did inflationary cosmological perturbations, which were quantum field theoretic in nature, became classical? This is called the cosmic decoherence problem. And can the inflationary quantum gravitational effects in the cosmological constant? In particular, my research project present research is lambda really vacuum? We do not know what lambda is. The chief goals here, well, this is related to some kind of resummation of loop effects from loop processor in the receiver space. And here I'll skip that. And we already have started publishing in this direction. And there are a couple of papers which are in preparation with my students. Well, I have three students, Nitin Joshi, Sudesh Kumar, and Shagun Kaushal. Shagun and Nitin will be submitting next year the thesis. And I also had two postdocs in our group, and they have completed their tenure. And yeah, and also project track. Okay, I just wanted to mention another thing. I talked about academics, but I must also tell the excellent ambience I had during my stay here at SNB, both academic and also non-academic. The non-academic sessions usually had the rooftop of lab course, but I'll not go into the detail. Okay, thank you very much.
Hello. Nice talk. So, are there any questions? So, if there are no more questions, let's stop this session at this point. And the first thing, at what time should we start? 2:30. 2:30. Yes. So we shall meet at 2:30, and lunch will be for students. The lunch is available outside. And for the alumni people, we shall go to Radha.
afternoon. I hope you have finished the lunch. Put the video on. Samitra, are you around?
Hello? Hello?
Yeah.
Am I
You have to bit louder.
okay? Is it okay? Is it okay now?
Yeah.
Can I share my slides?
Okay. Good afternoon. Welcome to the afternoon session. About 15 minutes. I request our time.
Hello?
Yeah.
Am I audible to everyone?
Yes, yes.
Okay, that's fine. So, hello and welcome back after lunch. Hope you all are having a quite fulfilling day. But it's unfortunate that today I cannot be present with you all. But never mind, I keep visiting SNB from time to time, and it's always very warm and welcoming every time I go there. So, first thing first, let me acknowledge all the people, all the professors who have really helped me to shape my academic career. And with that, I would begin with my professor and my my PhD professor, Professor Ranjit Bishwas and Professor Michelle Vogel and Kramer, with whom I did my postdoc in Germany, and then with Professor Sanjay Bonthang, where I am currently working as a senior researcher in the Department of Chemistry at IIT Kharagpur. So when the organizers invited me to give a talk, first of all, thanks to all of them and the faculty members for giving me this opportunity to share my experience. It was quite. I was in thought like how to give an outline of my science work, because SNB is a place which did not only helped me to build an academic profile, but also gave me a life much beyond it. So we will come to that afterwards in a while. But to begin my journey, so my PhD actually, I joined the group of Professor Vishwas in year 2009 as a junior research fellow. And there I worked till 2014. My thesis titled Computer Simulation Studies of Multi-Component Melt Mixtures, that are deep eutectics we worked on, and ionic liquids majorly. So in this work, during this 4 to 5 years time, we mainly tried to investigate the computer simulation studies of different structure and dynamics and dynamical modes of motion in these complex liquids, which are very interesting in nature for studying in bulk, because they showed dynamic heterogeneity and cooperative motions. The reason because they had some polar and apolar regions showing varying dynamics. These are much in details about the work, but to outline that this was majorly the work we did, and during that time, we were the first to start the simulation studies on ionic liquids in the groups, because I remember 2 of my seniors were then busy doing analytical studies of ionic liquids. So after that, after finishing my PhD in 2014, in July, when I submitted my thesis, in a 2 months to 3 months time, I received my postdoctoral offer from Germany, and then it took like 2 months more to defend my thesis, and finally in 2015, I started working with Professor Vogel in TU Darmstadt, Germany. And there, my project was more extended with ionic liquids in bulk and confinement, because they wanted to make the project was a German Foundation project, funded project, where they wanted to correlate the different length scales and time scales of simulation in models, not just in atomistic level, but also to the coarse-grained levels. So they wanted to study this, and initially we started with bulk simulation, and then we further extended to ionic liquids in confinement, because they are very interesting features that they show at the interface. So to help us with the next level of study was like with the coarse graining study, which was one step further towards the multi-scale simulation. And this coarse grained simulations, we took the help of Professor Kremer, who is well known for developing force fields for different polymer liquids. So for ionic liquid, we used the structure-based coarse-grained, the iterative Boltzmann inversion techniques to reproduce correct structure for this for a model liquids like ionic liquid. And we used iterative generalized Born-Green technique, by which we could consistently, we could build a model that was dynamically consistent and reproduced quite accurate results with that of an atomistic simulation over a wide temperature range, which is otherwise quite difficult with many liquids and ionic liquids, ionic kind of liquids, ionic solvents. So with this, this was around 2018 that I finished my postdoc there, and definitely my postdoc journey was quite wonderful because of the wonderful people I met there, both in the field of science and also good friends. After that, I moved to the group of Professor Sanjay Bandyopadhyay at IIT Kharagpur, mainly because he is well known for working in the field of biomolecular simulations, ranging from proteins, DNAs, and so on. And also because during that time I was also being interviewed at some of the places for academic positions, so I found that quite favorable to come back to India and work in his group. When at the time he was very curious to understand that how this polypeptide chains or the protein backbones, how they actually behave in the presence of not only just normal solvents like water, but in presence of ionic solvents. because there are forces which drive protein stabilization, like the hydrophobic interactions, the ionic interactions, the hydrogen bonding. So how are they actually favored or disfavor a protein stability and their structure was his main thought behind this work. So we started with globular protein, which is a more compact shaped protein, and that was human alpha lactalbumin. That's mainly responsible for breast cancer, and also intrinsically disordered protein, which is way different from globular proteins in a sense that they basically don't have any native structure. They are quite flexible, and they are interesting in a sense that if we, most of us know that in aged people, a specific protein known as amyloid beta, when they deposit or they form aggregates in the extracellular matrix of our nerve cells, it leads to the memory loss or cognitive decline, what we say. And this is one of the reasons why intrinsically disordered proteins are quite interesting. So amyloid beta protein is mainly responsible for Alzheimer's disease, while there are other proteins like alpha-synuclein, which is more responsible for this Parkinson's disease. So this intrinsically disordered protein mainly that was the main reason why I wanted to work in his group. And when I looked into the studies, we were doing this peptide study with a monomer and with oligomer systems. Then it came to my mind that if it is all happening in the nerve cells or this neurodegenerative diseases are taking place in the brains, then how does actually or where does this actually take place? So when I looked up into different papers and books, then I found that mainly, if we see, this is a beautiful picture sketched by Leonardo da Vinci, and this is the side view of the skull of the human brain. If we see that there is, sorry, so there is basically this hippocampus part, which is a region of the temporal lobe, and that is mainly responsible for these memories. So any loss of memories or cognitive decline leading to dementia, it mainly arises from this. And most importantly, that how our thoughts, like what we think, what we decide, and what we imagine, where all these ideas come from. So the secret mainly lies in the brain cells, that how we connect the brain cells are by active neurons that constantly strive to build up electrical potential or impulses, which is known as synapses, that actively tries to connect with one part of the brain with the other. So any change in this hippocampus part, for example, can lead to the change in our personalities, in our actions. We can lose our memory, which may be due to also disease or maybe due to some kind of injury. So basically, brain is the like a powerhouse of all the information, is one of the central to our lives in terms of all this intricate things going on. And another thing, what I learned is that if we see from the top view of the skull, we basically see there is a left part of the brain and there is a right part of the brain. So brain left part mainly helps in reasoning and logic and skills development, our radical and rational thinking is mainly taken care by the left part, and the right part is more on the emotional side and our feelings and creativity and imagination that stems from the right side. So as you can see that the two parts of the brain deals with two different things, and it's very hard to find a brain and where to find a brain where you can get like equal contribution from both, because it is shown that at a time only one side of the brain dominates, either in terms of logical thinking or in terms of creativity. So it would be interesting to mention here that science is just not a creative thing, it's not just the regular things we do in the lab. It's more like a creative thing that we do in terms of music and art, because as scientists, we are always capable of, and we are always venturing to know the unknown. with the help of curiosity-driven facts and informations. So to say the least, that brain in a nutshell is a powerhouse of all the innovative ideas. And to, as E.O. Wilson, one of the biologists, famous biologists, said that it is a very complex object in the universe probably known. With that, before winding down, I would like to mention an inspiring quote that since it is all in our thoughts, well, René Descartes, one of the French philosophers, said it quite rightly that whatever we think, we become. It's like, I think, therefore I am. So how we think, how we creatively we can think, how differently we can make a huge and tremendous impact on our own lives and also to the people around. So with that, I would like to finally say a few words of praise for SNB, our alma mater, that SNB has given us so much, not just me, not just in terms of academic background, but it's one of the rare places or institutes that we find which also helped us to nurture the scientific, the creative mindset. And it's beautiful because whenever we come there, it brings back memories of now and forever. It will be etched in our minds. The green campus and the beautiful golden days, the fruits and flowers, whatever we find them, are so beautiful that we can never forget. And the place has been so warm and welcoming. Not just the faculty members and non-academic people, but also the canteen boys and the security personnel have always helped us to feel that we are being loved whenever we go there. So with that, I would share two slides. First of all, here, as you can see on the left side at the top, with Professor J.K. Bhattacharya standing in front of this of SNBNCBS statue with Professor Graham Fleming and Professor Shondip Chakraborty. And with that is my Professor Vishwas. On the right-hand side is Professor Arup Kumar Rai Chaudhary, who was then the director of SNB. On the left side bottom, you can see this new Silver Jubilee Hall. It was new then. Now where you are sitting right now, it's like 5-6 years old probably. So there, if you can zoom in, I can see Mr. Deb is there. So he has been one of the wonderful people I am still in touch with, who has helped me really in various official stuffs and paperwork during my PhD time. And on the right-hand side, you can see a chunk of these students surrounding Professor Mukherjee, and following which there are many photos I find with Professor Mukherjee, which is quite incredible, because in all of those cultural events that we took part, Professor Mukherjee was one of those enthusiastic person who was always there encouraging us, and we were, and like every year we had different cultural events like Bose Fets or Ravindra Jayanti, and there down we can see the image from Ghare Baire set. So with that, I would like to thank you all and for giving me this opportunity, especially the organizing members. And it's indeed a pleasure to talk and share my experience, but it would have been wonderful to be there. Thank you very much.
Thank you, Dr. Is there any questions or some query you have? Online participants? Yeah, online participants have some questions. Thank you very much, Dr. Paul. And our next speaker is Dr. Dr. Chakraborty.
Snehashish, are you there?
Yes, sir. Yeah. Can you see me?
Yeah. Here I see you. Now you have to
Okay. Okay, let me share my screen.
Snehashish, you did not take bath or what?
Huh?
You did not take bath?
Oh, no, I have done. Okay.
Yeah, please go ahead.
Can you see the screen? Can you see my screen?
Yes, it's visible.
Okay. Is it full screen now? Okay. I actually can't hear you properly. Okay, fine.
I hope this is
Okay. Okay.
Yeah, good. Go ahead.
So good afternoon, everybody. I am Sriasis, and I am currently working in the Department of Chemistry, IIT Patna, for the last 5 years or so. And here I will basically talk on my journey from SNBNCBS back in 2008 to what currently I'm doing at IIT Patna. So I have the title I have chosen definitely is not very informal. It is kind of scientific title: Complex Interaction and Dynamics in Chemical and Biological Systems Using Theory and Molecular Simulations. And that I have chosen because my journey all along from SNBNCBS to IIT Patna was actually in this around this topic. So I can surely say that this journey was academic journey, and the topic was always revolving around interaction dynamics of chemical and biological systems. So I joined SNBNCBS Center in 2008 as a junior research fellow under the supervision of Professor Ronit Biswas. And I started working with him some simulation models, some model liquids using computer simulation. And I remember the first day I visited SNBNCBS Center when I was just completing my MSc, still not completed, and I went to see Sir in his cubicle. In that time, the cubicles were there for professors in the second floor, and I just went to meet him after the interview. And I asked him, I want to join with you, but what kind of works I will do? And I am interested in proton programming. So because in my MSc, I did not know anything other than proton programming, which is relevant for research. And he said that, yeah, computer simulations you can do, but computer simulation is like you can increase the you can change the temperature of liquid water, and you can study the dynamics and structure without pouring water in the computer. Okay, this was a very excellent introduction about computer simulations. So because in my MSc days, there was no project, so I did not know anything about research. And I remember I asked the very first day to Tuhinda. Tuhinda was the senior most person in my lab, in our lab. So I asked him, Tuhinda, how many theses you have published? Because I did not know the differences between thesis and paper. And that was quite interesting. And Tuhinda smiled a lot and then said that, yeah, actually I have not published any thesis yet, but published quite a few papers. Okay, so that kind of background I had before I joined PhD in SNBNCBS, and you can now understand like what I have got from SNBNCBS Center. It was an amazing experience. Everybody has said here in this today's meeting, so I don't want to repeat it, but I definitely want to mention that SNBNCBS Center has given me many things. Academically, I can say that I have learned from zero to some level, so definitely not 100%, some level in chemistry and physical chemistry, and the communications and network with physics people also was incredible. So in my PhD days, I started working on computer simulations of simple liquids. And the most important thing I should actually mention to the students present over there who are interested in doing some molecular simulation studies, computer simulations, I did not use package. Okay, so that was definitely not very fancy. I actually started writing programming codes, and that was influenced by my supervisor. that you should write your code, and definitely I should tell that it helped me a lot, because to understand some subject you have to do from scratch. So although I could not work on very relevant biological and chemical systems, very simple model systems like Stockmeyer fluids, Gay-Bond models, but I learned a lot because I wrote all these things from Ewald summation to integrate Newton equations, to calculate forces, to write the ensembles, NVT ensembles, all the thermostat, barostat, everything myself. So I learned a lot. But nowadays, I'm very sorry that nobody writes programs for simulations. They write something for analysis, but not for the overall simulations. And then after 3 years, I started shifting onto another problem, which is basically using same molecular theory, analytical theory, and to solve very interesting problems. That time, my supervisor was extremely successful in understanding the Stokes dynamics of room temperature ionic liquids, and already Dr. Hemanda is here. He started all these problems for pure ionic liquids, and I followed up. After he left to Iowa, I followed up and did the similar works, but in the binary mixtures. And these works were so tremendously popular, even experimentalists, which is the most important thing for theoreticians, that experimentalists are comparing your theoretical results, and they are showing how close our theoretical agreement was. And one of the results I am showing here was by Professor Maroncelli, who is very famous in solvation dynamics, and he and his group actually is were working on these Stokes dynamics and Dirichlet dynamics of room temperature ionic liquids and the binary mixtures with dipolar solvents, and they actually used they compared with our theory. That was fascinating for me particularly, definitely for my supervisor also. After completing 5 years, learning a lot of things, I am ever indebted to my supervisor for this, and definitely my seniors, my friends and juniors. And after that, I went to University of Colorado, Boulder, where I joined with Professor J.T. Hines, another giant. And almost I was the last postdoc of him. He was almost retiring, and he took me a field which was completely different from what I have done in PhD. That was ab initio calculations, ab initio molecular dynamics simulations on proton transfer reactions. So he asked me while I applied to him for postdoc, he asked me, do you have any experience for these kind of things? I said, no, I do not have any experience, but I have done analytical theory and I have written my own computer simulation program. So I have some knowledge about these things, classical definitely, not quantum mechanical or ab initio calculations. But anyway, he considered my candidature and he took me, and I joined with him in 2013, although defense was not done, so I came back again for defense. After I joined him, I asked him why you took me, because I did not have any experience about these things, particularly these ab initio calculations. He said, I have read a couple of papers where you have done theory, analytical theory, which actually impressed me. That's why I took it. So although these things, this analysis, these calculations were not so fancy in the current terms, but real people, genuine people will understand about your research. So I worked with him on this proton transfer reactions. I tried to understand how carbonic acid can actually protonate biological base. It was a nice proposal which actually aimed to understand whether carbonic acid, which was not considered to be a biological acid, can also protonate different biological bases. And we tried to solve the problem theoretically. There was also an experimental group. We closely collaborated with them in Israel. And in 2016 December, when I completed my postdoc, I joined at the Department of Chemistry at Patna. And I started working on actually one problem which involves the understanding of the breakdown of Stokes-Einstein relation in supercooled water, because although I did not directly work on this area in my PhD, but I had some fascination about these things for a long time, because similar things were being done in our PhD group by Professor Bissas. So I started working on them. Then we have also once new student Sakira joined in my group, who was a little bit interested on this biological system. We started working on this model cell membrane adaptations, hydrophilic adaptations, how extreme extrophilic organisms survive at very harsh conditions, where high temperature or low temperatures is there, which is not very hospitable for life. We are also working on these nanoparticle cell membrane interactions. I will show you few things about that, and also with experimental groups like physics group, the physics department, or mechanical engineering department also, which is giving me a real boost, because mechanical engineering and all these engineering department do research in a different way, different perspective, very macromolecular, very macro scale, and we are giving them some microscopic insights for their projects. So I will just briefly go overview, because there is a golden opportunity for me to show my works also, what I am trying to do in here. So as I said, this breakdown of Stokes-Einstein relation of supercooled water, we have devised a new approach. We have named it, the name is transitional jump diffusion approach, which actually explained a long controversy about the Stokes-Einstein breakdown in supercooled water. So there were several theories which tried to explain it, but none of the theory was quantitatively explaining this phenomena, breakdown of Stokes-Einstein. That is basically the decoupling between diffusion and viscosity at low temperature. Only at the very recently, because this work actually started by looking at this experiment in 2015. This paper published in PNAS, which showed for the first time direct breakdown of Stokes-Einstein. Previously, it was observed by indirectly using the structure reduction time, but in 2015, as they published it, we actually, and the most interesting result was that water does not break, the Stokes-Einstein relation does not break down only at supercooled condition, even at room temperature. You can see here. So that actually fascinated us, and we started working on this, and we proposed this approach, transitional jump diffusion model, which actually takes the transitional jump into account and calculate the jump diffusion coefficient, one part of the overall diffusion. And if you subtract this jump diffusion coefficient, that is the rogue element, you can get the residual diffusion. And if you check with residual diffusion, Stokes-Einstein relation is perfectly valid. So that actually essentially indicates that quantitatively that this jump diffusion is the reason for this breakdown. And we have published a few papers on this, and also recent articles we have published, which actually has been which is in perspective, PhD perspective, where we have discussed the whole thing in perspective. So another work we are also doing, that is the adaptation of cell membrane in extremophiles, because as I said, extremophilic organisms are interesting to study, because they are they have certain adaptation strategy to survive, because otherwise the cell membrane that is made of lipid membrane, that will undergo phase transition. Okay, so to stop the phase transition, there is a strategy that this the saturated lipids undergoes saturated lipids transformed into unsaturated lipids, and thereby stabilize the fluid phase. We have published one paper, and then recently another paper which actually deals with the soil bacterium, the homeostatic adaptation of lipid membrane of a soil bacterium, and that is under revision. Hopefully, it will be published soon. Another strategy that is using the different cryoproductants, or you can say osmolytes like trehalose, like DMSO, glycerol, all these different small organic molecules, how they protect the cell membrane against these harsh conditions. That also we have seen. A recent interesting and a very ambitious project we are trying to do is that during this freeze drying process, it is seen that E. coli and all these different probiotic dies, So to make them survive in these harsh conditions during freeze drying, different lyoprotectants. They are called lyoprotectants because lyoprotectants are basically protect the membrane against lyophilization. Lyophilization is freeze drying. So the mechanism is still completely unknown. How these different molecules, trihalose and sucrose, particularly these disaccharides, okay, where two monosaccharides actually are attached by a chemical bond, how they actually protect or prevent the phase transitions of the cell membrane of different probiotic. The first time we are doing E. coli. Our plan is to go to yeast cells, etc. Okay. And finally, this works also we are doing, which actually involves the interactions of nanoparticles and cell membrane. I will not go into the details. And finally, I acknowledge heartily my supervisor, Professor Ranjit Vishwas, from whom I have learned a lot. It's not an exaggeration to say that whatever I have become, I give a majority of the contributions to him. Also, Professor Jetty Hines, because I have learned a lot of the things I'm doing now in 3 years, a lot of learnings, and my department of chemistry for doing all the research and different funding agency time to time. And this is a photograph when I visited SNBNCBS in 2017, I guess. And this is the photo with my postdoc advisor, and this is the current group at our department. And thank you all for your kind attention.
I'm just wondering if you have your query questions from offline people. No? Any online person have any questions, comments?
Thank you, sir. Thank you.
Then let's move to the next talk by Dr. Kaustika Chatterjee. Please.
So thank you so much. So it's a wonderful feeling being here. And let me tell you, Commissioner, this is not 6 years old. This is at least 11 years old because this is the stage on which I gave my last Bose Fest talk. That was 2011. And when I stand here once again, I feel equally nervous. So it's the ambience. I see ma'am sitting, Ranjit sir. So to start off, I came here in 2007 for my interview. The first interview panel that I faced was by this TBMS panel. So there were lots of people, Ranjit sir, Surajit sir, and so he's in ISR right now. Yes, Subhashik sir, yeah. So there was lots and lots of people. So the first interview was horrible. So I was, from then onwards, I was very scared of Ranjit sir. He asked me some extremely tough questions, and for me, like, unfortunately, it was like if I can't answer the first question, my mind is switched off, and the whole interview, and he tried a lot hard, like to get something out of me. And it was like around 45 minutes of an interview, and I barely could answer anything. So when I came out, my father was sitting, so he knew that if he's not there, I might run away. He was sitting, so how was the interview? I said it was bad. So his argument was, if an interview goes on for 45 minutes, it has to be, you must have said something there, otherwise it couldn't have continued for 45 minutes. But it was terribly bad. All right, so the next interview board was by the condensed matter group. Ma'am wasn't there, but all the stalwarts of that time were there, the condensed matter. And fortunately, it went good. I wasn't a very good student, but it went good, and I was selected. and hence I'm very happy to be here. So when I was asked for a title and an abstract, I was like, I didn't know what to say. And a single title that could sum up everything. So for me, SN Bose is more of a sentiment, right? More than academics, it's my family, a family that I joined in 2007 and I never left. So it's a part of me. So I could not figure out one single title. I begged Raka, so give me one title. So she did not help me. I messaged her twice. Then Indraki came up with one title, say, right from being Tanushree ma'am's student to being a supervisor. And then Raka added, colon, add a path integral approach. So that somehow happened to be like, I thought equating myself with ma'am, like giving such a title would be like equating myself with ma'am. So that didn't work. So here I am with no title, no abstract. And this is where I started from in 2007. This is where I am. Okay, so this is a bad picture, but the discredit doesn't go to me. I've pulled it out from the internet. So these are my mentors, my most revered guides, Tanushree ma'am and Shurajit sir. So Shurajit sir lives with us. He lives within us. He lives with us, right? Because this is the beauty of academia. So you do not die. You live on through your students. You live on through the ideas, through the principles that he has imparted on to us. So he's there with us, and here is our backbone. So I would not say many more words about her because whatever I tell would be less. And I'm undermining what she means to all of us. Although there was a time when we really wanted to get away because of the huge amount of scoldings we used to get. But now that when I am in her place, I know what she has done for us and the amount of labor she has put to us, right? So it's a very difficult job to be a supervisor. Okay, so when I came in 2007, so 5 of us finally joined, four boys and 1 girl, that was me. And that time we had this, our year had this thing that all the people, all the supervisors, they came in, they gave a presentation of the kind of projects they are offering to us. And out of that, one of the projects was what Tanushree ma'am and Shurajit sir jointly proposed, was to study the Earth's interior. So for me, as a young student, it was very interesting and it was very fascinating. But when I look back, I think that was an extremely bold step by the duo where they thought about going into and talking about the Earth's interior. So let me tell you, this is the kind of topic that they were approaching for the first time in the country. And at that time, around the world, there were just 2 other groups in US and 1 in UK that were trying to use the principles of physics to understand the Earth's interior. But their approach was definitely different, and that is something I'll come at the end, right? So once I joined, ours was a pre-smartphone era, but I have tried to collect as many pictures as possible from my friends, from all your Facebooks, from the internet, and put it here. So this is the kind of we used to use. Okay, so this is the TSB group, and this picture is taken sometimes at around 2009. By that time, Bodhiyuddha had graduated. Shomenguda had also left for his postdoc. We hadn't seen Durga for Dion, so he's a person we only heard about at that time. And this is a person who was never officially a part of a group, Mukulda, but he was always an integral part of us. For example, when I had joined, I had never seen Mukulda. I didn't know how he looked like. But my first person to go for was Shomenguda. If Shomenguda is not available, it is Mukulda. So he used to set up a Skype call. But the problem is, if you're calling Mukulda, then you have to first hear about what he is eating that night. So he would tell that the kind of hilsa I eat here, you never get it. All the good hilsas come here. See, this is what I'm eating. So then he used to start explaining, helping us out. So very often when we are doing computations, convergence is an issue. So we didn't know at that time how to work with it. But Mukulda has been selflessly helping us out. So very often it has happened that ma'am, you even didn't know that I didn't do it. Mukul did it. But this is the kind of environment, the ambience, the family that we had got here. Okay. So this was our ghetto, the computer center, CC, right? And this is the different people. This is Shonmoti things, my batchmate, a very good friend, Rajiv Chauhan, Shudipta Kanungo will come next, Kapil Bhai, Srimoi maybe got a packet of chips from somewhere and she was here talking to me. And this is something late at night, maybe 12 o'clock or 1 a.m. at night. Saurabh, you were not there at that night. So these pictures were taken by Shishendu, and those who were there are here. Okay, and this is our CC from different angles. So the best picture, this is the Hall of Fame, I would say, because all our stalwarts, the student stalwarts used to sit there. So you would have Moshiorda on this chair, you would have Robida in this chair, Srimoi, Hena got a seat here, and then Srimoi also had a seat here. But we were not fortunate enough, we were in the other wing. Right? So this is the other wing. This is an L shape, and this was the entrance. I don't know whether the CC looks like this or not, but this was our home. This is where we spent maybe 18 hours of the day. Okay, but I was not that unfortunate. So this is a computer that came from ma'am's project, maybe some CMP or CPM, some project, and this was the first LED screen that the computer center had. So whoever was the senior most student in the TSD group got a chance to sit here. Okay, so by that turn, when Somendra went and Hena got a chance in that Hall of Fame, I was the next in line. So I got this computer, but by that time, every other student or rather every other PC had this kind of an LED screen, and maybe even better. But this was much revered and honored. So I would sit here and work. By that time, this was maybe by my third or fourth year of the PhD when I had my own laptop, but never did leave the seat because this was like a prize seat for all of us. Okay, so when I joined SNBNCBS Center, I was the only girl in my batch, and these were the other girl PhD students. So we had Hena, Sudesh Nadi, Raka, Rupati, and Kapodidi. So 6 of us, and since the number of students, girl students were so less, we didn't have a girls' hostel. We were all privileged to stay in the guest house with a personal bathroom of our own. Okay, and this is our guest house corridors back there, and this is our Boast Fest. So right now you must be having much grander Boast Fest in terms of the grandeur, but ours were nonetheless like less grand. Okay, so this is, you can see many familiar faces, Rudroni, Indrakti, Raka, we have Shudipta Kanungo there, so Shuja Modo, Omorto, Vipulda, right? This is one poster presentation that I was making. This is quite early during my PhD tenure. So ma'am had asked me to work on a mineral named as olivine, which is the most dominant phase in the Earth's upper mantle, and her idea, it was a genius idea that came out later on, was to see the effect of iron. So iron, most of the iron in the Earth's mantle has gone into the core, right? During the accretion of the Earth, the majority of the iron and nickel has gone into the core, and that is what has built the core. But some amount of iron still stayed back in the mantle, right? And when people did experiments, so high pressure experiments are used generally synthetic samples, because you cannot always extract samples from inside the Earth. You cannot dig so deep inside the Earth. So they basically used to prepare samples without iron, considering iron is very less. Okay? So the idea was to see the effect of iron, and iron was found to have profound effects. So henceforth, after I would say her publication with iron in olivine, there were several other papers who started looking into what is the effect of iron in the mantle. Okay, so this is where we have Sandeep Chakraborty sir coming and asking me, so this is the phase which is first formed after the Big Bang, olivine. So can you tell me why? I still don't have the answer, but it's a very interesting question. This is the main phase in the Earth's upper mantle. It's also the first phase formed after the Big Bang. And this is our Bose Fest queen. So if she stands for a presentation, nobody else gets to get the first prize. Okay, so Raka got the first prize 3 times in a row. Not to forget, Shorodai is getting angry. Shorodai also used to get the best speaker award. And then he had a secret which he shared with Raka, and henceforth Raka started getting that Bose Fest prize. Is to whenever you're giving a talk, if you're not sure about a certain concept, then speak it with so much confidence that the audience doesn't even think that this might be incorrect. So Raka learned it from Shoravda. Shoravda used to get the best speaker award initially, and Raka started getting, and Raka got it 3 times in a row. We used to call her the Bose Fest queen.
These are recorded.
This is not to be followed. This was Shoravda.
That's okay. Other student will also know this.
Okay, so these are also some random pictures from our SN Bose days. This is a conference that was organized on a ship, floating ship. I know. What is the name? Floatel. Yeah. So we were very happy seeing it for the first time. So that is probably back then in 2008 or something. All of the meeting these 2 guys. Okay, this is the happy birthday celebration of Rajiv Chauhan, Raka and myself sitting and chatting, and this is Abhinav Kumar dancing. All right, and these were our small parties that we used to have in Pizza Hut in city center. So it's like maybe somebody has given a SRF talk and it went well. We also went for these kinds of treats if somebody's SRF talk did not go well. So in fact, Raka and myself took somebody, you remember Raka? So the SRF talk did not go well. So we took her for a treat to Pizza Hut. And this is from the mess. So ours was a batch to start the SN Bose mess. So we have the first general secretary of the mess, now Professor Shorav Bhattacharya with us, the treasurer of the mess, the first treasurer of the mess, Vishwajit Das, and Raka, myself, Shirshendu and Kamal Bashak, we were the first managers of the mess. So we invested 1 full month. You remember Raka? So we had some cooks. There was just 1 cook, and the rest were helpers. They could be helper in anything. They could be a helper in building a building, or they could be a helper in here. So that day, there were lots of students. They couldn't make these puris fast. Either was I good at it, but since there was an extra rolling pin, I started sitting. So Srishan had taken this picture. I thought of putting it here. Okay. So finally, I made some wonderful friends during my tenure of SN Bose. I could say my very best friend, a confidante, a support in the most difficult times of my life. So I talk to her when I'm in trouble. I don't talk to her in happy days. Indrakshi, Tishendu. Tishendu person was there in our group for 2 years, but he was such a wonderful guy that he made a very good impression on all our hearts. Okay, so finally, picture credits. Tishendu was the only person who was to take pictures, so we have only pictures in 2009. I don't have pictures beyond that. Facebook, so I've stolen it from all your accounts. Okay, and finally, this is where I am. I serve Kolkata in the Department of Earth Sciences. So I'm still a student. Since I come from a physics background, I'm in an earth science department. I still go and sit in sedimentology courses. I attend fieldworks with students. I'm still a learner. And before I end, I would like to emphasize on the importance of physics in geology. Okay, so you know whatever is happening on the surface of the earth, everything can be deciphered quite easily. What about what is going inside the earth, right? You can dig only up to say around 12 kilometers inside the earth. And whatever else you know about the earth comes from seismic wave velocity. What does seismology tell us? It just tells us about the elastic properties of the medium. That's it. We don't get anything else from that information. But what helps us understand what seismic information we are getting? So it is mineral physics that tells us, right? So mineral physics data previously So mineral physics data previously always flowed from experiments, okay? And performing high pressure, high temperature experiments is an extremely challenging task. So what people generally do is they do experiment up to a certain pressure, extrapolate. Or maybe they can just tune the pressure, they can't tune the temperature. So the results are not always accurate. So here, physics and even quantum chemistry tools, they have a big role to play. So you can actually calculate it's there inside here, the properties of the materials. So it basically has a huge application which can still be explored, right? So thank you so much. And this is the summer of 69. And if I had the choice, yeah, I would always want to be there. Those were the best days of my life. Thank you so much.
I request for question, comments. No, it was such a wonderful memory.
Very different kinds of talk.
Yeah.
Where you have lots of sentiments.
Yeah, that's true.
Ashishna was doing it.
Okay, so thank you very much. Let's move on to the.
I look for faces. Confirm that what you're saying is fine. The faces might.
Thank you, Swastika. And let's now move on to the next speaker, to Dr. Visajit, Assistant Professor at Srinagar University. Dr. Visajit. Dr. Visajit.
Hello, sir. Hello, everyone. Just so can you see my screen?
Not yet. Not yet. Yeah, sometimes, yeah. Are you trying to share with Google, like Mac?
Yes. So
Maybe we can email, we can go to the next speaker and we can email.
can you see now?
It's coming. It's coming. You can see it. Please make it full screen mode.
All right. Okay. Yeah. Thank you.
Yeah.
So.
Please go ahead.
Hello, everyone. So I am Viswajit Guchait, and I am presently at Srinagar University.
Can you please make it full screen?
I made it actually probably.
At least I cannot see. I don't know if it is visible over there.
It's not.
You need to select the entire screen option. While sharing, you just stop sharing and share again, and this time select entire screen while sharing. Instead of a window, select entire screen.
Can you see now?
Yeah.
It's okay.
Yeah.
Now it's full screen.
Okay. Okay. Thank you. Yeah. Thank you. So I completed PhD from SN Bose National Center with my advisor, Professor Ranjit Biswas. And then in my PhD, I worked on actually the solvation dynamics in debutytic solvent. So I can actually share one thing. Actually, that time my professor yeah, he was interested to study the theory of solvation in ionic liquid, and that's what Dr. Snehashi Das Chakraborty also explained. So actually, that time I was talking with my supervisor to find a good problem for my PhD. So I was telling my advisor that I want to do the solvation dynamics experiment using our available resources at the Helmholtz Center in ionic liquid. And my supervisor said, no, you cannot do that because many other people are doing in India. So then we decided to do something. Let's do solvation dynamics in some different media. So that's why we decided to do, let's mix two solid compound and the resulting liquid, what happened to the solvation phenomena in the resulting liquid. So we got some literature and people have tried mixing two solid and they actually become liquid at room temperature. So that time actually that field was not that much interested, and nowadays it is very much interested, actually known as the debutytic solvent. So to the best of our knowledge, I think we are very few persons who have initiated to find out the dynamics, the natural dynamics of the debutytic system. So yeah, so that's how it was very interesting for in my PhD, and Professor Ranjit Biswas, my advisor, helps a lot, and including my senior lab members, Dr. Hemant Kashyap and Dr. Tuin Pradhan, also the Snehashi Das Chakraborty and Mr. Pal, they are my lab mates. And yeah, so then I moved to Max Born Institute for Nonlinear Optics and Short Pulse Spectroscopy to do my postdoctoral study. And there I have carried out postdoctoral study in a completely different field. So that was the 2D IR spectroscopic study of biomolecule. So, and in my PhD, actually, I handled only the picosecond laser diode. So I did not have that much experience to handle the femtosecond laser. So even though we had a femtosecond TISAB oscillator that time, but we had a rare opportunity to handle it. And so I actually learned a lot of things at Max Born Institute, handling the femtosecond laser and how to produce, how to frequency convert the femtosecond pulse from the near IR to the mid IR. Then we use that to do the 2D IR spectroscopy of biomolecule. And there I used the 2D IR spectroscopy to determine the structural dynamics of DNA backbone. So we studied the structure fluctuation of the DNA backbone using the DNA backbone vibration. And then I moved to Colorado State University, Fort Collins, and I worked with Professor Ambar Kumar there. And that was a project of developing 2D IR microscopy. So yeah, maybe it will be a bit helpful if I go in this slide. So in Max Born Institute, I used the 2D IR spectroscopy in this configuration. If you see that this is something known as the boxcar configuration. And for 2D IR spectroscopy, you generally need the 3 femtosecond pulses. And this first pulse create the coherence, second pulse stop the coherence and generate the population, and the third pulse creates again the coherence and emits the signal field. So in Max Born Institute, I actually used these techniques. And when I moved to the Colorado State University, there I had asked to develop the 2D IR microscope. And so then actually we convert this geometry to a collinear geometry. So here you can see in the right side, this is a palm probe geometry. And so that was a difficult task for us to how to convert this geometry to a collinear geometry. And then actually we choose, we take the polarization of the optical pulse and we used the pump parallel and probe perpendicular configuration and use a achromatic lens to focus the mid-IR beam in a 50 less than 50 micron resolution. So, and that was to study the micron length scale heterogeneity of the materials. So then I go to the for my next postdoc. Then again in Germany, in Ruhr University Bochum, with Professor Martina Haven, and there I developed. Actually, I built one setup, terahertz time domain spectrometer, and that was used for study of the water dynamics. And actually, so I developed the setup, but I did not have the opportunity to study the dynamics. And then I actually take a position at Shivnagar University in August 2019, and from there I am working there. Okay, so actually, sorry if these slides maybe not relevant to this kind of interaction. So maybe I will discuss a little bit about what I did in my postdoctoral study and what I am doing now. So at present, actually at Shivnagar University, I am teaching a lot, and in addition to that, I am trying to develop laboratory here. So I got a picosecond process setup. So of course, I don't have the opportunity to do the 2DIR at Shivnagar University because it is a huge course, more than 5 hours. So here I am doing the photochemical reaction using the picosecond laser diode. So so just to tell what we have done in brief. So for example, here we have studied the structure fluctuation in the ionic liquid. So the ionic liquids are very important. So, but there are some limitation of ionic liquid because of its huge viscosity. And in recent time, people have incorporated many anions to reduce the viscosity. For instance, this tricyanomethanite anion or that tetracyanoborate anion. So, but what was the reason that they are giving the low viscosity? To understand that, actually, we studied the structure fluctuation time of this ionic liquid. So, and we found that this 2DIR spectra, this is if you see, this is known as the spectral diffusion. This capital T, when we reduce it, the slope of the nodal line, if you see, it is actually starting from almost 45 and it is completing at 0. So this is giving actually the structure fluctuation time scale. And when we see that for multiple cyanofunctionalized anion, this time scale is very fast, almost an order of magnitude smaller than its common ionic liquid. For example, the tetrafluoroborate ionic liquid. And we propose that this structure fluctuation time scale is very fast because the ion cage lifetime in this type of ionic liquid are very small. And that is actually responsible for the low viscosity of these types of ionic liquid. So this is just a portion. And yeah, so just to give you a brief idea about what we are doing. So presently, as I told you, that we are doing the photochemical reaction. For example, the photoreaction of a photoacid, that is the excited state proton transfer or excited state electron transfer. So we are actually studying the rate of those chemical reaction in dibutectic solvents. As you know, that these dibutectic solvents are very important nowadays. And also we are confining, we are studying these dibutectics in various confined media. So I'm not going to explain the photochemical study. Rather, we have started actually new things so that I do not have expertise, but here I have started doing this because I had the exposure in 2D IR spectroscopy. I utilized that, and I am now doing the pulse field gradient stimulated spin echo study, which is pretty analogous to the 2D IR actually, I would say. So, and here you use two gradient actually, the two magnetic field gradient, bipolar gradient. Using that, actually, if you increase the gradient, then the FID of the proton NMR signal reduces, and this signal reduction you can fit with this kind of standard expression, and utilizing that, we are measuring the diffusion coefficient in various D-eutectics solvent. Okay, so for example, we are studying many D-eutectic solvents. So this is a system that I have started doing PhD actually. That time I have done the solvation dynamics in this D-eutectic. So here actually we are doing measuring the diffusion coefficient. So so here I am showing just a result in brief. So this is the diffusion coefficient in the right bottom, as you can see here. The diffusion coefficient we have measured for this type of D-eutectics, and this is RNS type of plot. And from that plot, we calculated the diffusion activation energy here. So this diffusion activation energy actually decreases if we increase the ion, if we change the ion concentration. If you carefully look at these things, we are actually replacing the sodium by the potassium if we increase the F. So nothing we are doing. And by doing that, what we are seeing, this activation energy is getting reduced. So that means when the sodium ion is more in this particular type of mixtures, the rate of change of diffusion, the rate of change of diffusion on temperature is very large. So, and we have also done the molecular dynamics, and from the mean square displacement, we have also calculated the diffusion energy, which is in good agreement, as you can see. So that basically telling that when the sodium ion present in the mixture at a large exchange, the rate of diffusion, the dependence of rate of diffusion on temperature is much larger, which is basically telling that the structure is more rigid. Which has very large temperature effect. And that is also confirmed by this radial distribution function, as you can see. When we do the radial distribution function for this acetamide, as we have present acetamide in this mixture, acetamide with sodium, we are getting the height of about 15. When we do the same for acetamide oxygen with the potassium, we are getting this about 9. So, and that is basically telling, finding the molecular mechanism of diffusion in this type of things. So, and then I would like to acknowledge my professor, Professor Ranjit Biswas, from whom I have learned a lot. I also, as Dr. Snesi Daksok mentioned, so I am from Medipur. Actually, I did not have that research exposure at my MSc time, and Professor Biswas actually taught everything in the laboratory, as well as his group is doing the theory and simulation. I had plenty of opportunity to learn the basics of theory and simulation also. And then I acknowledge my advisor, Professor Ambar Kumel. And these are my PhD students here, Mr. Arnab Sil, Ms. Songita Jangra, and Mr. Vikas Singh. And I acknowledge Vice Chancellor, Professor Mukherjee, the Dean, Professor Galande, and our HOD. And finally, I acknowledge Shivnadar University and ACRB New Delhi for funding. And thank you very much. Thank you.
Thank you very much. Any comments? Any comments from online participants? Offline participants? No? Let's move on to the next speaker. Dr. Sudipto Kanapro. He is assistant professor at IIT Goa. Sir, please.
Am I audible?
Yes, yes.
Okay.
Please share your slide.
Yes.
Yes, but the actual data is there. But when experiment they do, one things are already included there. In experiment they don't care whether you theoretically sometimes take position, sometimes they don't. But in experiment everything is there. Whatever happens, everything is there. You think it is a person effective. You can do it. Means that reality calculation, you have to do reality calculation.
Is this screen visible?
Yes, it is.
Okay. Yeah. So first, let me thanks to this nice concept that we all came back. Some are physically, some are virtually, to the same place where we start our journey. So, and in the entire day, we listen a lot of old memories, kind of recapitulation of whole things where we are right now from our formal starting of our professional careers. So today, what I'm going to share is a completely non-technical kind of sharing the memories. Some of the content picture you maybe is repeated. Some of the picture is also from Shostika is already shown just before. Anyway, so basically it started the kind of from 2008, and I intentionally gave this picture. It is taken in 2009. There is a special incident on that day because of some substation failure or something. The entire power was gone in the SN Bose, and that time and that moment we are very happy that okay, the power is cut. So okay, we can do apart from what we are supposed to do that time. So let's go somewhere and do something else. That day, Kapil Bhaiya bought a new camera. DSLR that time is very expensive, but he managed to bought a new DSLR camera. And I am just walking down their main street entrance of the SN Bose, the main entrance. Then Kapil Bhaiya clicked this photo and as a evidence to show my supervisor that see the students are going outside without doing utilizing this kind of opportunity. So this is that picture. It's the afternoon. So kind of I can start from here. So basically this okay, yeah, no. Yeah, so this is the brief academic kind of journey. I joined 2008 SN Bose as a PhD student under the supervision of Professor Tanushree Shah Gupta. Then from 2013 to 16, I was as a postdoctoral fellow in the Max Planck Chemical Physics of Solid. Then for a couple of months, I joined as a postdoctoral fellow in the Hurricane. Then for 1.5 years, I was as a inspired faculty in the IIST Shibpur. And then 2018 onwards, I am in IIT Goa currently as an assistant professor. So in most of the today, I'm what I'm going to show is surrounded with the SN Bose and some of the few things what we are recently we are in recently as a new place in IIT Goa. So the story begins with this. This is a offer letter back in 2008 signed by JKB, that time the Dean Academic Program is a, my screen is visible to you, right?
Yes, yes.
Yes. So that, yeah. So that time is a post MSc PhD program in 2008. So although in the offer letter my spelling of my name was wrong, but anyway, they allowed me to join there. It's fine. But the actual story starts before the 2008. My first interview, formal interview, during the BSc time, after the BSc third year, there was an integrated MSc program, and during that time, even from the JAM exam, that is entrance exam for to doing the IIT, MSc in IIT, SNBNCBS used to take the integrated MSc student. So that is my first interview I gave in 2005 in SNBNCBS. An interview was held in the guest house, first floor of any room of the first floor in the guest house that time. I don't remember who was there. Only I remember Professor JKB was there. He asked a complicated question on the rotating top, and I could not answer this thing. So at the end result, I didn't get the chance in the integrated MSc PhD program in SNBNCBS in 2005. So then again, after that, after the MSc, I joined 2008 as a post MSc PhD student. Then 2009, I joined the TS Professor Tanushree Hadasgupta group. Phostikari already showed the same picture because we have only limited number of picture during that time. We don't have that smartphone or even the camera in the phone. Most of it, and most of us, we have a normal Nokia 1110 phone kind of. Only calling, message is done. Okay, so yeah, same old picture. Phostikari is here. So Shishendu, Henadi, ma'am, Shomojita, myself, and Progga. This is already old computer center or CC pictures. Here some of the old culprits are there. Hirogda, Ovinavda is sitting here, and this is Prashant Bhaiya. This is the what Shostikari showed is the elite group bunch is a elite group bay is a different part, and the bottom part is the where we all are newcomer are allowed to sit. So this is a kind of picture where we are used to sit in the computer center. That time we don't have a specific computers. There is all are connected with the NFS. Whatever the seat is available, you have to sit, and we are fine with that. And that time, still that time, okay, we are doing the coursework, is a completely new place. We don't know. Just after finishing MSc, we joined here. But the most surprise are still there. So first, we realized after joining the PhD from the MSc is a completely different kind of situation. And first, what I understood or I realized about myself that I don't know anything. Although when I joined there after doing the MSc, joining the condensed matter group, and then okay, I thought that okay, I know few things, but after joining here, I realized that I don't know anything. And also I realized that MSc to PhD, that transition is a completely non-trivial phase transition, and it is a very different thing. And we are now in a completely different domain, different place, and I don't know how to survive here. That time, these two persons, Shomojita and Shostikari, came and came as a rescuer. Any problem, anything that we don't know what to do, this is our kind of destination. We used to discuss, and we used to kind of consult, or not consult, it's a kind of simple helping that I don't know what to do, and what should we do for this current situation or this that. So, and also Swastikadi mentioned, the Mukulda is a kind of when everything is kind of closed, then final suggestion or final recommendation, if you want, contact Mukulda. Mukulda that time was in US. So sometimes Mukulda used to call the ISD phone call to solve our query. Most of the time, these queries are not the scientific or the academic things. Most of the time, this is a personal thing or how to handle this, that. And we also learned, at least I learned one thing, that sometimes coming in the doing the PhD from the MS after the MSc, the notion is very different. And I found, at least myself, that probably I am more, whether this is scientific discussion, scientific work, these two are very different things. And the scientific work, if you want to survive, they have to be very professional. And that kind of training we don't have had during our MSc time. And also we learned that one thing, that during the PhD is basically is beyond something, the publishing, result, showing, this, that. It's a completely different thing. It's a journey is basically matters than the where we start and where we reach. So then we trained ourselves that, okay, since we have to deal with that, let's make something which is very common to our daily life, like how to deal with the frustration. And I think Swastikadi is there, Rakadi is also there, so they can relate what I'm trying to say. How to deal with the frustration, how to handle the criticism, how to handle the failure, and in spite of all these things, you have to survive and the show must go on. This training is basically the main thing what I learned from the SN Bose. So that is one very big surprise after joining the PhD program. But then also there are some lighter side of the life. So because in the presence of the this is a picture taken in 2009 when Professor Kitterle visited visited SN Bose, and in the early morning, I guess it is a January or it is a January. So we are basically cast him and okay, let's have a photo. And this is the one photo with Professor Kitterle and Progress there. This is in front of the SN Bose statue in the main entrance. There are many memories is like that, apart from all the hardship we gone through during our PhD tenure. But these are basically the asset for the whole life, that we can go back, look at that, kind of relive that episode, that time, and we can understand, okay, that time probably we are taking the situation is very differently, but the actual thing is completely different. So these are the few fun moments, and I would say this is out of the box. This is a group picnic photograph. We went for the Turkey for the Professor Mukherjee's group, and our group is there. So this is a Prashant Bhaiya, Ombika, Jena, Rajiv, myself, Shishendu. We all are basically, these are the kind of recreation. Aftabda also there in that picnic. This is the one of the group lunch. I think Mukulda is there. Yeah, Mukulda is here. Shomenduda, and if I remember correctly, this is probably the 1st of January of some year. We went for the Chinatown for having a lunch, and all these kind of occasions we are waiting for that. Okay, let's go do something else. This is the old memory in the canteen. All the old culprits are here. This is Yomajidda, Kopil Bhaiya. This is Shoikot Devnath, Obhijit, Swastikadi, Rakadi, Prashant Bhaiya, myself. This is the main culprit. Obhijit, Abhinav Bhaiya is there. This is in the institute canteen. It is during the breakfast time. I don't know who clicked this photo, but I think this photo is with many of us. This is the famous Bose Fest 2010. I am not going to the technical, what we did technically, Bose Fest, these, that. Everybody already aware of that. This is 2010 Bose Fest. In every Bose Fest, in the last day, there is a cultural event. And that year, Bhumi, this Bengali band, came to perform. And that is the night we are completely, these are the self-explanatory pictures. No need to explain what is going on there. So these are the memories we have in the SN Bose beyond all the academics, what we learn, what we are doing for our everyday. These are the assets what we created and we live forever. Also, we experienced the centenary Indian Science Congress that year 2013. Kolkata was the host, and some of the event was in SN Bose campus itself, and we are there to former Indian President Dr. APJ Abdul Kalam was there, and there is a special interaction event was organized with the students. And these are also, this is our lawn, some of the camps or some of the tent is made because of this some presentation, all this thing. And this is in 2013. So one new thing is the experience that is called conference. Before that, there is most of us don't know what is called conference. And there is a kind of parallel version of the conference was there apart from the academics, and we met many people across on the same batch. They are working in a different institute in India. This is a kind of platform to interact, and if I look back now, this same group is basically now placed in a different institutes across the globe. So this is a kind of long chain started back in that time and continue till now. So this is the right hand side. This is a special day. We are that time in HRI. There is a workshop and conference. This is the 2nd April 2011. Is a night that India won the World Cup, and in the auditorium after the talk, we basically stream the final match, and we are basically enjoy here in the HRI auditorium. We are watching the final India versus Sri Lanka match. So this is 2011. This is my first time when I am out of the country. First time I went in Uppsala University for 2 months. This is the before the going to the institute. I went there into the Friday or Saturday. This was some Sunday after the Durga Puja. This is Biplab Das residence. We used to celebrate the small Durga Puja there in Uppsala, and Professor Peter Openier is a group where I there for the few months and this is Kartik Da. Then is the first APS meeting. First time is the first realization or first experience what is called this kind of Mela conference. I just completely clueless. This is in Boston in February. Is a -4 or 5 degrees Celsius that time. This is the first experience what is called the APS March meeting or something like that, big conference meeting different people. And there is an interesting story of that conference. I had a kind of presentation in that conference, but since this is the first time I'm going outside and giving a talk in front of the international audience, so talk should be very good and be up to mark. So during that, I guess 1 month back or something, Mukulda was visiting SN Bose. Then we gave a presentation in front of Mukulda to standardize our talk. that okay, to standardize my talk, that it should be presentable in front of the audience. And after a kind of 10 minutes talk is going, 10 minutes talk, the mock is going for another around 2 hours. Lot of kind of correction. After that, the completely talk, the whole slide has changed. So all this kind of learning process we gone through during this 5-year tenure is actually is a kind of asset, or we basically what I said beginning, there's a journey. So let's do some kind of academic talk. Back in 2000 when we joined, there is a, Swastika is also already mentioned that there is a kind of I joined in the condensed matter department. So all the faculty members used to give a presentation about their research, what they are doing, this thing. And from the academic office, they used to give us a form, and we are supposed to discuss, supposed to meet in each and every faculty personally, discuss and get them signed. Unless we fill that form, the 6-month coursework will not going to finish. This is the official formalities that time. So during that presentation, ma'am gave a presentation on the low dimensional quantum spin system. So I thought, okay, is very interesting thing. And then when I went to her to discuss this thing, she gave me a thesis, Bodhiuddha's thesis, and asked me to read. From that time, basically the low dimensional spin system, or formally the quantum magnetism is started in my work. So after the 5 years, did many things. Is not a unidirectional. Some are the spin system, some are the perovskite, some are the organometallic, and at the end I am totally confused at what would be the thesis title. Then she told, okay, let's make a completely kind of overlapping everything. Let's say first principle study of novel materials, and using that we can include everything. Then okay, it's fine. And suddenly one day, when we are basically in the for 5th year, we are basically trying to get the post interview for the postdoc, this, that, and suddenly one of the postdoc interviewers accepted, and they are asked me to when I can join. But that time is a completely I'm not ready to even submit this thesis or writing, not even the writing stage. Then I went to ma'am, then asked that they are asking when I can join, what should I reply? Then he said, okay, this is this is March, so you have 15 days time to finish all your pending work. 1st of April you start writing thesis, end of April you have to finish, May mid you have to submit, and May end you should go there. Timeline was framed. Then I thought, okay, 15 days, how I can finish all the pending work? Anyway, we have to finish, and somehow I managed to finish this thing, and within 1 month somehow I managed to write the thesis. And most importantly, ma'am able to check this thesis, because when I submitted the first draft, he asked me, your English is too bad that I cannot check your English. It's not possible to check each grammatical mistake, everything. Then she suggested that, okay, go and check and ask someone to check your English thing. Then I went to one of my junior, Rishit. That Rishit gave a tremendous, this Rishit that time the first year just joined. He used to be a kind of very good in English. So I gave all this thing, and his task, apart from the coursework, was to correct the English of my thesis, this thing. So in that way, I completed the PhD tenure, and I joined 2013, my first postdoc in the Max Planck Institute for Chemical Physics of Solid, with Professor Claudia and Professor Martin Johnson, although Binghai was my group leader. And this is the first time I joined in an experimental group. Very few of them are working in theory. All are experimentalists, and professionally they are experimental chemists. So it's a completely different thing, different language, different way of representing the same thing. So then I learned, okay, so this is the first exposure that how to speak to the non-expert audience and how we can make them understand what we are doing. To explain this thing to the known audience is very different than to the completely non-expert or non-relevant people in the other field. So anyway, and whole group is working a completely different thing, everything rather than the oxides where I basically used to work. Then okay, I just engaged myself and worked in a different type of oxides. So then this is the very new photograph. I would say the old wines in new bottles, because this is a kind of group photo or group lunch photo where all the old culprits are there, also the new batchmates. Bodhiuddha, Somojitda, Swastikadi is not here, Somenduda, and the Rishit, Anita, they are the new generation of the TSD group. This is, I guess, in a RDB somewhere. Swastikadi gave us the treat to all of us, and this is, I think, is in the same year in 2018. We went somewhere in the sector 5. I forgot the name of the restaurant. And this is also this is in Salt Lake, Fantasy something name. I forgot the name. Fantasy something. This is very much famous for the seafood. So we went there. This is a dinner time, and so these are the few memories. And currently, I am in IIT Goa, very new institute. You can see this is the kind of building we have. It's a temporary building. We are in a Goa Engineering College campus, and we are very small in group, small in number, in terms of the faculty strength, in terms of the student strength, in terms of the space, in terms of the electricity, in terms of the funding, in terms of everything. So, and some of men are not aware that Goa is, everybody is famous, but there is a IIT in Goa. Just I would like to use this opportunity to introduce that this is one of the 5 third generation IIT. And although we are not situating just as adjacent to the Goa beach, but it's not so far, around 1 hour drive from our institute to the all the Goa beaches. So you are all are welcome to our new institute, to my new. And these are the currently I'm working in a different type of quantum material modeling, and this is a small group with 2 PhD students. And we are also, as a department, we are also very small, around 5 faculty members are here. We are working in different directions, and with that, and mostly I'm working in a different type of quantum materials, like a correlated electronic structure of the correlated oxides, quantum magnetism. Recently, I started working on the topological phases, different exotic topological phases, starting from the wild and topological insulators, and also the 2D material and the heterostructures. With me, these are my 2 PhD students. With that, there are very few recent activities we are doing in our limited resources. Professor Tanushree Shadaskar visited us in 2020. She is giving a kind of colloquium. Time by time, many of the faculty members of the different places visited us. We organized a small conference. It's a recent trend in the condensed matter and material sciences with the association with the Goa University, and regularly we used to conduct, say, outreach program which is called the Goa Physics Meet, combining all the institutes, all the academic institutes residing in Goa, Goa University, IIT Goa, BITS Goa, all are together. We are coming in one day. We are discussing science, exchanging our ideas. So these are the few activities we are doing at IIT Goa. So with that, I'd like to thanks or the special thanks few members or the few members in the SN board. Swastika di Somajita, there is no need to explain all this thing. Devmala, although is not our group member, but most of the time I spend discussing everything, starting from the academics, politics, sports, food, everything. And sometimes we spend overnight sitting at the just stairs in the main gate. One day I can remember we just discussing after the dinner, and it's sometime after some time we recognize that it's almost 4 a.m. in the morning. So all these things are the special memories with and none means Mukulda is always there. Even today, even last year we made it in a conference and we discussed many things apart from the direct scientific discussion. All kind of advice, suggestion, we always there, that we can anytime write to Mukulda, or you can call to Mukulda that okay, this is the thing, can you give a suggestion. So with that, I'd like to end. Thank you.
Thank you very much. Thank you very much for your so I think if there's any comment, we'll take it. Any comments from online participants?
I think they are writing in chat box. They're writing something in chat box. So if you save the chat messages.
Yeah, Tomistre wrote some writes something.
Many people wrote many.
Okay.
So please save the chat box. So that people can read afterwards.
So Dita, please check your chat box and.
Yes. Tomistre wrote, yes, Swastika, you are right about the Silver Jubilee Hall. I remember giving the oral presentation in the year 2013-14. Must be 10 to 11 years ago. And she also wrote, and I had a similar feeling during the power cut. You are not the only one.
Okay, so
Yeah.
I think.
Thanks once again. I will be there to meet everyone.
Yeah, please do come. So let's move on to next speaker, Dr. Devasi Chaudhary, Associate Professor at IMB Bhubaneswar.
Hi, hello.
Yeah, we can
Okay,
hear
can you hear me?
Yeah, sure.
Okay, good. So, thanks, Professor Manoranjan Kumar, and like particularly Manoranjan and Sunandan, they took special interest and called me. That's why I did not miss the email, which went to trash file by due to the IUP server. So it has been a long day. Thank you all for staying back. So I'm Debashish. I work in Institute of Physics, Bhubaneswar. So first I'd like to share the screen. I hope the entire screen should work. So can you see my screen?
Yes.
Okay, great. Yeah, so let me briefly outline what was my word line between starting from SNBO Center and where I am right now. So I was in SNBO Center from 2001 to 5. So during, or 6 rather. I went there in 2001 to work with Shurajit Sengupta. He had been my supervisor, a mentor, collaborator, a friend, philosopher. He was a guide in all sense, and we really miss him. I went there in 2001 to start working with Surajit, and I think I was the first student who joined him, first PhD student. And so it was a really fun time, had many interesting uh, introductions, fun stories, which would be nice to share, but I think we are already pressed with time. We should not spend much time now. Maybe later, if I get the opportunity to be in SNBNCBS in person and during similar events where these opportunities come, maybe I can share some stories if somebody is interested. But it has been a fun time. It was an interesting time, and one thing I always also remind myself whenever we start to deviate from what the purpose we are for in research institutes. So Surajit used to tell me that remember why you are in a research institute before getting involved in things which are not really the purpose for which you had been here. So these words come back to me because we keep on deviating from the basic reason for which we have chosen to take this path to do research and come to research institutes, academic institutes, teaching institutes, and do our work. And to extract fun from doing the research we do, extract fun from trying to learn about what nature does. So, yeah, so that was interesting, and Surajit, I feel, was a person who had been always taking pride and interest and fun from doing his research activities to figure out what is happening around us. And also, like, he has multifaceted interest in things apart from doing physics. Anyway, so the area in which I worked with Surajit, and Surajit's main area of interest was soft matter. I just gave this the cover page of this book for any interested student who has not seen this book. It will be interesting to have a look at it. So this is for the student audience if anybody is here. So during my PhD, I worked on colloids and polymers, two major aspects of soft matter. So, I mean, I also should mention that Surajit's the free hand he used to give. He used to always say that, okay, so you can do several things, but just keep me in loop that I should be knowing that what you are doing. It should not be a case that I get to know from somebody else that you are working on some third project which I am not aware of. So whatever you are doing, just let me know, and I'll be always helping. If possible, I'll help. And he really helped me doing several things. We were working on colloids, saw some certain interesting features where confined colloidal solid was undergoing a phase transition via formation of defects, and we are discussing that these defects will probably give rise to capillary resistance, so resistance due to at the phase boundary. And then at that point I said that, okay, I would like to go to Bangalore to work with Abhishek Third. I knew that he was working on heat transport, that we could look at heat transport problem here. And he said, okay, you go and do this work with Abhishek and come back. So that was, of course, I expected that from him, knowing him by that time personally, that he was that kind of a person. After I came back, he said that, see, there is another interesting thing we can do, that on this system we can look at, on this system actually, what I'm showing here, on this system we can look at also electrical transport. So I had a chat with Tanushree. She is interested and she would like to do this work. So that gave me this opportunity to do, I mean, I did not do much. This was Tanushree, this project, along with her PhD student. But they did this work on the system to look at the change in current as the system undergoes phase transition. And it was interesting that we could see that similar behavior for heat transport, and that's similar kind of resistive behavior also was shown up in electrical transport. And this is like due to Surajit. He did that introduction, he took up that idea. Okay, so then also I looked at polymers, and initially the polymer work I was doing with Abhishek. Abhishek was in RRI Bangalore, and so a part of my PhD thesis was work done with Abhishek, and the major part was done with Shubhajit on colloids. So that was my SNBOS story. In 2006, I left SNBOS and went to MPIPKS, Max Planck Institute for the Physics of Complex System in Dresden, Germany. I think some of the previous speakers have also mentioned about PKS. This is the institute. So I went there, did some work on biophysics, particularly modeling neuronal bundling in a system of neurons which keeps on wiring and rewiring and degenerating, regenerating. It's a, I mean, it's not as other kind of neuronal circuit which are built at the beginning of life, first few years of human life, and stay there for rest of the life without much change. This is something which builds on, and this is a steady state formation which remains in our system, and which has this birth of neurons, growth of neuron, connection, and then death of neuron. So typical lifetimes are like about a month, 7 weeks, 8 weeks. That's the typical lifetime of these neurons. And still they give rise to very precise connection, very precise sense of smell, etc. So we are interested in that. We are trying to use statistical physics modeling to try to understand this. Then I went on from 2009 to 11. I spent my time in Helmholtz in Amsterdam. So there we are looking at chromosome organization, particularly in bacteria. So I'll just give a brief outline. So bacteria, you can imagine that it's kind of cylindrical cell in which there is a huge DNA chain. The length scales are, this bacterial length scale will be around 1 micron, and these are like meter length scale. So these these are millimeter length scale in bacteria. So it's a huge, at least 1,000-fold of compaction one needs to have for this DNA to be encapsulated within this cell. And then there are important biological questions that if there is so much compaction, then how can the different parts of the DNA can express themselves, in the sense that DNA produce protein, how protein production keeps on going due to, I mean, that question comes because it's a huge compacted structure. And then also, what are the compacted structures? So we used some soft matter polymer physics principles to predict that this DNA within the bacterial cell should show emergent helicoid shape. Which in a couple of years' time, so this prediction of us was done in 2010-11, and then in a couple of years' time in 2013, Nancy Kleppner's group figured it out in E. coli. So they actually observed such a helicoid shape. So that was kind of small positive story coming out of some long research. Okay, so then in 2012, I returned to India, joined IIT Hyderabad, and taught there until 2016. In IIT Hyderabad, so I deviated a little bit to a new field, the stochastic thermodynamics. So, and we did some work on stochastic thermodynamics of active matter. This was sort of the beginning of the work on active matter and stochastic thermodynamics ideas. That was the first time people were developing it in active matter, and so that gave us some traction, because we started this thing, and then also kept on working on chromosome organization. various other aspects of that. And which, okay, so, and then in 2016, I came to Institute of Physics, Bhubaneswar, where I'm now. I mean, I work there now, I'm not there at the moment. Okay, so there, our group's research interests had been in active matter, which is a field between soft matter physics and biology. Chromosome organization remains an direction of interest. Cell membrane and its dynamics in presence of active intracellular mechanisms, for example, the actin-myosin cytoskeleton, how they influence the cell membrane and what are the emergent dynamics of the membrane, and also dynamics of the membrane-bound proteins as a result. So crosstalk between the two. That's one direction. Another direction of our research is cytoskeleton, and particularly artificial cytoskeleton assays. These are the different things we look at using statistical physics theories. Another connection with recent connection with SNBNCBS Center, former PhD student who Biplab, who worked with Mannada, and then after his PhD he came to IOP and spent a couple of years, pretty fruitful couple of years, did a postdoc in IOP and did some interesting work in active matter. Now he is in Raiken, Japan. And so then finally I come to this slide. What are the special gifts of SNBNCBS in particularly in my life? So first thing was the training, academic training that we had. And second, very, very important thing is the number of friends, a large number of friends with whom we are still connected and we enjoy our interactions, often visit each other. So I'll not take anybody's name because there's a huge list. I'll be surely missing somebody and will be naming somebody else. So I'll not do that. But then there are a few friends who turned collaborators later on. For example, Abhishek Chaudhuri, who is in ISAR Mohali, had been a very long time collaborator, and we had been working on several projects together. We have a strong overlap of interest. And then later on, with Dipanjan, I had been working on several problems, and many of his PhD students are also working on these projects together. So this had been a fruitful collaborations, and this is going back to SNBNCBS days. This is happening because we spent interesting, enjoyable time in SNBNCBS. Okay, so then these are the people who are involved. The people in left are like Abhishek, Surajit, then Martin and Bela had been my postdoc supervisors. Fernando is a friend and a collaborator, and Srini, who is in ISAT, is a collaborator. He is an experimental biologist. And this is my group few years back, and some of the other students who are working now, Chitrak and Arpon. Shubhendu is a postdoc working here now, and these two other master students who worked with me and did some pretty interesting work. Okay, and if anybody is interested, this is my web ID, and I would like to take this opportunity to announce that this is small advertisement that there are 3 postdoc positions in statistical physics at IOP at the moment, and if there is any potential candidate, I would invite you to directly write to me, or you can have a look at the IOP website and send your application as soon as possible. So with that, I would like to thank again the organizers and the opportunity SNBNCBS Center gave us to build our career. So thank you.
Thank you, Dr. Dev. I think now let's move on to the next speaker, Dr. Srinandan. He's an associate professor at our center, our colleague.
everyone. It's a long day and it's the last stop, this alumni speech. So first of all, I would like to, so this is the title of the talk, borderline. I think I will not have much time to talk about my research directions, but I will just say some words about it. But first of all, I must say that it is a pleasure to meet all the old friends. Like Vivashita was talking just now, Shubhankar was there, Muthu Kobil was there, and many more people. Abhishek Chaudhary, Abhishek was not here. I can see many people here. Dhaka, Rustika, Ono, Shurab has just left. Vishwajit was there. So it's really a joy to see all of us again here, sitting here. Also a joy to see that, for example, in some way, myself and Professor Indu Rajput are also entangled because we are the same as well as the director, Madam Sridhi. So we are all entangled because we belong to the same place. We have done our PhDs from here. And not only that, I had a map of going places which started things for the first time. For example, I was the first batch of this IPhD integrated PhD course in SNBNCBS National Center, and that started in 2001. So my association with this center is for around 20 years now, more than 20 years. And I was the first batch here, and we were supposed to be very bright students because in the offer letter it was written that you are quite bright students and therefore you are being accepted to this place. I don't know whether the same kind of offer letter is given nowadays also by instruction if the students are bright. But I always it was written elite. Elite. So it was a sense of pride because I considered that okay, I am going to a place and I am being considered in that place as a very bright student. So it was a sense of honor. And we were 9 of us here in the first batch, and supposedly all of them probably did their PhDs in experimental physics, but I was the only person doing my research at SNBNCBS National Center in theoretical. And all 8 of us, we were sort of outside the SNBNCBS Center because at that time we had some flexibility to do our research in the centers that are close by, that are nearby, the important centers like cultivation, trials. But I was the only person who did my PhD in SNBNCBS National. And of course, you know that my guide was, my supervisor was Professor Vishwajit, and I was fortunate enough to be taught by a faculty group. I used to take a lot of pride because I used to say that I am being taught by people from IIT Kanpur. Because the people who teach us were Professor who belong to IIT Kanpur, at some point of his career, Professor Jayanto Kumar Bhattacharya, he also belongs to IIT Kanpur. Professor H.S. Mani, it was fortunate for all of us in him because he was the director of HRI at that time and he retired from the director post and he came back and he came to Calcutta. Professor H.S. Mani is actually a person who belongs to Tamil Nadu. But it was strange enough that he came back to Calcutta to join the SNBNCBS National Center. And what was the reason? The reason was quite simple. I was also being taught by a person who was not from IIT Kanpur, and he's a legendary teacher. Not only a legendary teacher, also very good researcher. He was Professor Vinay Dutta. And Professor H.S. Mani and Vinay Dutta, they were the best of friends. And so Vidya told H.S. Mani that you come here, and H.S. Mani was also influenced by Professor Dutta. He was also my teacher. And so it was really a very nice experience to have all these great teachers and to be taught by these great teachers. And 2 other people who also taught me, and one of them is sitting here. She is now the director of this institute. Professor Tulsi Shah, she taught us quantum matter physics. And I was also taught by Professor Sanjay Kumar. So these were the 4 teachers that I had during that period. But I was not fortunate to have the Linux man. So he was another bright person, and he, as someone in the morning said that he is being termed as the Linux man of our center. He used to be termed as the Linux man of of our center. And I knew that he's a very bright person, but I was not fortunate enough to get a lecture from him. And so I tried to fulfill my wish at a very old age when I was
So Nandan, you are not audible. Is this me only or other
No,
online
it's all
participants?
static. It's all static only.
Oh, okay.
Yeah,
Dave,
in the
and I
static.
got hold of his notes, quantum field theory. And I knew that those notes were taken by Ramda and were taught by Professor Lahiri. And what I used to do, I just used to naively copy them because I was just in joy when I used to see those mathematical equations. I just had the pleasure of just copying them without understanding anything. So this was another story, and that was long back when I was a first year or maybe first year MSc student. And then, of course, all of you know that I joined as a PhD student with Professor Vishwajit Chakraborty, and he was a very nice man in academics, but he was a little bit problematic in some other areas. I will tell you why. See, I have a knack of singing also. And today also the director madam has ordered me that you have to sing a song. So okay, I just obliged that okay, I do that. But in those days, what used to happen is that all my seniors used to say that okay, Shravan, you come here and just sing a song. And I was very afraid to sing a song because I was a blind fan of Kishore Kumar. And Kishore Dada used to sing most of his songs are Hindi songs also, but it is not only Hindi songs, he has also sung Bengali songs also, if I did Bengali songs. But I was a blind fan of this person. And I used to sing Hindi songs. But I knew that my supervisor is completely against Hindi songs and should not sing Hindi songs. So I was very afraid that I will be caught at some point, and indeed one day I got caught. And it was a terrible experience at that time. But later on, we consolidated with each other, and he said that okay, you carry on with your music. There is no problem. So it was something like Deyane. You remember Uttam Kumar's story that his father used to be very angry that you should not sing. Singing because those who sing they are not good people. So it was something. So common with you. So it was something like that. Then in 2006. Something very good happened with me because I met a person, and that was obviously through my supervisor, Professor Chakraborty. He was Professor Frederick Scholz from South Africa, from Stellenbosch University, and that was a very nice thing that happened to my life because I learned a lot from him. I learned obviously a lot from Professor Chakraborty, and I also learned a lot from Professor Frederick Scholz. It was a very nice opportunity because I spent. Being a theory guy, I spent 1 month in South Africa during my PhD time. That usually does not happen with theory people. I was fortunate enough to spend a month during my PhD time in South Africa with Professor Frederick Scholz. And another very nice thing happened in 2006. I met my better half. So that was something, and that my better half is Dr. Srimoy Ganguly. She was a student of Professor Abhijit Mukherjee. And in that sense, I became a son-in-law of Professor Abhijit Mukherjee. So you can understand that. So I got entangled with Professor. I was obviously entangled with Professor Mukherjee because he was my teacher. But when we bonded, when I got bonded with Srimoy, I also automatically got bonded with Professor Abhijit Mukherjee and all of his groupmates. So this was a very nice experience in my life that occurred in 2006, and we got married in 2010, and we are now happily married for 12 years now. And hopefully, I hope that we will be happily married for. So in the future also. And then I completed my, I hope she said that you should tell me the time, but I didn't tell her the time that I'm talking at this time.
But she has a program.
But she has a program now, but I think she's online, she's listening to me. So anyway, and she told me once I go back. So then what happened was that I completed my PhD in 2008 and I was offered a postdoc. I mentioned in the beginning that I had a knack of going to places which started things for the first time. So I was offered a postdoc from Stellenbosch University, and this was a new research institute. It was termed as National Institute for Theoretical Physics, and it was inaugurated by Professor Stephen Hawking. He was there in person. He came there and inaugurated it, and also Professor David Ross, who was already a Nobel laureate at that time. Both of them came to the place and they inaugurated the place, and I was the first postdoc there. And obviously, my mentor there was Professor Frederick Schwartz, and we had a very nice time. I was offered a postdoc for 3 long years, and actually, Frederick told me that if you want to stay here, you can stay here for a longer time. But I told him in a couple of months that I got a job in West Bengal State University, Barasa, in the physics department. So I disheartened him completely. But he was not disheartened. He said that no, you should go immediately and take the job. Even though I offered you a post for 3 years, and you are here for 4 months, but you go there and take the job, you can come back later. So he gave me that assurance, and I came back and joined the Department of Physics, West Bengal State University, Barasa. Once again, this was a new university. And I had the knack of going to new places. It was a completely new university. There was no building, nothing. So I joined the Barasa Government College first, and then I shifted to the main campus. And there I had the fortune of getting a very nice person as my senior colleague. And coincidentally, he also has a connection with Director Madam and Professor Indolash, and his name is Dr. Vivash Bhattacharya. So once I joined in 2009, Vivasda joined, and it was a very nice experience because Vivasda actually loved me a lot, and we used to have long discussions about physics, about general, about life and everything. And then after working there for 4 years, I again went back to Stellenbosch University, and this time as a visiting academic for 1 year. And there I worked with Frederick for 1 full year. It was a very nice experience. I came back, and then I applied for an assistant professor post in IISER Kolkata. And immediately IISER Kolkata just told me that you don't need, I was fortunate enough. They told me that you don't need to give a job interview. Just straight away come to the interview. You don't need to give a job talk. You come to the interview. I went to the interview. I got the job within 10 days as an assistant professor. The funny thing is that I didn't want to shift from Barasa. I thought that I would stay in Barasa and I will not take up the job. But somehow I took the job, went to IISER Kolkata, and then after staying in IISER Kolkata in 1.5 years time, I got an opportunity from SNBNCBS National Center, and I joined as an assistant professor in SNBNCBS National Center in 2017. By the way, in the meantime, I was an visiting associate in SNBNCBS Center from 2009 to 2012. So I joined here in 2017 December, and then I again applied for an open post, which was advertised for an associate professor. I applied for that, and then I got that position as an associate professor. Until now, I'm an associate professor. So this is in the Department of Theoretical Sciences, and I'm proud to say that I have worked with almost all the theory people in this center. For example, I must mention that my supervisor is Professor Vishwajit Chakraborty. I worked quite a lot with Professor Rubin Banerjee, a lot. Also had many nice experiences because we shared a lot of funny stories and many such incidences I had with Professor Rubin Banerjee. When I joined here, I was fortunate to work with Professor Amitabh Olai. This was a completely new experience because his style of doing things was completely different than what I experienced with Professor Chakraborty and Professor Banerjee. So I learned a lot from him, and then I also got the opportunity to work with Professor Archon Muli. Well, in a sense, I worked with all the theoretical branches of this center. So this is something very satisfying for me because I consider myself very fortunate about this. I think I have already finished my time. I will just take 2 minutes to just tell you a little. So this was all about my world line. And now I'll just quickly come to my research directions that I've been pursuing. My main, the thing that I've been doing from my PhD days, that is sort of bread and butter for me, is quantum gravity phenomenology. By quantum gravity phenomenology, I mean that I've worked in non-commutative geometry and generalized uncertainty principles. So you know that quantum gravity is an unsolved problem of theoretical physics, right? It's a mystery. Why? Because you know the two great theories like quantum mechanics and gravity, and they do not merge with each other. The simple reason for that is that the theory is not denormalizable. So what do I mean by denormalizability? It is that when you do quantum field theory, you will encounter things which are divergent. But those are completely nonsensical things. But quantum field theory, denormalizable quantum field theories are those theories where you can make sense out of nonsense. So that is what denormalizability is. But here in quantum gravity, you cannot make sense out of nonsense. Those things are really nonsense because those are divergent and you cannot control those divergences. So a way to do that, a way to understand quantum gravity phenomenologically is non-commutative geometry, which I learned through my supervisor, Professor Chakraborty. And then I tried to explore other areas such as generalized uncertainty principle. And this was non-commutative geometry. This was during my PhD days. And then I tried to explore something on my own with one of the students of Professor Rabindranath, who is now a faculty in IIT Roorkee. And this was ATS-CLT correspondence. And this, I feel that this is the greatest development at least at the end of the last century. It was developed by Mallasena in 1999. And it was one of the beautiful things that Mallasena had developed in 1999. And it is called the ATS-CLT correspondence of the gauge gravity duality. And it actually tells you it has a lot of potential. It aims to solve strongly coupled systems and also tell you many things about quantum information theory, physics of black holes, and information loss paradox, which is one of the beautiful paradoxes that Stephen Hawking has proposed. Information loss paradox. You can address everything, all of those things, to this ATS-CLT correspondence. And then I have also been looking at physics of black holes. And here you have the famous area law. Once again, Hawking's name is come because this area law was given by Stephen Hawking and Wittgenstein. And then corrections to the area law. So the area law is the entropy of a black hole goes as is proportional to the area of the event horizon. But then you can have quantum gravity corrections to it. And then I also try to explore thermodynamics of black holes. And later on, when I joined this center with Professor Lahiri, I tried to look at the implications of asymptotic cell gravity in cosmology and quantum optics. So these are some of the things. Non-commutative geometry, those of you who are curious about non-commutative geometry, you can. So this is why I say this quantum gravity phenomenology, because you just start from this bracket and then you develop your physics. And this is the generalized uncertainty principle. You see that the usual Heisenberg uncertainty principle gets corrected by this term. It's a gravitational correction. And this was actually first proposed by Bronstein, who was actually killed, murdered at the young age of 30. And so he is termed as the father of quantum gravity. And what I have done is explore the consequences of these structures in black hole physics, quantum mechanics, gravitational wave detection. In particular, I've been trying to find bounds on this parameter theta and theta. So with this, I would like to end my talk. Thank you very much.
Thank you very much, Nandan, for the very nice presentation. Now I think we are quite late, running late, so let's question with us, and there will be online participants. They might be waiting for this panel discussion. So I think we'll skip the. Yeah, after the panel discussion, we can have the tea. So let's start the panel discussion. I'll request moderator. Yeah. So I to take over the session.
Good afternoon, everyone. It has been a long day, and thanks to all of you who have stayed back till the end, especially the online. I think online people are all there right from the morning. They are much more dedicated. So the last week of the program, before the cultural program, was the panel discussion, because we are having this alumni meet, and there have been many suggestions. Many very, very useful solutions, I would say. So we thought it would be good to have a panel discussion in terms of discussing what is the way forward. We had this alumni meet, and as you know, in many institutes, alumni play a very big role. We have all the connections, they themselves are established. So in some way, there should be a feedback mechanism. So maybe I call up on stage the panelists who are online, and I will request the offline panelists, once I call their name, to switch on their video so that I know they are there. So maybe we can just three panelists offline, they can see. Professor Raka Dasgupta.
Not even.
And from the offline, we have three, we have four, three from Sweden, from Uppsala. Professor Biplab Chandal, are you there? Professor Biplab Chandal, are you there? Can you please switch on your video?
Hello.
Biplab, are you there? Biplab, are you there? This is Sakati Sharma.
Yes, hi, hello.
Hi, can you please switch on your video?
Yes, my video is on now.
Oh, your video is on. Yeah, we can see you now. Venkat, are you there? Can't see Venkat.
My video is on, Tanushidi.
Okay, you have to probably click on them. Somehow they are disappearing. And Shubhradeep? Professor Shubhradeep Ghosh? He was there in the morning. I don't see him now. Is he there? Shubhradeep, can you switch on your video? Shubhradeep? Can you hear me? Can you hear me, Shubhradeep? Might be. His microphone is on, but so let's get started because the time is running. So the plan is the following. I will first request each of the list to say a few words, maybe for 5 minutes, so that what are you we will basically open it to the audience because I'm sure there will be many suggestions, many comments. So I start with the junior most. Junior most is Raka. So maybe I start with Raka. Yeah.
Thank you, ma'am. Yes, so after you said that it's a long day to read that, but I feel much richer and rejuvenated after coming here. So I was just thinking that, of course, the institute, we need such alumni meets, and maybe we need to increase its scope, like some full-fledged academic conference kind of thing where we not only talk about our journeys, but we can make meaningful exchanges in terms of our research and teaching also. And since this COVID situation has taught us that geographical barrier is not that much important. It cannot be a hindrance anymore in terms of academic discussion, collaboration. Maybe we can set up something like a virtual dashboard kind of thing where people can share put up important information, just like some ads that just like I saw maybe Debashita was showing some post-op opportunities. This kind of thing, I think the more amount of information exchanged among the alumni and also the present students, I guess it's good for all of us. I think some online activities can be maintained in this regard. And also maybe we can, have a full-fledged alumni association where people, alumni can donate, they can set up a fund for holding conferences or providing some stipends to some summer students or things like that. If someone wants to come and help the, to the be of help to the alma mater, and maybe we would be to get the discussion ball rolling from the year. That's what I think.
Yeah. So before I go to the online speaker, so maybe let's finish with the offline.
Yeah, I completely agree with Raka that there should be a full-fledged conference for this alumni meet. And in full-fledged conference, what I think is that it would be very nice if we can have partition that conference into departments. So that would be very nice. Then people will be interested more in the partition. And I also wish that in the next alumni meet, there will be more participation, more people will come offline, present in person, and but there is obviously a problem in for people to come here in person in a very short notice. So it would be very nice if we can intimate them maybe 2 months before, so they can plan everything here and prepare their talks, plan their journey, and come here, stay for 1 or 2 days, and give their presentations and go back to their research. And regarding the point that Raka mentioned, that it would be very nice, obviously, to have some alumni fund, and also if we can provide some membership to our alumni people. For example, if we can provide a membership for them to come and access the library, they can come here and access the library. And this also we were discussing in the meeting. We can also raise this point. So we can arrange for that. So we can just maybe we can make our alumni life members kind of thing. We can organize something, some association, and there we can. And for that, maybe obviously we have to charge something, maybe some life membership charge, maybe 3,000-4,000, and it is not that much of the money. And we can raise fund from time to time. That would be actually great. So I think this
is a very nice suggestion.
Yeah,
maybe not only library, maybe also the communication facilities. That we can share.
The guest house, computational facilities. Absolutely. People can share the computational facility because we have a very nice computational facility here. So we can actually.
Who don't have that kind of facility can become a member and.
Yeah, sure.
Thank you. So now the oldest.
Yes, so I'm maybe the oldest. I don't know what I should add to this. I think Sunandal and Raka has already said. I guess I'm audible, right?
Yeah.
So the first thing is what I believe is alumnus are essentially ambassador of an institute. So this alumni thing should be taken very seriously, And the first suggestion would be that why don't you have a very good database of the alumni? So this is first thing, and which is not done in most institutes. And I'm saying this from my experience from an IIT, where alumni happens to be one of the very important component of the institute. I think all our alumni are scattered all over the world. Right? A very good database of these people should be produced, and this should also be advertised in our website, what they are doing. And that will also attract good students, right? Each one of us should have a feeling for the institute, right? Our alma mater. So I think this is first thing, if it is not done, should be immediately taken up and should be done. A. B, of course, nothing works if there is no money, right? So, and I think this point was emphasized both by Raka as well as Shugandha, that alumni should also contribute something. And the way I can tell you my experience, the way it happened with me in IIT Kanpur was when I joined as a master student in IIT Kanpur, I used to be considered caution money, right? But when I left, then I was requested to donate that caution money to the institute, which was not a small money, but also not negligible, right? And that way, if people contribute, I mean, then possibly one can accumulate a substantial amount of funds. And then to keep a contact, I think SNBNCBS every year brings out this a little, I think, a flyer, right, about this thing. And this gets newsletter, right? I think one can say to the alumni, so that they also remain connected with the institute, right? So they see that what is happening in my institute, right? Again, this is the experience we borrow from my previous institute, so I think this can be very easily done. Third thing is, of course, I think one of the mandate of the center is to provide a collaborative platform, right? Why not invite alumnus, right, into a collaborative platform? They can collaborate with the research groups here. Or of course, this will be based on selection based, right? I don't think you can offer that to everybody. But alumnus can get priority as far usage of the library is concerned, as far computational facilities concerned, as far as lab facilities concerned. Maybe some of them are working in different, some of them are working in a college, right, where they teach. But if they get an opportunity to do some research in the summer, why not? Right? So give them, for example, DST is a scheme for a TARE, right, where you have to apply and get such a thing. But institute can offer such a TARE kind of a scheme to its alumnus, right? So that you can spend your summer and do some research here. And I think that also happens to be one of the mandatory institutes, if I remember correctly, right? So one can exploit that. And of course, I think also we should mobilize our alumnus to have a permanent position abroad, right? Particularly, I think it's always a good idea that people, they do their PhD here, they should also get the exposure to go abroad and do a postdoc. I'm not saying mandatory, but this is where these people can essentially help us, right? What opportunities are available, often is not known, right? So this is something which I guess our alumnus who are working abroad can help us. And I think this all should essentially make the center rich. I mean, I'm thankful to the organizers for organizing this meeting. And also I would request that at least alumnus who are in Kolkata or in India, why not invite them to give a talk at times, right? I mean, I was invited some time back, and then I was invited after a very long time, right? I left this institute in 95, right? And I was invited in 2022, right? Also I was hanging around here and very much visible, right? But I guess that this should be extended to everybody, right? I mean, and now the good thing is that since you have this online platform, right? If Raka, for example, is invited, if I cannot come here, I can hear her online, right? So this is something which I guess centers should take, particularly people who are organizing colloquium, and they of course invite others, but maybe a couple of alumnus can be invited to our faculties in other places. Well, with this, I think again, thank you for this opportunity to come and share some ideas.
Thank you. We now go to the online panelist. So Viplav, can you hear us? I'm not sure he is there. Coffee?
Are you audible?
Yes.
No, Viplav is very much there, Tanushree.
But he is not saying anything. So how do I know he is there? I can see him, but he is not saying.
He opened his mouth couple of times, but then got drowned by others' voices. I can see him opening his mouth, trying to say something. So Viplav, you can speak probably.
it is told to open out the lot of meeting.
I think he is frozen. His video and his connection is frozen. If you have his number,
Okay, I think he will get back soon.
Yeah.
He will get back soon.
So by that time, can we request Shubhradeep since you were there?
Yeah,
Can you share your thoughts?
Biplab is back, but
Can you hear us?
Biplab, we cannot hear you. We cannot hear you.
We can hear Shubhradeep. So Shubhradeep, why not you start?
Okay, all right.
Leave, you told us.
All right, yeah. So basically what Sunandan, Raka and Indroda covered, basically all the points were covered. I just want to add one extra thing is that yes, the alumni database need to be prepared. As Indroda said, it's in IIT Guwahati we are facing the same problem. It's very difficult to maintain a proper, maintain, even to construct a proper alumni database. But with research institute like SNBNCBS, probably that is possible. So the first thing we can do to start, to roll the ball, is get the email addresses of all the participants today in this meeting and circulate. Okay, so the building up of the database can start from there, and we can think of building up a database and announcing all the programs, any announcements to the alumni. And maybe, I don't know, these days are social media days, so we can sort of have a alumni page as well, where all these announcements can be made for people to see. These are the two things. And apart from that, yes, targeted conferences, small meetings with alumni participation can be a good thing, particularly for the young researchers, the pre-PhD students. And on top of that, I would like to suggest that if SNBNCBS can take initiative or is interested to have MOUs with institutes where the alumni are situated. For example, I had no idea about all these things, that there is already a MOU with ARIS and there is one with IIT Bombay. See, for IIT Guwahati, in physics department, we have 3 alumni. One in astrophysics, one is cosmology, one in computational material science. So that gives a wider spectrum, and I think we can easily work something out. So if we have such memorandum of understandings with institutes where alumni are placed, SNBNCBS can cover a bigger spectrum. So these are my suggestions.
Thank you, Shubhradeep. So we will take up these comments after the panelists are done. So may I request Kapati, because your microphone was working.
Yes, can you hear me?
Yes, yes.
Yes, first of all, thank you really for inviting me for this. And Tanushri in particular, because he sent me that personal message. And I have to confess that I have not been a good alumnus. I have not been in touch with the SNBNCBS Center much, and especially after the COVID, when I have not been able to travel back to Kolkata as much as I used to do before. But these kind of meets, the today's meet that you have organized, it is really so good, and now that we have this hybrid mode, so it really no excuse to be apathetic anymore. And what Raka and Sunandan and Indroda and Shubhradeep and they have said, I totally agree that we need more such meets. From the perspective of being an alumnus, what I can just add is that we get so involved with our day-to-day activities that sometimes it becomes difficult for us to become more proactive and go back to the place where we learned everything. But human nature is such that if you tell us to talk about ourselves, we will keep talking. So this today's meet that you organized, where we could come and speak very briefly about our own journey, this I think is a very good starting point. And we should create a dedicated website where all of our contacts will be listed, and where we can also have online chats with the current students, because I think there is a lot of the alumnus has a lot of potential to guide the students that are there now, although things have changed a lot. When I was at SNBOS, it was really not as large an institution as it is now. But then we have crossed the paths that the new students will do in the future. We can share our experiences with them, and this, I think, if this connection between the current students and the past students becomes stronger, then both of us can benefit. So I hope that in the future we will have more such meets, and the hybrid mode will continue, so that even if because we stay so far away from Kolkata, that if the hybrid mode is gone, it will not be very easy for us. But having said that, I also want that I should be able to go there personally, because now I'm just getting half the experience, and I would really like to be there and mingle in person. So maybe next time. But thank you again, and it's a really good initiative. Yes.
Thank you, Kelvin. I think Biplav just messaged me that his microphone is not working. So he of course cannot say, but he will be able to write things in chat. So what I suggest, we take Biplav, you please type in your thing in the chat box. We'll read it out. So can we now move to Venkat?
Hello, hello. Yeah, I can speak now, but I don't see myself in the screen. Even though I can see my video here on the computer, but I do not see it there.
No, we don't see his video. We see his video.
I can see my video on my computer, but not there.
Can we try to pin him?
Is it enabled or yeah?
Yeah.
Hello everyone.
Yeah.
Hello everyone. Thank you, Tanushree, for this opportunity to.
See, you are in your office in Uppsala.
Yeah, I'm in my office.
Yeah.
Yeah. So I think it's a very nice effort. It was very nice. I was attending all the speakers since the morning. I tried to attend as much as possible to see who are there and what they are doing, and it was a very good experience. Actually, people were sharing their own experiences of what they have done. How was life in SNBOS some 20 years before? So that was very good, and that I think it is nostalgic. But I think that was one thing, and the other thing is it's a good idea to have a database of alumni, and then it's also good that people can actually ask for some suggestions when they're applying for postdoc positions, or how experience of working outside because all of the students that I've seen, all the PhD students, they have been in some places throughout the world, and they're also at different places in India. So this will be helpful for the new students when they are actually looking for jobs or going to present seminars or their work. This is a good network. That's what I feel.
Okay. Thank you, Venkat. One thing, since it has been mentioned by almost everyone, we do have an alumni page. SNBOS Center, if you go to the web page, there is an alumni page, and there is a database. Of course, the database is constantly evolving, and in that, making that database, I think the participation of alumni are as important as what we can do as an institute. Because most of the time you move from one place to another place, especially if they are doing their postdoc, their addresses are not permanent. Their email address becomes obsolete. So, in fact, please spread this. Please have a look at that web page and tell to all your friends to have a look at this database. And please email us if you think your name, with whatever way it is appearing, the affiliation should be corrected, the email address should be corrected. Please do that. Because for us, it's very difficult to follow the career path which one is moving. I actually found even in today's program, some of the affiliations, they have been outlawed. But we didn't know about it. So, it's a both-way thing. Otherwise, we will not be able to cope up with this database which is changing. So, Viplav, do you want to write something in the chat box?
I think he has written something.
So let me just read it out what he has written. The first thing he has written here, my microphone is problematic. Then his two suggestions, sharing experience of working in a university outside India will be interesting. So I think we should probably organize some kind of talk with the alumni who are working outside India. They can share their experience in detail. And online seminars given by alumni will be good, which was already mentioned by Indra, that time to time we should invite our alumni to give colloquium, to give seminar. This is a nice way of keeping contact. So now I can turn to the audience. So from audience, is there any suggestion, anything?
So I also said, tell me what to do, I will do it.
Yes. No, what to do in terms of this, making this alumni activity.
Offering all the help.
Yes, of course. So Vishnu, I think we will invite you for a talk so that you can share your experience, and that I think is a very useful experience.
You also make an announcement how much million dollars he can give us.
So people, so the suggestion is you should try make a commitment how many million of dollars you can donate to SNBNCBS. Anyway, jokes apart, is there any other comment? So any other comment from the audience, from the online as well as offline? Online participant, you can just unmute yourself and say if you have to say anything.
Hello. Hi.
I have Tanushree, I just want to add one point. This is Shubhrodip.
Yes.
Yeah, so for example, in July, there is a program in center organized by IPTA. I think this is targeted for BSc students primarily, maximum first year MSc. So if some alumni are around, you can, I mean, if there is a possibility, I know a lot of things is decided by IPTA itself, but these are like, motivational talks and giving some exposure about some area. So if some alumni can be included in list of speakers, so that way I think some integration, beginning of an integration is possible. Biplav, the IPTA is Indian Physics Teachers Association.
Yeah, we will keep that in mind. As you say, the speakers are mostly decided by them, but we will, convey them this message and request them to take it.
Yeah, because we had organized this in IIT Guwahati, and there are possibilities that they always look for the in-house speakers. That is why they organize it in a particular place.
Right. Thank you. And Aftab, you wanted to say something. Your hand is raised.
Yes. So just one quick suggestion. Good that we have a alumni database. There is a web page, I guess you said, right? And it is evolving with time. But I don't know how many research scholars or postdoc from SNBOs do get in touch with these alumni. So if we can, think of creating a platform which is more easily accessible, and these scholars and postdocs can ask their questions on that platform directly, that may be a good thing. I mean, these days we are in social media, so maybe a WhatsApp group where everyone is available mostly, so that the scholars can write their queries, the questions, and get the answers quickly.
Or maybe having a Facebook. I think there is already some SNB Facebook group, but I don't think the alumni are part of it. I mean, this is maintained by the current students. Yeah, so one can think of opening up such a Facebook group.
Sure. Okay.
Thank you. Any other suggestion? Online, offline, any other suggestion?
Maybe it will also be helpful nowadays. There is a thing like people are opening apps, creating apps. So if we can create some SNB alumni app kind of a thing, where everything, all post of positions, everything. So someone has to create that app.
So why not one of the alumni? You had a Linux man here.
That's what I was wondering.
So you need to have among your alumni app man. We will do that job.
Linux man can get started with it. Yeah. That was 25 years ago.
Yes, absolutely. We need young blood. We need young blood, and some of the young faculty, whoever is working somewhere in the computer firm or something. We also have many alumni who like that. Their probably main task is to make apps, so they can take up such responsibility.
I also have one suggestion in a sense.
Can you use your microphone? Otherwise, the online people cannot hear you.
So I'm just wondering, in this alumnus committee, what we have made, we should have a one person from the alumni also. They can join one person, so maybe 4 or 5 member committee, which monitors the whole year.
Personally, I'm very open to it. If you feel we should also involve some of the alumni, definitely that will be a good idea. But on the other hand, the alumni also should be proactive, because this is something where the drive should also come from the alumni. Of course, the center is very eager to keep connection with them, but they should be also eager to keep. The connection is built by both sides. It cannot be just one-sided thing. So I do request, please have a look. Now you have got a sense of it. Please have a look at the alumni page. Take a bit of your time. Now, tomorrow you have a Sunday. Have a look at it and post a suggestion how this page can be improved. Whether the database is completely obsolete or partly correct, and if there are changes, what are the changes you need to do? We have given, we have opened up a complete dedicated email address called alumni@post.res.in, but we never get any email from any alumni. So it's all one-sided. So that should not be.
Yeah, I think one more thing, what we should be trying, actually, I was talking to Abhitav, we should have on that alumni page, there should be one like a link where they can just register.
Yeah.
So now they should do a complete registration again.
Yes.
So that we'll have updated version of this.
It's a suggestion, and that is a very easy thing to be done. Very easy thing to be done. But again, spread this message so that people do get to the page and register themselves. Mukul, you want to say anything?
Yes. Yeah. So, one second, guys, to allow. So what I was suggesting is that, I mean, as you are also pointing out that it should be a two-way bridge between alumni and the institute. I would suggest that, like, rather than, I'd be very interested to look into the opportunities. I'm not suggesting that what institute can do for the alumni. Rather than that, I would like to see that where all the alumni can help the current students and the institute. I think like me, every one of us would be eager to help whatever possible way we can do. Okay, but this message has to pass across the current students that they can anytime approach any of the alumni, scientific, non-scientific, in any ways. And I know, and as I mentioned earlier, also a special thanks to Biplabda. Biplabda is doing a lot of things for a long time for many of the SNBO students. I think, like, I mean, not all of us would be able to do that in that scale, but I think, like, everybody of us would be willing to help the current students and the institute in whatever possible way. So if institute can come across a plan that where we can help, okay, it would be good to have that kind of opportunity, right? I mean, yeah, the first thing would be telling all the students that you can always approach any of the alumni about anything.
Yeah, I think this is definitely an important point, because in fact in today's meeting we were expecting many more current student participation, but their exam is next week, so probably next time we will choose the timing. Timing should be proper, so that the current batch of students are also kind of free to attend this meeting, because as you very rightly say, the current students should also know their alumni. So that was the whole idea. But unfortunately, I think PhD student exam is next week, and also for some of those MSc student there are exams. So probably they are receiving it. Next time we have to be this time. Is there any other yes. Please, but use your microphone. Yeah. You are in the committee.
No, but
it's all in your hand.
No, I mean, one more suggestion I have, Mr. Director of the Institute. So I would request you to create at least 4 or 5 visiting faculty positions, just like we have in the past. So there, like some of these faculty can come and stay there.
No, come on. We have an adjunct professor, an adjunct faculty, and I don't think we have ever said that alumni are barred from being adjunct.
But maybe
so just you nominate someone, and there is a committee, and our alumni are as good as any other professors, and they will qualify. So we don't need to have a separate channel, because we do have a channel. So they just needs to be nominated.
Okay, yeah, good. If we get it.
Yes, absolutely. 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 So in fact, from the alumni cell, if you think that there are some alumni who deserves to be an adjunct professor or adjunct faculty, from alumni cell itself, you can nominate some name, and then it goes to this committee which looks at it. And they just look at their CV and the recommendation from the current faculties.
Yeah.
That's it. So, are there any other questions? Yes, please. Arnav.
So, is it possible to extend, so both of the, like, these institutes has a post-basic program, right? Then the universities, ISAs, they also have similar programs. And everyone does these projects, master projects, I guess here also, there also, our universities also. So can we have some program to exchange, or some students, particularly project students?
But that has to be institutional level MOU or understanding.
Yes, yes.
For example, with Residency University, now we have signed an MOU where especially the project students, you are saying, they will be exchanged. But for that, you need really institutional level.
Institutional level.
Understand.
Okay.
So because otherwise, for example, Calcutta University may not like to send their student to us. Why
Yes, of course, of course.
So
what I'm saying is, alumni can, it's our actually.
you can take the
initiative to the, yes, yes, of course.
Absolutely. We have to be open. We definitely want bright students to come here and do their project.
Okay, and also the other way around, is it?
Yeah, it is
that
of
is
course.
right.
Once
Both
you sign
exchange,
an MOU, it's both.
both ways. Okay.
Absolutely. Absolutely. Any other comment or question? I see you have raised hand.
Yes, I just wanted to say one more thing because we have been discussing about trying to build a bridge between current students and ex-students. I think a very easy thing that we can do as a continuation of today's program is to organize some dedicated panel discussions on topics that will be of interest to the students now, like what to do after you have finished your PhD. And this is one question that every PhD student has. And yeah, it is very good if they come up by themselves and contact us. But sometimes we are shy. I remember when I was a PhD student, I would have hesitated just to contact someone who is abroad. But if we open up this kind of discussions like we are doing now, but on a specific topic that is of very relevance to the students now, that can be a starting point, and I think help the current students and give us an opportunity to do something concrete for our past institution.
Thank you. I think that's a very good suggestion, and I already see, like Biplab said, we will be coming in July. So please keep us informed whenever you are visiting, so that we can organize, such kind of, talk where you can tell the present batch of students in a much more detailed manner. Of course, it's the entire thing now compacted in one single day. So in that case, there can be a dedicated event where you meet the student, tell them what are the career opportunities. But please let us know whenever you are visiting. I mean, that is true even for the faculties and alumni who are not in Calcutta but outside Calcutta, but within India. Please tell us whenever you are visiting. I think we have more or less covered everything, and there are some very useful suggestions. And I request once again, please tell us about, go to this alumni page, have a look. Definitely, it needs to be improved a lot, but we need suggestions. Please post us suggestion in this email address, and this is a very good suggestion. We will create such a kind of, so that they have to register when they go there. That can be done, taken up to the center. But please send us. We want to hear from you. Unless we hear from you, we don't know how to really. Okay, so with that, I would like to thank all the panelists and all the people who actively participated in this panel discussion. Thank you once again, and I now give the mic back to Dr. Najla.
Well, okay. It's a long day and very fruitful and exciting day. We heard a lot of things. It's a time to thank everyone and thank profusely. So let me first thank the students participants in the organizing committee, the 4 students. They really worked hard, and it was very nice to interact with them. And then, of course, the committee members, faculties like Sunandan, Manoranjan, they also took more action than I myself. Being senior, I enjoyed some relaxation, right, Manoranjan? And then, of course, the support that I have received, the alumni committee received from Nivedita Kona. So a big hands to her, please. And she really did all the difficult work, extra work, and she really controlled her mood not to shout on everyone, although she wanted to. And then the facility persons like we are really indebted to keep this room functioning, running, electrical persons and the person who is actually managing the sound systems and also the ACs. And also our thanks to those who provided foods. I hope you all have enjoyed foods. And with this, I would like to formally end, but this bond that you have just started feeling from today, it was always there, but we just scratched a little bit, and it is now visible. And you can see the emotions because we could not stop you while talking. So we are good 45 minutes late. So this should actually thrive on, and we should be having many things in future, maybe a longer version of this, well planned and well ahead in time. Thank you very much. Thank you.